Hi everyone, welcome to Intellipaat live session of blockchain full course. But before we begin the session, please subscribe our channel. Now let's see the agenda. Firstly, we have introduction to blockchain and Bitcoin, types of wallets, centralized and decentralized networks. We also have cryptography, transactions, then transaction life cycle, Ethereum and Solidity, platforms for implementing blockchain, and at last, blockchain interview questions and answers. So, guys, this was today's agenda. Let's begin with session.
So what is blockchain? Blockchain, as name suggests, it is nothing but a linear chain of blocks. It is a digital ledger that holds information of transactions taking place over the web. So every block here contains data in the form of coding that is organized in chronological manner. So this is the simplest definition to understand what is blockchain. Let us now go through various features of blockchain that make this technology a strong contender for the top technologies in the near future. So this technique was originally described by a group of researchers in 2008 and was originally intended to timestamp digital document to ensure no one could tamper the data that had once passed through the server. So blockchain actually uses a decentralized structure to process the transactions. It created a peer-to-peer or a distributed environment with immutability. And all this led to the most important advantages of using this technology, and that is security. So it gives this security to your transactions. Now let's go through each of these in detail. Decentralized network. So what does it mean and what all advantages it brings along? So this technique is built on decentralized structure. That means it eliminates the need of a single or centralized system that would be in charge of all the transactions taking place across the network. Since there is no centralized system, there is no single authority. It has got a distributed authority and hence not a single entity or a person is in charge of everything. Due to this, your transactions get faster since it is a direct communication. And all this would eventually lower down your cost. You don't really need to pay the fee amount that an intermediary would charge you for lending you their services and giving you a platform. I hope it's clear to you guys, right? So let's move ahead. Now let us move on to the second feature, which is distributed network. Now blockchain works on distributed network. That is to say, every node in the network has got access of every block of information, resulting in bringing in transparency. Now since it is public and everyone has got the hold of entire network, hence it becomes nearly impossible to tamper with the data logged in a block. And if anyone tries to make some false changes into the already existing blocks, all the nodes would get notified of the same and the attempt of tampering would fall futile. So it verifies the attempt of changes in no time. This seems quite interesting, right? But how does it happen? So we'll see in the coming slides to come. Now immutability and security. Let's discuss these. Now blockchain is a technology that supports immutability. What does that mean? So it means once a code has been logged into a blockchain and passed to the server, it cannot be changed. And similarly, since the code cannot be tampered with, results are also the same and cannot be tricked. And hence, it brings you a sense of security. Exactly. For example, if some organizations has made a promise to you and if it is logged into a blockchain, then the organization could never step back and has to live up to its promises. I know this must be sounding just like a must-have feature to you in today's dual-phase environment, isn't it? So we saw one of the main reasons as to why transactions done through blockchain is secured. Now let us go a little deeper into it to understand it better. But before doing so, let us know what all a blockchain consists of. So a block has got number one, a hash. I'm going to describe it in a while. And then the data, and finally the hash of the previous block. Now hash is nothing but a fingerprint of a block, and any changes in the block would lead to changing the hash of the block, and hence making hash of all the following blocks invalid, since each block consists hash of the previous block. So hash does play a crucial role in the security, but again, in today's technologically driven world, creating a hash is not a big deal. And hence, just having a hash cannot stop a miscreant to tamper with your data. And that is why we have got another crucial concept in blockchain, and that is called proof of work. So this makes blockchain data almost impossible to alter. So this is nothing but the first consensus algorithm. Proof of work increases the time required to create a new hash and hence making the technology secured one. So before anyone can change the hash of entire network, nodes are notified of the tampering attempt and hence tampering becomes a tough task to perform, almost impossible. So now I hope that you guys must have got a fair idea about how this technology is so secure. Right, now let's move forward and see its applications. Bitcoin. This is the famous application of blockchain. So blockchain was originally conceptualized by Satoshi Nakamoto when he published the white paper Bitcoin, a peer-to-peer electronic cash system. So the first Bitcoins were mined in 2009 and thus was born the exciting technology of blockchain. So this is a cryptocurrency, that means digital cash, and digital currency which runs on blockchain method and has got limited supply. Now let's check out how do we actually implement blockchain in real life applications. Ethereum. It is again a blockchain which is designed specifically for smart contracts. So it is a sort of cryptocurrency and allows to transfer values in form of ether and also allows you to create smart contracts or code to be deployed to blockchain. So what is a smart contract? Smart contract is nothing but a digital contract that cannot be amended. Yes, you can also get detailed information about smart contract and Ethereum in our previous videos, link of which have been mentioned in the description below. And finally, we have got Solidity. So Solidity is a contract-oriented high-level language. So the syntax of Solidity is similar to JavaScript. So basically, you write your smart contract using Solidity language and then execute it on Ethereum virtual machine and do your blockchain transactions. Now I guess that you must have got a fair idea of what is blockchain and advantages of using this. Now let me take an example of a real life scenario to differentiate between a normal transaction and a transaction through blockchain. So let's suppose if you want to take some loan from a bank, what would you do then? So you definitely would go to a bank executive and ask for the EMIs the loan would incur you every month, interest rate, principal amount deduction, etc. And after going through all the formalities, you have been sanctioned your loan amount, right? But what if after a few months, bank increases the interest rate? What would you do then? So you have to anyhow fall in line with whatever the bank dictates, right? But if you had got this logged into a blockchain, the bank had to work according to the code specified into the blockchain for the entire tenure, which would mean no changes in the contract that you made with the bank while taking the loan. Relaxing, right? Now let us see how technically it works. So if you want to make a new transaction to an already existing blockchain, that is to say, you want to add a new block of data to the chain. So that block would actually get distributed to each of the nodes in the respective network. And then now every node would validate the authenticity of the block needed to be added to the chain. And once it is validated from all the nodes, then only the block would get added to the chain just like this. So if any nodes finds any problem with the block would get rejected. So it basically works on consensus. So after knowing its technical aspect, now let's take a use case of such a working mechanism. DAO, exactly. So it stands for Decentralized Autonomous Organization, which is a decentralized and democratic organization. So it actually eliminates manual intervention to the lowest level. And all the managerial task is replaced by a set of terms and conditions or values that are agreed by all the parties involved in the transaction. And then every term and condition are decided through voting. And the final documentation is then logged into a code which would be passed through the server to perform all the future transactions. So let's say if any e-commerce company gets DAO implemented in the organization, they can have the following advantages. Number one, all the processes would be codified and hence no scope of making any manual error. Chances of having any discrepancies won't be there since it works on a collaborative consensus, right? And then overseeing of things would be eliminated. No need to have a specified hierarchy of position or authority. Actions like stock maintaining, delivery of the product, etc. are taken on automatic triggers and hence making the process faster and more efficient with lower cost. So blockchain's future certainly looks quite bright, isn't it? Now let's see how bright can it make your future. So let me tell you guys that blockchain expertise actually captured the #1 position on the latest skills index by Upwork for being the hottest in the US job market. So this is just one of the many indicators of how high the demand is for people with blockchain skills. and hence employment is never an issue for a blockchain professional. And a blockchain expert can garner around 86,000 per year. Sounds quite promising, right?
Let's start with a very basic question that what is Bitcoin or what is blockchain from your perspective? So basically, yes, blockchain is all about securing the data in such a manner that it is secured and transparent to the people who are part of that ledger. Repeating again, blockchain is nothing but a methodology opted to secure or to store the data in such a way that it is very, very secured and transparent at the same time. When I say secured, it means that no one can tamper that data. And when I say transparent, it means it is a public record. It's not a private record. It's a public record which is accessible by everybody who is a part of that ledger. So if it is a public blockchain, like now, as we all know, there are two different types of blockchain: public blockchain and private blockchain. If it is a public blockchain, then who can access the ledger? Everybody can access the ledger. So who can access the data present in the ledger? Everybody can access the data present in the ledger. But when it is a private blockchain, only a limited number of people can access the ledger or are part of that ledger. So who can access the data present in a private blockchain ledger? Again, only those people who are part of that ledger, only those people can see the data present in that ledger. So in both case, the data present in the ledger is accessible by the people who are part of that ledger. The only difference is in public blockchain, everybody is a part of ledger, and in private blockchain, only limited number of participants are part of that ledger. We'll understand that in greater detail. This is just a one-liner for blockchain. We'll understand everything in detail, but it's a good start. What is Bitcoin as per you? First of all, it's a digital currency. Secondly, adding to digital currency, it's a digital cryptocurrency. Okay. And third and most important thing is Bitcoin is running on top of a technology that is blockchain. Or in the background, Bitcoin is utilizing a technology that is blockchain. Okay, this is some facts about Bitcoin. Most important fact about Bitcoin is Bitcoin is the pioneer for blockchain technology in the market. Bitcoin is the pioneer for blockchain technology in the market. Okay, because Bitcoin only brought blockchain as a technology into market. Okay, if there would have been no Bitcoin, probably there would have been no blockchain at this point of time. Maybe discovered in future. But there is a wrong assumption by most of the people that Bitcoin is all about blockchain or blockchain is all about Bitcoin. So the first statement may be partially right, partially wrong. But the second statement, that is blockchain is all about Bitcoin, that is absolutely wrong. Okay, the reason behind that is Bitcoin is just one of the applications of blockchain. There are thousand more ways how we can utilize or how we are actually utilizing blockchain as a technology. Okay, there are thousands and thousands of more ways how we are actually utilizing blockchain technology in disrupting different sectors of finance, supply chain, banking, insurance, manufacturing, and multiple other domains. Bitcoin is just one of the applications of blockchain. But yes, definitely it holds an important place in the history or in the era of blockchain because it is the pioneer for blockchain technology. Okay, so I hope now we are in a good position to understand what is Bitcoin and what is blockchain. So this slide speaks about the history of Bitcoin, when it was invented, how it dragged its prices all the way from $1 to $13 and then going up to $1,000. So what is Bitcoin basically? It is the first blockchain focused decentralized digital currency. It uses consensus to control its creation and management rather than relying on central authorities. Very important point. What does this mean? It means that Bitcoin is not managed by any central authority. Okay, what does it mean? Like other digital currencies, it can be anything like PayPal money or Amazon balance, which is the balance which is available in their digital wallet, or any there are multiple applications who offer their own currencies, like Uber credits are there, right? So all these Uber credits and Amazon all these balances are also digital currency, which are managed by a specific organization, right? They have full right to add additional balance to your wallet or to deduct these balances from your wallet. Okay, they have full right to do that. But unlike these digital wallets like Paytm, Ola credit, Uber credit, or there's Amazon credits, all these things, they are all different digital assets which are being monetized by different digital organizations, right? Absolutely unlike them, Bitcoin is not managed by any central authority, or Bitcoin is not managed by any central organization. It's basically a number of people in general, or in a very layman term, if I have to explain, I can say that in general, a group of people from all over the world have collaborated together and decided to create Bitcoin. And now, when these Bitcoins are created, it is given to people for use. So, people from all over the world, or anybody from throughout the world, can own Bitcoin, can sell Bitcoin, can buy Bitcoin without any dependency on any organization. Okay? Without any dependency on any organization. So, this is exactly what it means when we say it uses consensus to control its creation and management, which means there is a very important thing in any digital cryptocurrency, that is consensus algorithm. We'll learn about consensus algorithm more in greater detail, but as of now, we can understand that it's a piece of software which is responsible for managing the whole blockchain network. Okay, it's a piece of software which is responsible for managing the whole blockchain network, and that is what is consensus algorithm. And we will understand consensus in greater detail, but as of now, just a one liner for consensus algorithm is it's a piece of software which is responsible for managing the whole blockchain network. Okay, so it uses consensus to control its creation and management, which means creation of Bitcoin is also done with consensus algorithm, and management of Bitcoin, which means who is holding what, the transfer of Bitcoin, the transfer, the buy, the sell, all these things are taken care or are pre-programmed in the consensus algorithm of Bitcoin blockchain. Okay. So there is no organization which is handling this. It is just a piece of software which is pre-programmed with the network configuration. It is taking care of creation and management of Bitcoin. It is held electronically in a peer-to-peer open ledger called blockchain. What does it mean? It is held electronically in a peer-to-peer open ledger called blockchain. It basically means that, first of all, Bitcoin is not something that can be printed, or Bitcoin is not a physical coin. It's just a digital form of currency which is held electronically in a peer-to-peer ledger called blockchain. So, what is this peer-to-peer open ledger? Peer-to-peer open ledger means a ledger or a copy of ledger that is maintained only by people, and there is no such single centralized authority that takes care of that. To explain this more in detail, we can understand with this diagram. So you see, when there is a centralized authority, then all the peers are connected to the centralized authority. Okay, so always the data is controlled and the data is managed by this single centralized authority. Whereas all the people who are connected to that centralized authority just get a copy of data. Okay, just get a copy of data, but they have any right to change the data or to modify the data? No, only the single centralized authority has the right to change or modify the data. Whereas in a distributed data storage, or in a peer-to-peer open ledger, what happens? There are multiple people who are connected to each other, and all of them manages a copy of data. All these people will manage a copy of the data that is generated or that is created, and all of them have right to modify or change the data. altogether, not a single person. If a single person want to do some change, that is not possible. If all of them will agree to a data that yes, this is a valid data, all of them agree or a majority of them agree to the right data, then that right change can be done in the whole ledger. More lights on this will be, we'll try to understand this in greater detail moving ahead. But as of now, for just a clear understanding of what is a peer-to-peer open ledger, it is this kind of data storing technique. This is peer-to-peer open ledger, where different peers are connected to each other and the open ledger is maintained by them so that all the people who are part of that ledger can see the data available in that ledger. So these are different facts about Bitcoin. Why should we use Bitcoin? It's super fast, it's really cheap, it's absolutely decentralized, and never worry about chargebacks. Some of the more reasons to use Bitcoin is best payment security, it's not inflationary, it's really private, and we can make our own money with the help of Bitcoin. Okay, so before we move ahead, so with this we understood or we now have a fairly good idea of what is Bitcoin and what it does and how it's consumed. But now let's move ahead and understand what is blockchain. Okay, so what is blockchain? If we break down this word blockchain into two parts, we get block and chain. Okay, when we break down this word in two parts, we get block and chain. What does it mean? It basically means that blockchain is nothing but chain of blocks connected together. Blockchain is nothing but chain of blocks connected together. When I say chain of blocks connected together, what does it mean? So some figure like this will come to our mind, like some figure like this will come to our mind, where we have different blocks which are connected to each other, forming a chain. And that is what is chain of blocks connected together. And that is what is blockchain. Okay, fine. I understand blockchain is chain of blocks connected together. But then I have some more questions. Questions like what is a block? Why do we need block? And how is it chained? Because these blocks are not any physical block that we can tie them up with a rope and say that yes, you see, this is how it is chained. Because this is just a digital piece of data, right? These blocks that we are talking about is a digital piece of data. So how can we chain up a digital piece of data? Okay, so we have some more questions. That is, first of all, what is a block? Secondly, what it holds or why do we need blocks? And thirdly, how is it chained? Okay, so the first question, what is block? When we talk about a block, it's basically a building block of the network. Okay, like the way we say that cells are building blocks of human body, right? All our body is just made up of cells. In the same way, a whole blockchain network is made up of nothing but blocks. Okay, so blocks are building blocks of blockchain network. Okay, so these small blocks connect with each other to form the whole blockchain network. So now you understand what is the role of a block in the whole blockchain network, right? So block is nothing but a data holding technique which is responsible for holding the data of the blockchain and is the major contributor of the whole blockchain. So as I already told, whole blockchain network is nothing but chain of blocks connected together. And that is the reason you can say the word blockchain itself symbolizes nothing but chain of blocks which are connected to each other. Now the question is, why do we need blocks? Why do we need blocks? To store the data in the staggered format. To store the data in the staggered format, which means unlike centralized way of storing the data, in blockchain, we don't store all the data in one place. We don't store all the data at one place. Rather, we break down chunks of data and put it in different blocks, which means all the transactions that are currently happening will be stored in this block. Okay, fine. So this block will obviously will have some space. Let's suppose the space of this block is 1 MB, and which is not a supposed thing but it's a fact that size of one Bitcoin block is 1 MB. So obviously this 1 MB can store only a limited number of transactions, right? It cannot store multiple transactions. Yes. So whatever transactions are accommodated in this 1 MB of block, that will be accommodated. What next? So next we will create a new block. We will create a new block. We'll start storing the transaction in that block. Okay, if that gets filled, what next? Again, we'll create a new block. We'll create a new block and start storing the newer transactions. Whatever new transactions are coming, we'll start storing it in that block. Okay, that will also get filled. What we'll do next? Again, we'll create a new block. So this process of creation of new blocks will continue to happen till the time a blockchain network is up and running. Okay, so we store all the current data in the current block, and then when we find a need to create a new block, we'll create a new block, and then we'll start storing the transaction over there. Then again we'll create a new block and we'll start storing the transaction over there. Which means when we talk about overall data of blockchain, it gets distributed in these different blocks. So if this is the overall data of blockchain, then this is not stored in one single centralized server like all the other mechanisms. Rather, this all data is divided into pieces of data and stored into different blocks. So what it holds? It holds transaction. Why do we need block? Because we want to store our data. If there would be no blocks, where we will store our data of blockchain? So blocks are important because blocks only hold the data and transactions. Or we can say blocks only hold the transactions and transactional related data. Okay, so that is the reason blocks are very important. Next, at last, how is it chained? Okay, yeah. So let's move on to understand how is it chained. Okay. So basically, what happens is every block have two different parts. The first part is block header, and the second part is transaction list. Okay. Every block has two different parts: the block header and the transaction list. So in block header, there are five different fields. We will understand about all those five different fields at a later point of time. But for now, we can understand that out of all these fields, one of the field is block hash. Out of all these fields, one of the field is block hash. So out of now what happens with this block hash? Block hash is a unique hash that represents this block. Okay, so a unique identity. Every block should have a unique identity, right? So this block also has a unique identity, that is block hash. Now what happens? This block hash is not stored in the current block. Okay, this block hash is not stored in the current block. Rather, this block hash which belongs to this block is stored in the next consecutive block. Similarly, this block will also have a unique hash. Now this block's unique hash is stored in the next consecutive block, and this block's unique hash is stored in the next consecutive block. Like this, every block's block hash is stored in the next consecutive block. And this is what forms a chain. And this is exactly what forms a chain of blocks. Okay, so when we have different blocks and all the hashes of the current block is stored in the next block, similarly the hash of this block is stored in the next block, because a hash of a block is a unique thing that represents a block, right? This block hash is a unique thing that represents only this block, and we are storing this unique thing which belongs to previous block in the next block. So obviously there is a chain that is being formed between these two blocks. Similarly, the block hash of this block, which is a unique thing of this block, we are storing it in the next block. So there's a link between these two blocks. Like this, every block is connected to its previous block, or we can say every block is connected to its next block. And this forms a chain. And that is the reason it forms a blockchain. And that is how it is chained up. Is it clear to all of you? Okay. So now we'll move ahead and see and learn about wallets. So before we move to understand the concept of wallets, let's see how this blockchain overall as an entity is formed. So now you see the screen resembles a overall blockchain network. Okay. Over here we have different nodes. Okay. So there are quite a few terms that we must be familiar with. Firstly, consensus algorithm. We know what is a consensus algorithm. Secondly, what is a node? On overview, we know what is a node. So node is basically a person or a computer who is maintaining a copy of ledger, okay, or who is keeping a copy of ledger. We obviously know what is a ledger, nothing but chain of blocks connected together, right? So overall, what we are able to see from this figure, we are seeing that there are multiple nodes, node 1, node 2, node 3, node 4, node 5. All these different nodes are there, and these nodes are connected to each other in a distributed format. Okay, all these nodes are connected to each other in a distributed format and are also managing a copy of ledger. Now, you see node 1 is holding ledger 1, node 2 is holding ledger 2, node 3 is holding ledger 3, node 4 is holding ledger 4, and node 5 is holding ledger 5. Is there any limitation to number of nodes that can be there in the network? No, there can be any number of nodes. And I guess I've already told this before also, the more the number of nodes, the more secured the network would be. Okay. In future, we will be also talking about three aspects which blockchain provides. The three pillars of blockchain technology, which it provides to whichever product or whichever solution it is being implemented upon. So it provides utmost level of trust, transparency, and security. Not only for fact, but we will also deep dive and understand how exactly blockchain provides utmost level of trust, transparency, and security. But not at this point of time. Moving ahead, maybe next week. But for now, we just need to know that over here, what we are seeing is there's a node which is holding ledger 1, there is a node which is again holding ledger 2, and correspondingly, there is node 3, 4, and 5 holding ledger 3, 4, and 5. Now, the important thing is, are these ledgers different from each other? No, absolutely no. All these ledgers are exact replica of each other. All these nodes are holding the same copy of ledger, which means ledger 1 is equals to ledger 2 is equals to ledger 3, which in turn is equal to ledger 4 and 5. All these ledgers are exactly same. Okay, so do we mean that there's the same copy of data and we are trying to manage and copy the same piece of data in multiple systems, technically called as nodes, which are spread all around the world? Yes, that's exactly what blockchain does. Okay, it stores and manages the same copy of data which is managed on multiple systems, technically called as nodes, throughout the world. Okay, and these systems are distributed throughout the world. They are not limited to any geography or any country or any city. They are spread wide around the world. Okay, this diagram over here gives a clear picture of what a blockchain network looks like. Okay, so main components of a blockchain network is ledger, nodes, and the blocks. Altogether, chain of blocks forms a ledger, and chain of ledgers connected to each other in a distributed manner forms a blockchain network. So now we'll go ahead and talk about wallets. Okay, so what are wallets and how do they function and what is their role in the network? So I hope we are very much clear with this. And as I've already told, this gives a clear picture to us of how a blockchain works from a very top level. Okay, so there are multiple nodes holding a copy of ledger. Ledger is nothing but a chain of blocks, and blocks is nothing but list of transactions that happen in the blockchain network, right? And all these blocks and transactions are created and validated by a group of miners. How do they do that? We'll discuss about that later on. All these nodes and ledgers and block confirmation and transaction validation, everything is taken care by a software, a special software that is called as consensus algorithm. What is this consensus algorithm and what are different types of consensus algorithm? We will understand that even that in greater detail at later point of time. But I hope this gives us a very clear understanding of what blockchain is and how it functions. So now we are going to learn about how do we interact with the blockchain. Okay, fine. So we created a blockchain network, but how do we communicate with the data that's available on the blockchain? If we want to put some data over here, how do we do that? And if we want to read some data from the ledger, how do we do that? So that is possible with the help of unique thing that's called as wallets. So that's possible with the help of a unique thing called as wallets. So there are two perspectives. Firstly, in general, if I say what's a wallet, then wallet is nothing but a place. A wallet can be physical or digital, obviously, but doesn't matter if it is physical or digital. A wallet is basically a place where we store anything which is important to us, right? So that we can always access it, right? So it can be our identity proofs, it can be financial things, it can be financial assets, and it can be informative assets as well. So right, anything which is important to us, which we want to keep handy so that we can get it whenever we want, is something that we keep in a wallet. Doesn't matter whether it's a physical wallet or a digital wallet. This definition of wallet will hold good in both the cases. Okay, that's the first thing. But in crypto world or in blockchain world, a wallet is slightly different thing. Okay, so a wallet is basically a gateway with the help of which you interact with the ledger. In blockchain world, a wallet is something like a gateway with the help of which you interact with the ledger. So in crypto wallets, okay, we do not store the funds in the wallet, unlike the other type, the generic wallet, which I already explained, that a generic wallet doesn't matter whether it's physical or digital. A generic wallet is a wallet where we keep important things, financial assets, informative assets, to keep them handy so that we can get it when we want to. But unlike them, in blockchain wallets, the data is actually not stored in the blockchain wallets. Okay, the funds are not stored in the wallets. Rather, the funds are always stored in the ledger. Okay, we just communicate with the ledger so that we can get the funds that are available over here. We can get the funds reflected in our wallet. Okay, so what does wallet does? Wallet provides us gateway to access the ledger so that we can communicate with the ledger. We can write the data on the ledger and we can read the data from the ledger. Okay, another important thing is what wallet stores. Okay, some wallets may store a public key and a private key at max. Some wallet may store our public key and private key. Now, what is this public key and private key? Very important to understand. So, public key and private key is a set of key that is uniquely provided to all the people who are a part of blockchain network. Please understand this very carefully. Public key and private key is a set of key which is provided to every individual who creates an account on any blockchain platform. Which means tomorrow, if I want to create my own account on Ethereum blockchain, what will I do? I'll go on any wallet which is supporting Ethereum blockchain, or I'll go to any wallet which supports Ethereum blockchain and I'll create an account over there. As soon as I create an account on any blockchain wallet which is supporting Ethereum, it will provide me two different things. Firstly, it will provide me public key, and secondly, it will provide me private key. Okay, so it will provide me public key and private key, and they always exist in pair, which means public key is always derived from the private key only. Okay, which means they always exist in pair and there is only one unique public key for a private key. Okay, so I hope you understand this. So when, how does blockchain network recognizes us? Any blockchain network, not only Bitcoin or Ethereum or any, but all the blockchain network, how do they recognize us? Only with the help of this public key and private key. Okay, so while creating an account on any blockchain network, do I need to submit my name? No. Do I need to submit my email address, my phone number, my account ID, or anything which is specifying me as an individual? No. I don't provide any data about myself. I don't have to provide any data about myself. And that's the reason public blockchains are anonymous. Okay, so that none of your personal information is taken on these blockchain platform. Okay, not even your name. So in return, a public key and a private key is assigned to you. So how are you known to the network? Only with the help of your public key and private key. Whatever transactions you will be doing in future, all those transactions will be instantiated with your public key and will be cryptographically signatured with your private key. Okay, fine. Now I understand that I have a public key and I have a private key. So how I'm known to the network is with my public key, and how do I sign any transaction on the blockchain network is with my private key. Fine. But how are these keys created? How are these keys generated actually? So, okay, there are different cryptographic algorithms that are applied, and with the help of that, these keys are created. Okay, we'll not too much deep dive into the cryptography part because that is not a aspect of this course, but at least we will get to see a detailed view of how these keys are generated. I'll show you a real-time demo of that, maybe in a couple of minutes. But before that, when I say that I have a public key and I have a private key, so what if I hand over my public key and private key to one of my friend? Okay, will the blockchain network able to differentiate between me and my friend if both of us have the same public key and private key? Absolutely not. The blockchain network will never be able to differentiate between you and your friend if you have the same public and private key, because the blockchain network, leave about your friend, the blockchain network doesn't even recognize you, because while creating an account you didn't submit any data to the blockchain network. The only thing that you got in return was a public key and private key. So it is very, very important that you ensure the security of your public and private key. If for some reason you get it exposed to other people or you share it with other people, you just lose your data. Okay, because they may also access the same data and access the same funds which is stored in your account. So it is very important to secure my public and private key. Is it important to secure both public and private key? No. With the name only you can understand public key is a thing which can be always shared with people. It's a public key, you can share it with everybody. Private key is something that should be very, very secured and should be kept very, very confidential, because a private key is the one which signs any transaction. Okay, so how can I, in an easy manner, if I want to understand public key and private key, how can I understand that? So you all must have got a account number, bank account. You all must have got internet banking. So you all must have got a username or maybe an account number and then ATM pin or any confidential pin, credit card pin, or an internet username password, right? So all these things, that password, the ATM pin, these are confidential thing, right? So you can compare that with a private key. Whereas your account number, which is again unique to you, but then you can share it with people, because obviously when you want anybody else to transfer some funds to you, you have to give them your account number. So definitely account number is also a unique thing, but that is not confidential. You can share it with people. In the same way, public key is also a unique thing, but it's not confidential. You can share it with, and you have to share it with people when you want to receive funds from them. Okay. So whenever you want some funds or you are expecting some funds from somebody, you have to share your public key with them, the public address with them, and they'll transfer some funds to you. But your private key is like your ATM pin or your username, your internet banking password, which you cannot share with anybody. There is another flaw that is associated with private key is, unlike traditionally used pins and passwords that are ATM pins and internet banking password, if you lose them, you can reset it. If you share it with anybody else, day after tomorrow you can change it. But unlike all these features like resetting the password and changing the password and forgetting and again recreating the password, unlike all these features in blockchain, you cannot do anything as such. If you lose your private key, you just lose everything. There is absolutely no way of recreating your private key or resetting your private key or anything like that. Okay, so it's very, very important to secure your private key. Okay, that is one thing. Now if we want to see a quick demo of how these public keys and private keys are generated, we will move ahead and see that as well. Let's see how address and how a private key and how a public key and all these things are created. So over here you see anything. Okay, so firstly, how a wallet is created. So maybe you can go on my ether wallet. So over here, when you go on my, this is one of the potential wallets. There are multiple other wallets. Okay, like MetaMask is again a wallet, my Ether wallet, and multiple wallets are there. You can go to any wallet, and directly on the home page itself, you'll get an option to create an account. Okay, so directly on the home page itself, you'll get an option to create an account, and then you can just follow all the process of creating an account, and you can easily create an account. There are multiple tutorials as well, which will help you to create an account. So you see over here, you see on the home page itself, you get an option to create a new wallet. And if you already have a pre-existing wallet, you can click on access my wallet. Okay, so you click on create a new wallet, and it will guide you with how do you create a account, and it will help you to create an account. That's simple process, nothing to explain much in that. Okay, now and the back end, see over here everything is graphical, like you just have to click on buttons and enter things and data.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
But in the back end, what this wallet is doing technically, that is what we are going to understand over here. So it will be asking you, or 99% of chances that it will be providing you with a random passphrase. Please understand this very carefully. It will be providing you with a random passphrase. What is a passphrase? Any data, like I type my city name. Okay. So I type my city name and that becomes a passphrase. So anything, any random data becomes a passphrase for you. It does not ask for your passphrase is because I'll give a reason for that as well. That why it doesn't ask for your passphrase, why it randomly assigns you a passphrase. We'll discuss about that as well. So let's suppose I provided a passphrase over here, which is Bangalore, and there are pretty much chances that I can type something random as well. Okay, anything random. So obviously this is not readable and I do not understand what it is. So that's the reason. This is the reason why it creates a random passphrase for you. Because when a human enters it, they will enter something which is relevant to them and something which is logical. Like I entered my city name, right? So there are chances that other people might guess that what I would have entered as passphrase, right? So that's the reason to randomness plays a very important role in blockchain. This is again very important statement that you should remember throughout the time you are involved with blockchain technology. The first thing I told was more the number of nodes, more secure the network is. And second thing is randomness plays a very, very important role in the world of blockchain. So the more random the things are, the more secured they will be. Okay. So over here, I write my city name and what happens? SHA-256 algorithm. This is a cryptographic algorithm. SHA-256 is something that is applied to this passphrase. Okay. Now how SHA-256 functions? Similarly, like this, there are multiple other cryptographic algorithms as well, like elliptic curve cryptographic generator, like CAC 256. All these are cryptographic algorithms. So how do they actually function? If you want to learn about that in greater detail, you can look into them, separately, so that you get a better understanding of how these encryption algorithm functions or these hashing algorithm functions. Okay. But over here, we'll just understand that yes, SHA-256 is a hashing algorithm that will be applied to the passphrase and a private key will be generated. So this is a private key that you see over here on the screen, right over here. This is a private key of 256 random bits. Okay. Now, to this private key, which is generated over here, it gets segregated in two formats, that is X and Y. Okay, the X coordinate and the Y coordinate. Now, to this X and Y coordinate, elliptic curve cryptographic generator is applied. Okay, ECDCA, that's called as elliptic curve cryptographic generator, is applied to the public key, that is kpub, and then with the help of that, the final output that is created, to that final output, KCAC 256 hashing algorithm is applied. Okay, you don't need to remember all this. Okay, you don't need to understand all this also, but it is just so that you can actually understand that how these public keys and private keys are generated. You don't need to learn it, you don't need to memorize it. You just need to understand that, okay, so this is how it is created. Okay, so whenever you see a public key and a private key, you will have curiosity to know that how these keys are generated. This is how they are generated. You take up a random passphrase, to that SHA-256 algorithm is applied and private key is generated. Now to that private key, elliptic curve cryptographic generator is applied And finally, CAC 256 is applied to generate the public key. So this is the public key. Now, the last 20 bytes of this public key is the address, that the main address which is used for sharing or for transferring of funds and all those things. Okay, you take up the last 20 bits of address and you prefix the last 20 bytes of the address with 0x, and that's what makes an Ethereum address. Okay, so this is overall how a public and private key is generated. So now you can see that an address is nothing but something that is derived from the private key. Another important thing to consider over here is, in most of the cases, in most of the wallet, it will not allow you to, it will not allow you to enter the passphrase. Okay, I'll show it why. The reason for that is, see, I entered Bangalore and I got a private key. Let me copy this private key and paste it here. Okay. So when I entered Bangalore, I got this as private key. So if I enter the same thing Bangalore, and the hash that I get is absolutely same. Okay. So when I get the same hash, this is the reason. Now you understand why wallets do not allow you to enter your passphrase. Because if you enter something like your name, your city, your hobby, your favorite thing, favorite book, favorite whatever it is, the same thing can be retrieved by anybody else who knows you, or by trying random things, right? So that is the reason this is provided in a very, very random format. So when there is something random, the private key would also be random, right? And this private key is obviously unhackable. Now that is first thing. Second thing is, if I just change a small thing like changing the small Bangalore to the capital B, what happens? And we can clearly see that if we do a small change like just changing the small to capital, it changes the whole private key. Okay, so that is the reason in most of the cases the passphrase is assigned to you by the wallets, and that's SHA-256 is applied, private key is generated, and then you get a address. So this address and this private key is something that I was talking about over here, the private key and the address. And that's how you are known to the network. That's how you sign any transaction on the network. So now we'll go ahead and discuss about different types of wallets that are available in the market. So when we talk about different types of wallets, we have web wallets, mobile wallets, desktop wallets, hardware wallets, paper wallets, and multi-signature wallets. So when we talk about all these different types of wallets, what is common in them? So everything is common only. There is nothing unique. Okay. All these wallets does the same thing. And what is that same thing? All these wallets will provide gateway to access the ledger and may store public and private key. Okay. These wallets are simply used for only two purposes. Firstly, they provide access to the ledger, and secondly, they may store public and private key. Okay, most importantly, this aspect only, providing access to the ledger so that people who are on this wallet can interact with their funds, their data, their assets, which is stored in the ledger. They can interact with those things. They can put some more data and read the data that's already available. That's the main thing that any wallet does. Okay, so then if all these wallets does the same thing, then why do we have so many different types of wallets? Let's understand that. So over here we have web wallet. So web wallets are basically used for providing web interface to people. So wallets which are available on web, which you don't have to download locally in your system, which you don't have to install in your mobile, and which you don't have to get it installed in your desktop or system, is simply called as web wallet, which wherein you can simply go on a web application, you can simply go on a website and access these wallets. Okay, there are multiple examples as well, like blockchain.info, Coinbase, all these are web wallets. Okay, then we have mobile wallets. What are mobile wallets? Mobile wallets are the wallets which are available to be downloaded on mobile. Okay, so the wallets which you can install as an application on your mobile phone, that's a mobile wallet. Then we have desktop wallets. Again, the wallets which you can install on a desktop is a desktop wallet. The examples of mobile wallets are Bread Wallet, Mycelium, Airbits, and Greenbits, whereas the example of desktop wallets are Electrum, Multibit, Armory, and there are multiple other wallets. And to be very frank, in recent days, the same wallets are available on multiple platforms. Okay, there was a time when there were different wallets created for different platforms. Okay, but now the same wallets are available on multiple platforms. Like over here, you can see MyEther wallet. Traditionally, it was a web wallet only. Okay, MyEther wallet traditionally back in 2017, it was just a web wallet. But now the same wallet is available on App Store, Google Play, and everywhere. Okay, so now almost all the applications are available at all the places. But yes, this is how it functions. So then we have a hardware wallet. Now what this is something interesting. What's a hardware wallet? So let me show you firstly what's a hardware wallet. So this is a kind of hardware wallet. Okay. So this hardware wallet is basically responsible for holding the funds. I mean, again, this wallet also does the same thing that any other wallet does. Yes, it again does the same thing that any other wallet does, that it stores your public key and private key and provides you the access to the ledger. But then if it is the same thing, then why will anybody buy these wallets? Because most of the web wallet, mobile wallet, desktop wallet, they are all free. They are available free of cost. Then why will anybody purchase these wallets? I mean, purchase a hardware wallet, because hardware wallet cost you something. It cost you around $100 to $200. So why would anybody purchase or will invest $100 to $200 in order to purchase a hardware wallet? It is because of the security of your private key. But we just learned that blockchain provides you with utmost level of security. Then do we still have a doubt on the security? No, we don't have the doubt on the security of blockchain, but we do have the doubt on the security of the wallets. Because let me explain it to you like this. This is the blockchain side, okay? But this is a traditional side. So basically all the funds and the transactions are stored on the blockchain side. This is the ledger, right? But the wallets are stored over here. And as we know, wallet stores are public and private key, right? So when public and private key is stored on the traditional server side, then obviously it is potentially more prone to hackers. So anybody can come and steal our private key. So if anybody steals our private key, I've already explained the scenario, then they are equally available to access any data or any financial asset that is stored on a ledger on your behalf, because the ledger does not know you or that person. The ledger just understand and knows this private key. So whosoever is having this private key, they are equally eligible to do transactions for that specific private key corresponding data. Okay, so obviously the web wallet, mobile wallet, desktop wallet, all these wallets are available on internet, right? So they are available or they are hosted on some servers, and those servers are prone to hackers. So if any hacker can come and steal your private key from those servers, obviously they are equally capable and eligible to do transactions on your behalf, right? That is where a hardware wallet comes into picture. So a hardware wallet is not all time connected to internet, and a hardware wallet is not hosted on some server. A hardware wallet is something which has having its software programmed within that hardware itself. Okay, so the software is programmed within that hardware itself, and the private key is also stored within that hardware itself. So it's not all time connected to internet, or it's not all time available on internet. Rather, it is just plugged in for fraction of minutes for doing the transaction, and then again it is plugged out. So there are very rare chances that anybody can steal the private key within that fraction of seconds or minutes. Okay, so that's the reason hardware wallets are more secured than other traditional wallets. The reason I've explained. Other wallets are hosted on servers which are prone to hackers, and can hackers can come and bypass the security of those servers and can steal the private key. But a hardware wallet is not at all connected to internet only. So it's like a pen drive. You only connect it to your system when you have to do the transaction, and once you're done with the transaction, you again plug it off. I hope that makes sense. Then we have paper wallet. So there are two different types of hardware wallet: Ledger Nano and Trezor wallet. So this I've shown you. This is how a Ledger Nano looks like. And if we talk about Trezor wallet, it looks something like this. So this is how a Trezor wallet looks like. Okay. So now we'll go back and then we'll understand what is a paper wallet. So what's a paper wallet? Paper wallet is again one of the very secured wallets, but paper wallet is not a type of wallet. It's just like You write down your private key on a piece of paper, or you memorize it, or you put it in a notepad file and save it in your system. Okay, so paper wallet is just storing your private key at any place wherever you want. So only having a paper wallet also have some flaws, because for some reason if your system get corrupts, or if you forget your private key, or if the paper on which you write down the private key gets torn or get lost, obviously you lose all the things, you lose all the funds. So that is again not very feasible. But then at last we have multi-signature wallet. Okay, this is something very interesting. Okay, multi-signature wallet is something which is very interesting and is the best wallets among all. Okay, so we'll deep dive into multi-signature wallet to understand how multi-signature wallet functions and what how it is very good to use and interesting. So in multi-signature wallet, what happens is, please understand this very carefully. With the name only, you can understand it is multi-signature wallet, which means more than one signature is required to do a transaction. Now, let's suppose there is a owner. Okay, if I'm the owner and I go on a multi-signature wallet to create an account. I don't go on any traditional wallet like web wallet, mobile wallet, desktop wallet, hardware wallet. No, I go on a multi-signature wallet to create my account. Now multi-signature wallet asks me that how many private keys you want to create. Okay. So multi-signature wallet on my behalf will create three private keys because I asked the multi-signature wallet to create three private keys for me. Okay, so multi-signature wallet create multiple private keys as per the user request. So if I ask multi-signature wallet to create three private keys, it will create three private keys, private key 1, private key 2, private key 3 for me. Now what happens is I store the private key on piece of paper. Like let's suppose we have a private key 1 which I store on a web wallet. Okay, and then I have a private key 2 which I store in the paper wallet. And then thirdly I have a private key which I store in a hardware wallet. Okay, so what I did, I kept my first private key in a web wallet, I kept my second private key in a paper wallet, and I kept my third private key in a hardware wallet. Now again, when even though I created three private keys, it will also ask me that while doing any transaction, how many private keys you want in order to signature any transaction. Like over here, for all these different types of wallets, web, mobile, desktop, and hardware, there is only one public key and there is only one private key. So when you are doing the transaction, only that specific private key will be used in order to do the transaction. But over here, in multi-signature wallet, we even have an option of choosing how many private key out of the total number of private key that we have created, how many private key is at least needed to sign a transaction. Let's suppose I say two. So at least two keys are needed to sign a transaction. So it can be these two keys, it can be these two keys, or it can be these two keys. Three combination. Any two keys out of these available keys can be used to do the transaction. So either private key 1 and 2 can be used, either private key 2 and 3 can be used, or either private key 1 and 3 can be used. Okay. So now what happens? You can see here needs at least two keys to be signatured to initiate the transaction. Now let's consider different scenarios. Now in scenario 1, let's suppose any hacker came and stole your private key from the web wallet. Why it can be compromised? Because web wallet is always available on web and anybody can come and steal your private key, right? So obviously there are chances that your private key stored in a web wallet may be compromised. So let's suppose it got compromised. Now will that hacker, will he be able to do the transaction? No, because he has only one private key. He doesn't know the private key which I wrote down on a piece of paper and is logged inside my locker, and he even doesn't know the private key which is stored in my hardware wallet. Right? He has got just one key, and with that one key, he won't be able to do anything because at least two keys are needed to be signed to sign a transaction. Okay? Another scenario. Let's suppose for some reason, if someone has got an access, to my private key which is available on a piece of paper, again, he won't be able to do anything. If for some reason, if I have lost my hardware wallet, a pen drive like thing which I have lost it, okay, so oh, I have lost my private key. How will I be able to do that? Again, with the help of these two keys, I'll be able to signature the transaction and make all the funds out of my contract or out of my account. Similarly, if I lost my private key which I have written on a piece of paper, again I have option of using these two keys and getting the funds out of my account. So earlier there was no option or there was no chance of doing all these things, but now with the help of multi-signature wallet, I will be able to do all these things. And now we'll move ahead and see and learn about what is a centralized and a decentralized network. So basically, when we talk about centralization and decentralization, it is just about differentiating the point of controllability. Okay. So when we talk about centralized network, you see that we have one single point of control over here. Okay. So everything is being controlled by one single entity. So all the other nodes or peers, whatever you say them, technically we can say them peers or nodes. So all of them are connected to this centralized authority. They are reporting and retrieving information only from this centralized authority, right? So this acts as a central authority for managing the data and controlling the network as well. Whereas in decentralized network, what happens? In decentralized network, there is no such one single node. Rather, there are multiple nodes that are there who are connected to each other and who further relies information to a group of nodes or peers. Okay, so there are some, we can say over here as nodes and sub nodes. So we have sub nodes and nodes. So these are nodes. The white color dots that you see are nodes, and then the yellow blue color dot that you see are subnodes who are connected to a particular node, and they are handling the network in this manner. So there is no such single piece of entity who is said to be the controller of the network. There is no a single point of controller of the network. Okay, there are multiple people who are all equal to each other, and they are controlling and managing the network. So in blockchain, the beauty of decentralization is these people are unknown to each other. So there is no point of them collaborating together and bringing a network down, or hacking a network, because they are unknown to each other. Okay, this is one thing. Next is distributed network. So in distributed network, all the nodes and subnodes are connected to each other in a very jungled manner network. Okay, all the nodes and subnodes are connected to each other in a very complicated and tightly packed manner. So all of them are very much in connection with each other. They share the same piece of data, and they hold the same piece of data among themselves. So now another important thing is, obviously there is no relation between centralized network and blockchain, but sometimes we even say that blockchain is decentralized, and then sometimes we even say that the blockchain is distributed. So what exactly is it? Is it decentralized or is it distributed? So basically blockchain network is functioning in a decentralized manner. Okay, the blockchain network itself behaves as a decentralized network, but the data that is stored in the blockchain network is stored in a distributed manner. Okay, and I hope this we have already understood. The same copy of ledger is maintained with multiple nodes, right? All the nodes manage and maintain same copy of ledger. So now we'll move ahead and learn about how blockchain provides you with utmost level of trust, transparency, and security. Okay, so as we all can see over here, when we talk about trust and transparency, it is very much clear that when the same copy of ledger is stored with multiple network members, okay, then there is no doubt in transparency, right? I mean, how do you bring in transparency? Let's suppose if I'm an organization, please understand this very carefully. I'm organization 1 and you are organization 2, and we both are doing business with each other, right? We are involved in a business. How we will bring in utmost level of transparency? When we do not maintain the data separately with each other, rather we have a common server, and that server is only maintaining the data, right? That will bring in utmost level of transparency, right? But will you be able to trust each other? Transparency is fine, you both are having a common server, and that the data is being managed over there, so transparency is there. But will you be able to trust each other? No, because you'll always think, what if organization 2 comes and hacks the data and change or tampers the data in the server, in the common server? And organization, you being organization 2, will always think, what if I as organization 1 will come and tamper the data over here, right? So bringing in trust and transparency at the same point of time is very difficult, and this is what is brought by blockchain. So now the question is, how does blockchain deliver trust and transparency between two organizations or multiple organizations, and that too of utmost level. So over here, as we all know, that the data present between or the data present in the ledger cannot be modified by anybody. Why it cannot modify the data? Let's suppose I'm a hacker and I want to tamper some data in blockchain. So what will happen? I will obviously I'll go to one of the nodes. I'll have to tamper the data. Let's suppose I'm tampering this block. And for some reason, me being a hacker, I came to node 2 and I tampered this block. Is it enough? Absolutely not. If it would have been a centralized server, what we have been using all these days, there it would have been possible. This is enough because we just have to bypass the security of that server and we go there and we can change the data. Although it is not as easy as I'm speaking it, but yes, definitely it is easy as compared to hacking a blockchain network, because all a server will have is its outer security that will prevent anyone from coming or refraining into the network or into that server. But once you are into the server, if you are into the server, then absolutely you can do whatever changes you want to do. But in blockchain, if you enter into this node and even though you modify the data, is it enough? No, it's not enough. The reason is the boot node will simply say that this node is not in same state with the other node. You remember what is the responsibility of boot node? To ensure that all the other nodes are in synchronization with each other and are in the same state. So a boot node will say that this node is not in the same state with all other nodes, and the data, whatever you have changed in this, will again go back to its original format. So whatever data you have changed will go back to the original format. So what will you have to do? What if you want to hack the network? No matter what it costs, but you want to hack the network. What you will have to do? At the same point of time, you will have to hack more than 51% of the nodes at the same point of time. This is very important. And you don't even know who are nodes, where, in what part of the world they are residing, right? Because over here, it is not one server. So if totally there are 1 lakh nodes or even 10,000 nodes, if totally there are 10,000 nodes, at one point of time, you will have to hack 5,000, more than 5,000 systems and do the changes in their data at the same point of time. What if you do it in different time? Like what if you go one by one? If you do it in one system, go in another system, go in another system, then boot node will keep on changing the data back to the original format in previous system. So you just go on moving forward, and in the backward system, everything is being changed to their original state. That is the reason it provides you with utmost level of security, and it provides you with utmost level of trust and transparency together. Okay, because over here you are not trusting the organization, rather you are trusting the technology. Over here you are not trusting the organization, rather you are trusting the technology. Okay, there is one thing right now, whatever we are doing, we are trusting the organization. If any social media platform, WhatsApp, Facebook, Instagram, they are managing our data, they are saying that I'm not stealing your data, we are trusting them. We are not sure that whether they are actually seeing our data or modifying our data or tampering our data or not, but we are trusting them, trusting in organization. Whether the banking system is saying that we are keeping your money safe, again we are trusting the organization, a bank. But in blockchain, we are trusting the technology. And that is the reason, even though people and organizations are anonymous over here, yet we are believing them. So if tomorrow some local currency comes up by any bank, a bank which is not available, a bank which does not has any branch, a bank which does not has any employees, a bank which does not has any website, a bank which does not have any customer support, and if they ask you to deposit money in their bank, will you ever do that? No, right? Because you don't know where that bank is. You don't know how to contact that bank. You don't know any employee of that bank. There's no ATM, there's no organized, there's no branch of that bank. Will you ever put your money in that bank? No. But today people are putting money in Bitcoin. Why? Because they are not trusting Bitcoin, they are trusting the technology behind Bitcoin. So Bitcoin may be an organization, Ethereum may be an organization, and like this, there are thousands of currencies which may be an organization, which you have never seen, which you have never called. which does not has any customer support number, but then you are trusting them because you're trusting the technology. And all this just for this thing that it provides you with utmost level of trust, transparency, and technology. I mean, security. How it provides you? This is how it provides you with utmost level of trust, transparency, and security. We have already seen what's a blockchain. So the blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions but virtually everything of value. So I hope this figure clearly explains you what is a blockchain, right? So all these blocks are connected to their previous block. How they are connected? Because the hash of the current block is stored in the header of the next block, right? So as we know, a block is divided into two parts, the block header and the transaction list. The block header contains multiple fields. One out of those multiple fields is previous block hash, which is nothing but the hash of the previous block. Okay. In this manner, all these blocks are connected to each other, and that's how they form a blockchain. That's the reason this figure is depicted under definition of blockchain. So what is blockchain? It's nothing but chain of blocks connected together. So all these things like what are the problems of current systems and all these things that I've already explained. We have understood what is a distributed system, how it functions. We have understood what's a node. We have understood what's a digital ledger technology. So just see this figure closely and then I'll explain what is happening over here. So over here, what's happening is basically we have James, Stephen, Paul, Kevin, and Robert and Lisa. So all these people, you see that they have an asset and they have a book along with them, right? So they have an asset and they have a ledger book that is available with them. So the important thing to notice over here is there is no centralized authority that is managing or tracing them, right? But what you see over here is, let's suppose if James transfers some funds to Kevin, okay, then that transaction is recorded in all the ledgers. If James transfers some funds to Kevin, that transaction is recorded in James' ledger, in Steven's ledger, Rahul's ledger, Kevin, Paul, Robert, and Lisa's ledger. So no matter what transaction is done by whom, the transactions are always recorded in all the ledger. And in this way, it brings in utmost level of trust, transparency, and security. So the only thing is that everybody will be able to know that who transferred what amount to whom, right? The only thing is that everybody will be able to know that who transferred what amount to whom, right? But then you don't need any central authority at least who will validate your transaction or who will store a copy of your ledger. So now you can see here that now since there is no central authority in the system, there can be certain questions that might come across your mind, like how to verify from where these transactions are initiated and to whom it is sent, how the transactions are faster than the present system, how the currency is generated, who validates the transaction as there is no central authority. All these questions would be answered under mining section. Okay, that who creates the transaction, how the transactions are validated, how the transactions are propagated from one network to another, and all these things. Okay, so whenever anybody has to sign the transaction, we utilize our private key and other person's public key to sign that transaction so that the other person can utilize their own private key to decrypt that transaction. So this is how we encrypt and decrypt. So there are two different types of encryption and decryption, or we can say there are two different types of cryptography. First one is symmetric cryptography and the second one is asymmetric cryptography. Okay, so symmetric cryptography is a cryptography where the key which is used for encryption is same as the key which is used for decryption. Okay, so there is an encryption key which is used at the time of encryption, and then there is a decryption key which is used at the time of decryption. Okay, so when encryption key and decryption key are different, this should be here. So when encryption key and decryption key are different, that is called as asymmetric cryptography, whereas when the encryption key and decryption key is same, then it is called as symmetric cryptography. In blockchain, we use asymmetric cryptography. The reason is clear that we have two different keys, public key and private key. So one is used for encryption and one is used for decryption. So we use the public key of the other person to encrypt the message, and the other person will use their private key to decrypt it. Okay, so now let's move ahead and understand the concept of digital ledger technology, about what are different properties of distributed ledger technology. So basically, first of all, what is a DLT? As we all know, DLT is nothing but a common distributed ledger that's shared across multiple nodes, right? So people think of blockchain technology and distributed ledger technology as one and same, but interestingly enough, that is not the case. Let us show you the difference. So distributed ledger technology. So what are different properties of DLT? It's distributed, means all the network participants have a full copy of the ledger for full transparency. So first property of DLT technology is distributed behavior. That is, all the network participants have a full copy of ledger for full transparency. It's anonymous, which means the identity of the participants is either pseudonymous or anonymous. What does it mean? Basically, we'll never be able to know who is the actual person behind an address. So basically, let me show you one of the block explorers of Ethereum network. So over here, as we can see, this is a Ethereum block explorer, which will help you to see and understand each and everything that is happening on the Ethereum blockchain. Okay. What is etherscan.io? It is Ethereum Blockchain Explorer. What is Ethereum Blockchain Explorer, or what is Explorer for any blockchain? So every blockchain have an explorer wherein you can go and see everything that is happening on the network. Okay, all the transactions, I mean all the latest transactions, all the latest blocks, all the latest transactions which are added to blocks, who created the transactions, who validated the transactions, who created the blocks, all these information is available on this portal Etherscan, which is the Ethereum blockchain explorer. So over here you can see what is the Ether price. It's $4,000. Transactions, like totally how many transactions have happened till now. Roughly 1384.52 million transactions have already happened. And gas price, as of now we don't understand gas. I'll explain it to you later on. We don't understand difficulty as well. We don't understand hash rate as well. Market capital. So what is the total market capital of Ethereum as a cryptocurrency? Somewhere around 471 billion. Okay, so if we see over here, we see all the latest blocks that have been created. Okay, so who has mined this block? We'll get to see the miner's address as well. So these are different blocks who have got I mean who have mined this block. So let us open this specific block to get more information about this block. So over here we get to know the block number, which means the total number of blocks that have already been created before this block, the timestamp of this block, the transactions, like totally how many transactions are present in this block. You see 321 plus 115. Okay, so somewhere around 436 transactions, right? Then we see it is mined by a specific address. Now the reason why I came over here, you see an address but you don't know who is behind this address. When you open all these transactions that are present in this block, there will be a list of transactions, right? All these transactions are present in that block. So let us open any specific transaction. It will have a transaction hash and a from address and a to address. So this transaction was initiated from this address and it was targeted to this address. But do we know who are the actual people, or who are the real people? Or it may not be a people, it may be an organization as well, right? So who is the actual entity behind this address? Do we get to know that? No, we don't get to know that. And that is the reason it is said that the identity of the participant is either pseudonymous or anonymous. Okay, time stamped, which means all the transactions recorded in a block are always time stamped. As I showed you, every transaction will have a timestamp that when that transaction happened actually. Unanimous, all the network participants agree to validity of each of every record, which means basically that all the record that is updated on the ledger has been approved by all the network participants, or a majority of network participants. Okay, it's immutable, which means nobody can come and change or tamper the data. It cannot simply be tampered, it cannot be changed. It's immutable. Secured means all the records are individually encrypted and cannot be tampered by anybody. It's programmable, which means a blockchain is programmable through smart contracts. So, overall, we can say all blockchains are distributed ledgers, but all distributed ledgers are blockchain, which means there are some other distributed ledgers as well, which are not blockchain. The way we can say that all cryptocurrencies are part of blockchain, but all blockchain is not just about cryptocurrencies. Okay, so blockchain has multiple more applications along with cryptocurrencies as well. So this is basically a comparison between famous blockchain frameworks. We have Ethereum, which is a public blockchain. We have Hyperledger Fabric, which is a private blockchain. And we have R3 Corda, which is again a private governed blockchain. You can look into it. Okay, let's move ahead. In centralized ledger, we can say that it's basically one central clearing house is there, and there are multiple other distributed ledgers who are connected to each other. Whereas, I mean, all the other peers are connected to this central clearing house for all the information and for updatation of all the data and assets. Whereas in a distributed ledger, there is no such central clearing house. Rather, all are connected to each other and all are dependent on each other for managing the data and for storing the data. So that's a basic difference between a centralized ledger and a distributed ledger. So now we'll move ahead and see how a blockchain structure looks like. So you remember that we discussed about the block structure, right? So let me show it to you. So the top part is known as block header and the bottom part is transaction list. And as we all know that the majority of space, so in case of Bitcoin, the size of one Bitcoin block is 1 MB and can store a maximum of 4,000 transactions, right? It can store a maximum of 4,000 transactions. Doesn't mean that every time it will store 4,000 transactions. Okay. So out of this 1 MB, majority of the space is utilized by the transaction list. Okay, around 80 to 85% of the space, or even maybe 90 sometimes. Okay, only like 10 to 15% of the space is utilized by the block header. Okay, so what are the different fields that are stored in block header? So what is this previous block hash? Previous block hash is nothing but the hash of the previous block that we store in the current block. Okay, next is timestamp. Okay, another thing that we store in the hash of the block is timestamp. So basically we can say the timestamp is basically the time when the block has been created. Okay, so let us see that as well. So see, the transaction timestamp will be different and that will be specific to each and every transaction. Like what I mean is, so over here for this block, you see this is the block number which has multiple transactions inside that. So this block will also have a timestamp. Okay. So this timestamp that you see over here is the timestamp of the block when that block was created and added to the main blockchain ledger. Okay, this is the timestamp of the block that when it was created and added to the main blockchain ledger. So when we are talking about the timestamp which is present in the header of the block, it is that timestamp of a block, that when a block was created and added to the ledger. And then when we open any transaction, then all these 321 transactions will have their own respective timestamp as well. Okay, that we can see once we enter inside. So over here you can see each and every transaction will also have a timestamp when that transaction was confirmed. So another field that we have over here is version number. So basically version number is the version of the consensus that is available when we are utilizing this block or when this block was created. Okay, so basically consensus keeps on upgrading from time to time, right? The consensus algorithm, the consensus protocol keeps on upgrading from time to time, like the way your system keeps on upgrading. So basically, when we talk about consensus, you can understand consensus in a very layman's term like this. Like you all have a system, right? It may be a computer or it may be a mobile phone. So basically, this system is being managed by a piece of software that's called as operating system, right? Operating system is a piece of software that is fully managing your laptop or your mobile phone. If there is no operating system in your device, then it just becomes a piece of hardware with which you cannot do anything, right? So all the applications that are present in your laptop or in your mobile phone are functioning properly because they are dependent on the operating system for their execution. Okay, operating system is the one which does memory management, time management, disk space management, process scheduling, and all the important protocols and the network administration things are taken care by the operating system. So if from your laptop, if you remove Windows, Mac OS, or Ubuntu, whatever Linux, whatever operating system you have, if you remove that operating system, your device just becomes a piece of hardware, nothing else. You cannot do anything without an operating system, right?
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So all the application that you see over here, like Ubuntu subsystem, file explorer, Chrome, snipping tool, Paint, Notepad, GoToMeeting application, all these applications are only running because I have operating system installed in my system, and all these applications are created or developed only to run on top of the operating system that I have in my system. If I take this application and if I run it in the Ubuntu operating system, will it be able to run? No, absolutely not. Right? So every application is created or intended or developed in order to run on top of a specific operating system. In the same way, the consensus algorithm is the one who manages the whole blockchain network. Okay, so how the peers will interact with each other, how the peers will share the information with each other, how the transactions will be validated, how the transactions will be added to blocks, how the blocks will be created. All these things are programmed inside consensus algorithm. So consensus algorithm takes care of all these things. So now the way your operating system keeps on upgrading, right? Some time to time you must have seen that your system needs upgrade or reboot and things like this, right? So the version number, there's a specific version number that is associated with each and every upgrade. In the same way, over here, there is a specific version number associated with consensus algorithm as well. Okay, so every consensus algorithm has a specific version number and it keeps on upgrading from time to time. So to understand it better, that when this block was created, what was the version of the consensus at that point of time when this block was created, we also put that one of the field in the block header so that we can always know that when this block was created, what was the version of the consensus algorithm. Okay, so with time, as the blocks keeps on getting added and added and added, we can always trace that when or from which block to which block the sudden migration of the version of consensus happened, and we can track at all the places and not all the time that when the consensus have been upgraded. Okay, so before we understand about nuns, what happens is when a miner is creating a block. Okay, for this, let's understand the transaction life cycle first, and then in detail we will understand what exactly is nuns. Just give me a moment. So over here, as you can see in the screen, basically what happens, please understand this very carefully. We are going to understand what exactly happens and how the transactions are validated, how the transactions are updated, how the blocks are created, and how the block goes ahead and reside and become a part of main blockchain ledger. Okay, so this is exactly what we are going to learn about. So first of all, what happens is all the transactions that are being initiated by any person comes and reside in the main pool. Okay, so different peers mean different people. Different peers will create different transaction. All those transaction will come and reside in the main pool. Now what is this main pool? Basically there are multiple miners. Okay, there are multiple miners. Who are miners? Miners are the people who are in constant competition among each other to create new blocks. Miners are the people who are in constant competition among each other to create new blocks. Okay, so when they create new blocks, what will happen? When they create new blocks, then those blocks, if they become a part of main blockchain ledger, then they will earn reward from that block. They'll earn reward from that block and from all the transactions that are present within that block. So to understand this better, let's see this. So what happens is when you open any block, you will see the block reward thing over here. What is this block reward? It's somewhere around 2.41487 something ether, right? So around 2.4 ethers, we can say. So out of this 2.4 ether, 2 ether is the static block reward, as you can see on the screen. 2 ether is the static block reward, which is given to this miner for creating this block, this ant pool 2. So ant pool 2 is the miner who has created this block, and for creation of this block, Antpool 2 has received 2 ether as a static block reward. Okay, what after this? After, is it the only thing? No, after this, obviously this block will have multiple transactions. So whatever is the transaction fees that is associated with these transactions, okay, whatever is the transaction fees that is associated with these transactions, that also will be rewarded to the same miner. Okay, because as we all know, in Ethereum and Bitcoin, or not in Ethereum and Bitcoin, all the cryptocurrencies, the transactions are never free, right? The transactions are always charged with some fees. So whenever we do a transaction, we always have to pay some fees for that transaction, right? So this is the total number of fees, or the total accumulated fees for all these transactions, like around 340 transactions, 335 or whatever it is, 335 transactions. So for these 335 transactions, everybody who have done these 335 transactions, they must have paid small amount of fees, which accumulates to this much amount. And this is also given to the same and pool 2 miner, right? So this is the total reward. Now you must be. I hope you have got, some of you have having a question that why will anybody create a block, and why will anybody use so much of, what do you say, so much of electricity, so much of hard disk space for storing all the data, blockchain related data, and all these things. So they get this thing in reward, and of course, 2 ether is not a very small amount, right? So this is what they get in reward. Now the question is, how do they get it? What they do in order to get this? So let's come back to our figure. So what happens? Obviously, there are multiple miners. Like over here, we have Antpool 2, right? So if you go back on the ether scan, you'll see that different blocks are validated by different people or different miners. Let's have a quick look of that. You see, this block has been mined by F2 pool old, this block has been mined by Ethermine, this block has been mined by Ethermine, this block has been mined by some address, Flex pool, Ethermine. So all these are different miners, right? So that is what is represented over here. These are different miners who are in constant competition among each other. What is the competition about? I'll let you know. Why am I using the word competition? I'll explain that as well. So basically what happens is, in all these miners, obviously they'll have a system, because all the process is automatized. There is nothing, all the process is automatized. There is nothing, all the process is automatized. There is nothing manual, right? Every process is automatized. So obviously these miners will have a system, will have a computer which is doing all these things. So in that computer, there will be a specific dedicated area that is reserved for unvalidated transaction. Repeating the sentence again, all these miners computer have a specific reserved area which is reserved for all the unvalidated transactions. So all the unvalidated transaction comes and reside in that area, which is also known as mempool. So what is mempool? It is a local node copy of all unvalidated and unconfirmed transaction. Okay, what is mempool? It is a local node copy of all the unvalidated and unconfirmed transactions. So the same transaction, whatever comes over here, comes and reside in the mempool area as well. Now from this mempool, the miners will select the transactions of their choice. From this mempool, the miners will select the transactions of their choice, and they will validate it and put it in their candidate block. Why am I using the term candidate block? Because it is not a confirmed block. It is not a confirmed block. It is just a block which has been created by a specific miner. But all the other miners and nodes have not agreed to this block. When they agreed to this block, then this block will be a confirmed block, and then it will go and reside and become a part of main blockchain ledger. So before it actually goes and becomes a part of main blockchain ledger, it is just called as candidate block. It's a candidate which is there in the competition. Okay, so repeating again what happens, all the unvalidated and unconfirmed transaction comes and reside in the mempool. From mempool, the miners will pick up the transaction, validate it, and put it in their own candidate block. So like this, they'll just fill up some transactions. So after that, the consensus algorithm will launch a puzzle in the network. The consensus algorithm will broadcast a puzzle in the network. Okay, it's a mathematical puzzle. So we are not going to deep diving into what that puzzle is and what exactly how that puzzle looks like. It's nothing like that. It's just a highly complicated mathematical puzzle. Nothing. When I say mathematical puzzle, it's not like 5 into 5 into 5. Obviously not that. It's a highly complicated mathematical puzzle. Okay, so that is broadcasted by the consensus algorithm in the network. Now when that puzzle is broadcasted, whichever miner solves that puzzle first, whichever miner will solve the puzzle first, that miner will include the solution of that puzzle. Let's suppose I solve the puzzle first. So what is the proof that I have solved the puzzle first? What I'll do is, when I've solved the puzzle, obviously this puzzle will have a solution. I'll include the solution of that puzzle in my block header. What I'll do, I'll include the solution of that puzzle in my block header. And this is exactly what nonce is. So what is nonce? Nonce is the solution of the puzzle which is launched by the consensus algorithm. Okay, nonce is the solution of the puzzle launched by the consensus algorithm, and that is the reason overall we say that it is proof of work. Why it is proof of work? Because you do a work, you prove that you have done the work, and then you get the reward. Right? Firstly, you do a work, then you prove that you have done the work, and then you get the reward. So how do you do the work? By solving the puzzle. How do you prove that you have done the work? By including the solution of the puzzle in the header of the block. That is nonce. And then if both are done, you get the reward. Proof of work. So you do the work, you prove that yes, you have done the work, you get the reward. How do you do the work? By solving the puzzle which is launched by consensus algorithm. How do you prove that you have done the work? By including the solution, the block in the block header, and then you get the reward. So yeah, what happens? Consensus algorithm launches a puzzle in the network. Whichever miner will solve the puzzle first will include the solution of the puzzle in the header of the block, and then that miner will broadcast this block to every other node saying that hey, I have solved the puzzle. And all the other nodes will validate that yes, this miner has solved the puzzle because that miner has actually included the solution of the puzzle in their own block header. So all the other nodes will agree to it, and then this block will go and become a part of main blockchain ledger. Then this block will go and become the part of main blockchain ledger. And then the rewards, the reward that you see over here, these rewards will be credited back to the miner's account. So you see this reward over here, this reward will be credited to the miner's account. So let's suppose over here, as per the diagram, miner 2 has successfully found the solution to the puzzle that is called as nonce. It includes it in the block header, and then this candidate block will no more be a candidate block, as it will go and become a part of main blockchain ledger. Is it clear to all of you what is the this is called as transaction life cycle of any blockchain like Ethereum or Bitcoin? So this is what happens. This is how, I mean, specifically in Bitcoin block, this is how the transactions go and reside in the mempool. From mempool, they are picked up by miners, included in the candidate block. From candidate block, they solve the puzzle, they include the header of the puzzle, header of the, I mean, they include the solution of the puzzle in the header of the block, and then that block is approved by all other nodes, and then it becomes a part of main blockchain ledger. And with this, we have understood what are different values or different fields that are stored in the header of the block. Now we are left with Merkle root hash. So to understand Merkle root hash, so guys, over here, what if we want to, over here, as you can see, like we have multiple transactions present, like in the Genesis block, that is the first block, we have 3000 transactions. In the second block, we have 2500 transactions. In the third block, we have 3200 transactions, and like this it goes on and on and on. So over here we have multiple different types of transactions. I mean, multiple different transactions present in multiple different blocks. Obviously there will be millions of blocks, right? So now the question is, what if I have to search for a single transaction? Okay, what if I have to search for a single transaction? How will I search for that transaction? Okay, let's understand this. Okay, so over here, as we can see that how do we recognize any transaction? First of all, how do we recognize any transaction? It is with the help of transaction hash, right? Transaction hash. So every transaction has a unique hash that represents that transaction, isn't it? Every transaction has a unique hash that actually represents that transaction. That is transaction hash. Now, the question is, so in the same way in this block, if I have 3000 transactions, all 3000 transactions will have a unique hash, that is transaction hash. So there will be 3000 transaction hashes. So if I want to search for this transaction, which has a hash, what I'll do? I'll start comparing this transaction hash to all other transaction hash. I mean, to all the transaction hash present in this 3000 block, right? So I'll search for the first transaction. I'll try to match whether this transaction hash is matching with the first transaction or not. If not, then I'll go to second transaction, third transaction. Like this, I'll search for all the 3000 transaction hashes, and I'll search whether this I'm able to find this over here or not. If I'm finding it, well and good. If not, then I'll go to the second block, right? I'll go to the second block. So I'll start searching for this transaction hash in all the 2500 transaction hashes of the second block. Okay, like this in third block, in fourth block. So I'll start searching for all the transactions in all these blocks. Okay, so now, so basically, yes, what we do over here is we try to create a common hash. Please understand this very carefully. Obviously, see, it is going to be a very hectic process if I start matching this hash to each and every individual hash of all the blocks, right? If I start matching this transaction hash to three, I mean, in one block only, I'll have to do 3000 searches, right? And then in the second block again, I'll have to do 2500 searches. So like this, it will be huge complication, or it will take huge amount of time in order to find a specific transaction, right? So what we can do is, for every block we can create a unique hash that represents all the transaction of that hash. Please understand this very carefully. I'll create a unique hash that will represent all the transactions within that block, only within that block. So what if I create a unique hash that represents all these 3000 transactions? See, right now there is block hash that is uniquely representing this block. We have transaction hash that is uniquely representing each and every transaction. But now I'm talking about creating a hash that will uniquely represent all these 3000 transactions that are present in this block. And that is known as Merkle root hash. So now what will happen? Now every block will have this unique concept of Merkle root hash, right? So this block will have a Merkle root hash of 1. This block will have Merkle root hash of 2, which will represent all these 2500 transactions. This will represent all these 3000 transactions, and like this I'll have Merkle root hashes for all the blocks, right? Now what will happen if I have to search for a particular transaction that has a unique transaction hash? So I'll just have to compare this transaction hash to this Merkle root hash. Only one search I'll have to do. Earlier, where I was doing 3000 searches, now I just have to do one single search. Now if I found if I found the trace of this transaction in this hash, well and good. Otherwise, I'll simply move to the second Merkle root hash. If I found it, well and good. Otherwise, I'll move to the third block, fourth block. So by the time I was searching 3000 transactions in one block only, in the same time I would have searched for 3000 blocks actually. So in the time that was used only for one block, in the same amount of time I will do the searches in 3000 blocks, right? So this is the way how the search actually happens. This is the way how you search for any transaction. So over here, when you see Etherscan, and when I go on Etherscan, if I will, if I open any block, if I copy this block hash, this is the hash of this block. If I copy it, I go back on Etherscan, and if I'm searching it over here, the hash of the block, I'm directly clicking on search. So the node of Ethereum is actually doing the same thing that I just explained to you. Okay, maybe we took a wrong hash or something. So this is what actually the node of Ethereum does when we search for a specific transaction. Okay, so we can only search the block number and not the block hash over here. Okay, but yes, this is what happens in the background. Or when we search for any transaction, actually it should have been a transaction only. So if we copy the transaction hash, and if we go back on Etherscan, and when we search for a particular transaction, then this is exactly what is happening in the background technically. So it searches for the transaction and shows us all the detail of the transaction, right? So in the backend, our blockchain node is implementing the process of this thing that I just explained, that it matches the same transaction hash that I have searched. It matches it with Merkle root hash of block 1, 2, 3 like this, and then it figures it out then in which block it is present, and then it pulls that transaction from that block and shows us all the detail about that transaction details about that transaction. Okay guys, so I hope with this we are very much clear with what are the different composition of a blockchain block structure, right? So we are clear with what's the version number, we are clear with what's a nonce value, we are clear with the previous block hash, we are clear with the timestamp, and we are clear with the Merkle root hash as well. So now another important thing is to understand how this Merkle is actually created. So till now we have understood the need of Merkle and how that Merkle we utilize the Merkle. I mean, obviously, same thing. Like, what is the problem, and the solution to that is Merkle. The problem is that it is very complicated to search for a single transaction, and the solution to this problem is Merkle root hash. But the thing is, how do we create a Merkle root hash from this list of 3000 transactions? And we also say that this one single hash, that is Merkle root hash, has the traces of all 3000 transactions. How can a single hash have traces of all 3000 transactions? So that's what we are going to learn about. So just go through this figure, see if anybody can understand it. So basically what happens over here is we have different transactions L1, L2, L3, L4. Okay, all these transactions are basic transactions. Okay, and then they are hashed, right? So hash of L1 is nothing but hash of transaction L1. Hash of L2 is nothing but hash of transaction L2. Hash of L3 is nothing but hash of transaction L3. Similarly, every transactions are hashed first of all. Then they are paired up together. After hashing, these transactions are paired up together. Then these transactions are again hashed, again paired, again hashed, again paired. So this process of hashing and pairing continues to happen again and again till we get one single top root hash. Okay, this process of hashing and pairing continue to happen again and again until and unless we get one single top root hash. Okay, so this is how Merkle root hashes are created. So all these transactions L1, L2, L3, L4, they are hashed to form hash of L1, hash of L2, hash of L3, hash of L4, and then we see that they are combined together to form hash of 00 plus hash of 01. So technically, when you'll deep dive, you'll understand it is nothing but a combination of binary values. Like if four combinations are there, then 00011011. So 00 and 01 are added together, and again hash is taken for them. So it is nothing but, in simple ways, we can say a process of hashing and pairing, again hashing the pair, again pairing, again hashing the pair, again pairing to get one single top hash. And this is the reason I said that this Merkle root hash has the traces of all these transactions, because at the end this root hash is nothing but it is created from them only, right? This top root hash is nothing but a hash which is created from these individual transactions only. So as you can see there, it is also known as binary T hash, a data structure that is used for summarizing and verifying the integrity of large sets of data. Okay, it contains cryptographic hashes and displayed upside down with root and a top level and leave at the bottom. So that is called as root hash. That's the reason it's called as Merkle root hash. So this algorithm of hashing and pairing is called as Merkle tree algorithm. Okay, as it looks like a Merkle tree. So on the top we have root, and in the very lower level we have leaves. So these leaves gets hashed and paired to form one single top root. So a block of one or more record is collected and such records are then hashed. Then the hashes are again paired, again hashed, again paired, again hashed, again until a single hash remains. And this single hash is called as Merkle root of a Merkle tree. So you can go through this. I hope this makes sense to all of you. Now we'll try to look into the blockchain ecosystem. So when we talk about main components of an ecosystem of blockchain, we have a node application, which we already know what it is doing. A node application which is responsible for validating transactions, creating blocks, and then storing all the ledger information. Then obviously we have a distributed ledger which is stored with all the nodes. And then we have a consensus algorithm which takes care of the whole blockchain network by providing different rules and regulations to be followed. Now we'll discuss about cryptography. Okay, so there are different cryptographic algorithms which are used in blockchain like TripleDES, RSA, Blowfish. So what exactly is a RSA algorithm? You can see it over here. It's a very simple process of encryption that is depicted in this diagram. See if anybody can understand it. It is one of the encryption technology algorithm that is used in blockchain. We have RSA in cipher. Okay, so RSA in cipher acts as an encrypting algorithm which takes in the plain text, that is the plain message that we want to transfer over the communication channel, and the encryption key, that is the public key of the receiver. So we give these two ingredients to RSA in cipher so that it encrypts the information. Then the encrypted information is passed over the communication channel where it reaches RSA decipher. RSA decipher will then use the decryption key, that is the private key of the receiver, to decrypt that message. Once the message is decrypted, then the plain text, that is the original message, will be generated out of it. And once the original message is generated, that is seen by the receiver. So this is just a basic process of how the original message is encrypted by the RSA in cipher, and then it passes over the communication channel. It gets decrypted by the receiver so that the receiver can actually access the original message that was sent by sender. Okay, I hope this makes sense to all of you. So now we'll learn about the consensus algorithm. So as we discussed, like, consensus is just a piece of software with the help of which we are able to control the network, right? So everything that is happening in the network, how the network will behave, how the people or the peers in the network will behave, everything is programmed in the consensus algorithm, right? So over here, what are different types of consensus algorithm? So the consensus provides the technical infrastructure layer for blockchains. This makes it one of the most critical components when accessing a real world use case. Consensus is the key because without a central authority, the participants have to agree on rules and how to apply them. Consensus does two things. First, it ensures that the next block in the blockchain is the only version of truth. Okay, the next block in the blockchain is the one and the only version of truth. And secondly, it keeps a powerful advisories from derailing the system. It makes sure that nobody is able to derail the system. Okay, because it keeps on checking that every miner and every node are managing the true state of blockchain through boot node, if you remember. So over here, consensus is the heart of any blockchain network. So the transactions are recorded in the network. Then you see the transactions are validated by the consensus. Consensus is recorded. Once it is verified, the transaction becomes a part of a new block for the ledger. And then that block is updated on the ledger. So the transaction is marked as completed. So basically, what are the parameters for a consensus? So we have decentralized mechanism. It has quorum architecture. The validation is one of the parameters for consensus mechanism. Integrity, that it enforces the authentication of transaction integrity and validity. Non-cancellation, which means that once the transaction is created, it cannot be, modified or it cannot be cancelled. Confidentiality, fault endurance, and fulfillment. Okay, so these are the different types of parameters of a consensus mechanism. So now basically we'll talk about what are different types of consensus. The first type of consensus algorithm we already know, that is proof of work. So the main goal of a consensus mechanism is to ensure that a blockchain never reaches the state of faulty behavior. A blockchain never reaches a state of faulty behavior. So what does it mean? It basically means that a blockchain never goes or never runs into an error state. That is the main goal of a consensus algorithm. Okay, so what are different types of consensus? One is proof of work, which we already discussed, right? That you do a work, you prove that you have done the work, and you take the reward. So yeah, we already discussed about proof of work, that you do a work, you prove it, and you get the reward. Then we also have proof of stake, which is very, very popular nowadays. The reason for this is proof of work is a type of consensus algorithm that is very, very power hungry. Okay, so proof of work is very, very power hungry, and it utilizes huge amount of electricity. The amount of electricity that is being used in mining of Bitcoin and Ethereum is something that you can't even think of. Okay, and this is a fact. This is a fact that the you know in Japan and in China, huge farming lands have been set up just for mining of Bitcoin and Ethereum. And the amount of electricity that is being consumed in those mining farms or in those mining lands can actually run a whole nation. So it is that much power hungry. Okay. So somewhere proof of work is not very nature friendly. Although when it started, okay, I'll explain this as well, that how it became so power hungry. Okay. Because when it started, it all started with a single simple system. Like I am having a system. With my own system, I could have mined Bitcoin and Ether in the starting era of Bitcoin and Ether. But today, like my system, I would need at least thousand and ten thousands of system. Like if you take a power of my system, normal my system, like I 8 GB RAM and i7 processor, and like 2 GB of or 4 GB of graphics. Okay, so that will create some computation power. You multiply that computation power by 1,000. That is the amount of computation power that is needed at least to participate in the process of mining of Ethereum and Bitcoin. Just to participate. You will win or not, that's a different thing. But just to participate. So when it started, it was not like this, but today it is like this. So somewhere it is utilizing lot of electricity, lot of computation power, and that is the reason proof of stake is coming into popularity, because proof of stake is or proof of stake can be applied with just a single simple system. Like right now I'm having a system, this is more than enough to participate in the proof of stake consensus algorithm. Okay, but what if after some time even proof of stake becomes power hungry? That would never be. So the proof of stake is designed in such a manner that it would never be power hungry. Why? Let's see that. So in proof of work, what happens? In proof of work, the major reason of this power hungry thing is the competition among miners, right? Who will solve the puzzle first? And as I told, it is not a simple puzzle like 2 into 2 into 2 that a miner has to solve manually. All these things are automatized. So when I say miners are in competition, it's actually wrong to understand that those people are in competition. No, their machines are in competition with each other. Okay, so when I'm a miner and if you are a miner, when I say that we are in a competition, we are not in a competition because we are not doing anything. Whatever is being done, it's being done by our machine, and that too in automatized manner. So I'm not going to solve any puzzle manually, right? So it's all done by the machine. So if my machine is more computationally strong than your machine, obviously I'll solve the puzzle first, right? More number of machine cycles can be utilized by my machine as compared to your machine, and then I'll solve the puzzle first, right? So it all depends on the computational power. So you are losing for many time. What you'll do, you will increase the computational power even beyond my computational power. So now what will happen? Now you will start winning and I'll start losing. So what I'll do, I'll again increase my computational power so that I can beat you. Now again, I'll start winning, you'll start losing. So what is happening over here? Now we are in a competition with each other to enhance the computational power of our machine. And now you understand that why it started just with a system and now it is at such a level where the electricity being consumed for mining Bitcoin and Ethereum can run a whole city like New York or run a whole small, very small nation as well, country as well. So this is the reason how it started and now where we are. So the power hungry behavior of mining led to this. Okay, so the most important problem over here is the competition among miners or competition among miners machine to be precise, right? But what happens in proof of stake? Let's see that as well. So now we'll understand like what is proof of stake. Okay, so with the term only you can understand that when we talk about proof of stake, it is nothing but a miner, or basically over here it is not a miner. The technical term used in proof of stake is a validator. Okay, please understand this. In proof of work we have miner, but in proof of stake we don't have miner. In proof of stake we have validator. So a validator will stake a portion of that token. Okay, let's suppose if it is about Ethereum blockchain, so a validator will stake some of his ethers, like maybe a validator will stake 1,000 ethers. Okay, and then there is another validator who has staked 5,000 ethers. Then there's another validator who has staked just 20 ethers. Okay, obviously there will be a minimum cutoff, but let's not talk about that minimum cutoff, but let's understand it like some validator has staked 1,000, some validator has staked 5,000, some validator has staked 20 ethers. Now these different validators who have staked different amount of ethers, they will automatically be getting the chance to create blocks and validate transactions. They are not in a competition among each other with respect to solving a puzzle or something like that. They are just in a competition to each other for staking more number of ethers. So whichever miner or whichever validator stakes more number of ethers will get more chance to validate block and validate transaction. So if I have invested just 20 ether, does that mean that I'll never get a chance to create a block? No, it's not like that. It's like you will get less chance as compared to the one who has staked 1,000 ether, and 1,000 ether will get even less chance as compared to the person who has staked 5,000 ether. But over here even 20 ether person would be getting a chance. But over here if you have 8 in proof of work, unlike proof of stake, in proof of work, if you have 8 GB RAM and if someone has 10 GB RAM, so most of the chances are that always 10 GB RAM will win, because always 10 GB RAM will solve the puzzle, right? So 8 GB RAM will lose always. I hope you get this. So over here, everybody can get the chance of creating and validating the blocks and transactions, unlike proof of work. And also they don't have to be in any competition. This is not power hungry. Even with my single mobile phone, I can stake my Ether and that's it. I would be able to get a chance and I'll be able to validate transactions and blocks. And automatically for those respective blocks and transactions, I would be credited back with my reward. So the more is the number of ethers you stake, the more chances you will get to validate blocks, and obviously the more reward you would be getting. So it is all dependent on ROI, return on investment. So more is your investment, more is will be your return. I hope you get this. So this is what happens in proof of stake. So another important thing is, even it's not only about having ether, but it's more about staking ether. Maybe I have 1,000 ether. Okay, maybe I have 1,000 ether, but I have staked only 100 ether out of my 1,000 ether. I have staked only 100 ether. So I will be given a chance to validate transactions and blocks with respect to this 100 ether only. Okay, although I have 1,000 ether in my account, doesn't matter. What you have staked is what will be counted. So when you stake, what's the difference between having number of ethers and staking a number of ethers? So basically when you have it, it's like, if I have to give a very simple example for this, is something like this. Like you have some money in your bank balance. Okay, so that's some money that you can use at any point of time. Wherever you want to use it, you can use it. But then you convert some out of that bank balance into a FD, fixed deposit. So when you convert it into a FD, it becomes like it gets logged for a certain number of years or months, right? It gets logged. Although in reality it never happens. Now even it is flexible, but let's not go in that direction. Let's assume that when you talk about fixed deposit, then like earlier days, it just gets logged for that many number of months or years. So you cannot use it. It's like a logged balance. So in the same way, what balance you have, that you can use at any point of time for sending, receiving, purchasing, buying, whatever you want to do, you can do. But when you stake a number of ethers out of that, then that gets logged for like 6 months or 8 months or whatever it is, the time tenure that is defined. It gets logged for that much amount of time. Perfect, guys. So this is what is proof of stake. Let's see this. So proof of stake is a category of consensus algorithm for public blockchain that depends on validators' economic stake in the network. So pioneered by Peercoin in 2011. Now many versions exist like Next, Enderman, Flying Fox, etc. So this is the important line. Your chance of being picked to create the next block depends on the fraction of coins in the system you own. Okay. Okay, perfect, guys. So then at last we have yet another type of consensus algorithm, that is proof of elapsed time. Okay, so mostly proof of elapsed time is used in private blockchain. So what is the purpose of proof of elapsed time? Over here, there is absolutely no competition, or rather, over here, the process of creation of block is automatized. Even the process of creation of block is automatized. In private blockchain, there is no miner, there is no validator, there is no mining reward, there is no transaction fees, nothing is there. There is no fees implicable in a private blockchain because there is no crypto in a private blockchain. If you want, you can have it, but by default, there is no cryptocurrency in private blockchain. So like in Ethereum, by default, you always have a currency that is Ether. In Bitcoin network, you always have a currency that is Bitcoin. But in private blockchain, there is no such default cryptocurrency. So what happens is there is no hustle to create a block. So we can automatize this process of creation of block. So we create a block after every set of interval of time, like 5 seconds or 10 seconds or 3 seconds, whatever you define. So that's the reason it's called a proof of elapsed time. So as soon as a specific amount of time has elapsed, a block will automatically be created. Okay, again, like it can be 5 seconds. So after every 5 seconds, a new block will be created. But the transactions present inside this block will be validated by somebody. By whom? Endorsing and committing peer and all these things that we will learn about in private blockchain. Okay, but for now we can understand that proof of elapsed time is like a consensus algorithm which automatizes the process of creation of blocks after every fixed interval of time. Does this make sense to all of you? So what happens over here? Proof of elapsed time is a Nakamoto-style consensus algorithm that is designed to be a production-grade protocol capable of supporting large network population. So POET relies on the source instruction execution to achieve the scaling benefits of Nakamoto-style consensus algorithm without the power consumption drawback of proof of work algorithm. So proof of elapsed time simulator which provides POET consensus on any type of hardware including virtualized cloud environment. So even if you want, you can configure POET simulator on a virtualized cloud environment, and that cloud environment will self take care of creation of new blocks after every fixed interval of time. So where it is used by Hyperledger Sawtooth and multiple other Hyperledger frameworks as well. So what are the advantages? Fairness, investment, and verification. So I hope with this we are able to understand completely about different types of consensus algorithm. Any questions? Any doubts, guys? Now we'll move on to that is about mining. So over here we'll understand about distributed ledger. So as you can see, blockchain platforms don't use a centralized database. Instead, each node has a copy of the ledger.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Okay, and the round orange color circle over here in the diagram resembles a node, and the file type icon that you see within each circle, that resembles a copy of ledger, right? So cryptocurrencies such as Bitcoin can only store the balance information in the distributed ledger, whereas blockchain platforms like Ethereum can store any kind of information such as identity information, patient information, real estate information, etc. in a distributed ledger. So basically, yes, over here, as you can see that Bitcoin blockchain can only be able to process transactions, which means you can just send some Bitcoins from one person to another. So on top of Bitcoin, you cannot program your own business logic. Okay, if you want to run a business on top of Bitcoin, if you want to run a smart contract, if you want to write a program, a smart contract on top of Bitcoin, or if you want to create a decentralized application on top of Bitcoin, that is not possible. But it is possible in case of Ethereum. So in case of Ethereum, you can write a smart contract that can store any information on the ledger. So let's suppose you're creating a business, you're writing down a business, and that business wants to store some information like who shipped what at what point of time, or who purchased what asset at what point of time, or who shared what information at what point of time. All these data can be stored on a public blockchain network like Ethereum, but it cannot be stored on a public blockchain network like Bitcoin. So this is the major difference that this point is talking about. Then we have public or permissionless ledger. So what is there in public or permissionless ledger? So when there is no central authority managing the access to the ledger is called public ledger or a permissionless ledger. Okay. So what happens when there is no central authority? Like there is no person required, or there is no authentication, or there is no approval required to be a part of the ledger. Okay, that's a public ledger or also known as permissionless ledger. So the way Ethereum is there. So if we go on Etherscan and if you monitor this closely, you will be able to see that I don't have to sign in. Even without signing in, okay, I'm able to see all the information. I'm able to see what's the price of ether, transactions of ether, gas price, and all these things, like what are the latest blocks that are added. I can see all the details about the blocks, I can see all the transactions that are happening, and every detail is visible to me. Why is it so? Because it is a public ledger or a permissionless ledger, which means I don't want to, or I don't have to uh, get access from any central authority, or there is no central authority who is managing the access to the ledger. And that's the reason these are public blockchain or permissionless blockchain. And then we have a private ledger, or also known as permissioned ledger. So what happens in a private ledger or a permissioned ledger? So when there is a central authority managing the access to the ledger is called a private ledger or a permissioned ledger. Okay, let's read that again. It says when there is a central authority managing the access to the ledger is called private ledger or permissioned ledger. But over here, I can clearly see that there is a central authority. When there is a central authority, how can it be blockchain? Because in blockchain, there is nothing like centralization, there's nothing like central authority. But over here, I can clearly see that there is a central authority which is managing the access to the ledger. So, how is both the thing possible? Because both are contradicting to each other. Either there can be a centralization or central authority, or there cannot be a central authority. Okay, so this is obviously a distributed ledger, chain of blocks connected together. And over here, these are group of peers, and this is the central authority. So, what is the role of central authority over here? Central authority is centrally managing this whole ledger and can always do whatever they want to do? No. Central authority is just responsible for providing access to the people. That's it. Okay, so you can clearly read it out over here as well. There is a central authority managing access to the ledger, not managing the ledger itself. Okay, central authority is managing the access to the ledger, not the ledger itself. So that means that there is a central authority, but it is just responsible for managing that out of this whole public, who should be able to be a part of this blockchain network and whose request should be denied and they shouldn't be allowed to be a part of this blockchain network. That is the only role of this central authority. Once the people have become a part of this blockchain network, then again things are absolutely decentralized for them, the way they are decentralized in case of a public blockchain. Okay, so this centralized authority or this central authority is just responsible for managing the access to the ledger and not the whole ledger itself. I hope this makes sense to all of you. We have Hyperledger, we have Corda, we have multiple other blockchains as well, with a small blockchains which have recently been created. Most of the blockchains are public, only some are there in the private blockchain side. So now this is a simple diagram which tells that, till now we have been considering that a file is when we say that there's orange ledger, I mean there's orange color circle which represents a node. So it is basically a node, that's fine. But then when we say that a file type icon which was representing a ledger, that is actually not a ledger, right? That is actually not a ledger because it is just a what do you say a single file type icon. But what actually is a ledger? So in reality, a ledger is nothing but a chain of blocks connected together, right? So a ledger should correctly be depicted like the one which is represented in the above figure. As you can see, there are multiple blocks that are connected to each other, right? But the important point over here is when I say multiple blocks connected to each other, why are they available in a non-linear fashion? When I say multiple blocks connected to each other, till now, how have we represented ledger? Till now, every time we have represented ledger something like this, chain of blocks connected together, right? Chain of blocks connected together. But what I'm seeing over here is some more branches are coming out. More branches are coming out from different blocks, right? That's what I'm seeing over here. You see? So it's not a linear chain. So till now we have always understood that a ledger is nothing but a linear chain of blocks connected to each other, right? A linear chain of blocks connected to each other. But then why are these branches coming out? From somewhere we see these branches coming out. right? This is what it looks like, right? Okay, let's understand this. So basically what happens over here is we have multiple blocks that are connected to each other. So that's a true fact that, there are multiple blocks connected to each other. But then why there is no linearity? The problem is, I mean, the question is, or not the problem, but the question is why there is not linearity? Because till now we have understood that there is a linear chain of blocks connected to each other, and that is what forms a ledger, right? But then why are these branches coming out? So if you remember, someone asked this question as well, that what if two miners solve the puzzle at the exact same time? What if two miners solve the puzzle at exact same time? Okay, so this is exactly what happens when two miners solve the puzzle at exact same time. Let me show it to you like this. So what happens is, as we can see over here, so this is the Genesis block. There are two rules. Please understand this. There are two rules in the network. First, the miner should always work on the longest chain if available. Miner should always, I'll write in shorthand, always work on longest chain if available. First rule. Second rule is the miners, I mean the consensus modifies the puzzle on the basis of active miners. On the basis of active number of miners. Okay. So there are two rules that are followed in the network. The first rule is very important. Second one is more like a protocol, not a rule. Okay. So what is happening over here is, so this is the Genesis block. Okay. After that, what is the longest chain? Obviously, this is the only block, so this would be the longest chain. So the next block that would be coming up, please understand this very carefully. The next block that would be coming up. So this miner who has created this block will always attach to this block only. Okay. Now after that, what happens is two miners solve the puzzle at nearly same time. Two miners solve the puzzle at nearly same time. I mean, almost the same point of time, both the miners have solved the puzzle. Because what is puzzle? Nothing but the consensus algorithm broadcasts the puzzle in the network. So whosoever solves it first will be the winner, and the miner will that miner will be able to add his or her block to the network. So let's suppose both these miners solve the puzzle at the same time. So what will consensus say? Okay, you both are winners. You both can add your block to the network. Now when both the blocks are added to the network, obviously what will happen? Obviously, there will be same transactions present in this block also and this block also. I told you that when it is in the same time, then obviously both the miners will become same transaction, right? So what will happen is everything now is dependent on the next upcoming block. So till here, do we have any longest chain? No, right? Because both are of same length. This chain also is of same length and this chain also is of same length. So this block becomes, or this block gets trapped in a dilemma to which block it has to get attached to, because both are of same chain. So this block will have a liberty of getting attached to any block. This block, the upcoming block, will have the liberty to get attached to any block out of these two blocks. Either it can get attached to the lower block or it can get attached to the upper block. Okay, if it gets attached to the lower block, the upper block is known as orphaned block. If for some reason the upcoming block gets attached to the lower block, the upper purple block is called as orphan block. Okay, what is orphan block? Orphan block is like a dead data available in blockchain. Orphan block does not has any impact on the network. Orphan block does not has any significance in the network. Orphan block data is just a dead data which has got no relevancy, no significance, and no impact on the network. Okay, so what about the miner who created this orphan block? Because that miner did everything that was required to create a valid block, and that block was also accepted. But then, for some reason, it became orphaned. What will happen to that miner? Will he be getting the reward or not? No, unfortunately, he won't be getting any reward. Okay, but isn't it somewhere unfair to that miner? Yes, it is, but can't be helped because this is how it functions. So unfortunately, if your block becomes an orphan block, that you won't be getting any block reward or transaction reward for that block. Okay, so on how does this upcoming block decide that to which block it has to be attached to? Like, how does it decide that I want to get attached to lower block or I want to get attached to the upper block? It is nothing to decide in that. It's absolutely random and it's absolutely automated. So it can get attached to any block randomly. To whichever block it gets attached to, the other block will become orphaned. Simple. And the one which becomes orphaned will not be getting the block reward and the transaction reward. And that is the reason you'll see sometimes these branches are coming out, but they're always temporary. They're always temporary. Why they are temporary? The reason is, at the end only one branch will continue to work, because this new block that came up, that block was having a choice. It can either get attached to the upper block or the lower block. But after that, whichever block will be coming up, that will not have choice, right? Why it will not have choice? Because of the first rule: the miner should always work on the longest chain available, if available. So over here, is the longest chain available? Yes, absolutely, because this chain is of 4 blocks, whereas this chain is just of 3 blocks. So the upcoming block will definitely be attached to the longest chain. And again, the further upcoming block will be attached to the longest chain. So that is why always one single chain of blocks will be pertaining. Sometimes some temporary forks can be created, but they will have no significance on the network. Okay, fine. All these things are good, but then what consensus algorithm does in order to make sure that consensus algorithm, consensus algorithm, what it does in order to make sure that this thing doesn't happens very randomly, or this thing doesn't happen very frequently. Okay, what does consensus algorithm does in order to make sure that this doesn't happens every frequent, I mean, very often? It doesn't happen very often. What does the consensus algorithm does? That is the reason why we have a concept of difficulty in Ethereum blockchain. What is this difficulty level? You'll see with every block there is a difficulty associated. With every block there is a difficulty associated. What is this difficulty? Basically, the consensus algorithm, what it does is it keeps on modifying the value of the consensus. I mean, it keeps on modifying the puzzle of the consensus and the difficulty of the puzzle. So basically, if less number of miners are available in the network, if less number of miners are active in the network, then obviously the competition is less, right? Okay, let me give you an example, a basic example for this. What if I tell you that there are only 5 people? Okay, there are only 5 people, and I give a basic problem to them. I want to just know who answered the question first. So I'll give a problem like 5 into 5 into 5, a basic mathematical problem like 5 into 5 into 5. I'll give this problem to them and I'll say that whosoever answers it first, press the buzzer or tell the answer. So when they tell the answer, because there are only 5 people, I would be able to know that who gave the answer first. Even if 2 people almost at the same point of time, also if they'll give the answer, then also I'll be able to make it out that among those 2 people who nearly gave the answer at the same point of time, who actually gave the answer first. I'll be able to make it out because there are only 5 people. But what if there are 50,000 people? Rather than 5 people, there are 50,000 people. Can I give the same puzzle to them? No, right? If I give the same puzzle to them, it would feel like I'm getting 125, like almost everybody is saying 125, right? And I cannot figure it out who gave the answer first. What is the solution to this problem? I'll have to increase my difficulty level. So rather than giving 5 into 5 into 5, maybe I'll have to give 125 to the power of 125 to the power of 125 to be solved by them. Then definitely I'll be able to figure it out who gave the answer first, right? Same concept is applied in blockchain as well. So when the number of active miners available in the network are less, then the competition is less, so the difficulty level of the puzzle is also less. The consensus algorithm broadcasts a simple or a less difficulty puzzle. But when number of active miners increases in the network, the competition increases in the network. So obviously difficulty level has to be increased, otherwise this temporary forks will be created. So difficulty level is also increased so that less number of miners are only able to solve it, and whichever is able to solve it also, we can easily figure it out which miner solved the puzzle first. So that is the second protocol, that consensus algorithm modifies the puzzle, the difficulty of the puzzle on the basis of active number of miners. So this is what consensus algorithm does in order to make sure that orphan blocks are not very oftenly created.
What are the platforms for implementing blockchain? Nowadays, since blockchain has evolved a lot in last 1 decade, there are many developers, organizations, investors, and ideas generators have evolved with various kind of blockchain platforms. So nowadays there exist multiple blockchain with multiple facilities, multiple advantages, and multiple features, out of which we will be discussing about few that constitute important area inside blockchain terminology. The first one is Ethereum. We all might have heard about term Ethereum. It is a public permissionless blockchain, a blockchain platform that lets anyone build and use decentralized applications that run on a blockchain technology. Like Bitcoin, no one controls or owns Ethereum. It is a public permissionless blockchain network where everyone can participate and transact and earn token or currency. Then comes multi-chain. This is again a blockchain platform for the creation and deployment of private blockchains, permissioned blockchains. So it can be used either within or between organizations as well. So this is permission. So this is permission, and it requires permission in order to transact and participate in the existing blockchain multi-chain network. Hydra chain, a joint developed effort of Brainbot Technologies and the Ethereum project. It supports the creation of scalable blockchain based applications. Then comes Hyperledger. This is again becoming very much famous in blockchain technologies. It is an open source collaborative effort created to advance cross industry blockchain technologies. It is supported by Intel and open source Linux Foundation. Then OpenChain. OpenChain is again a blockchain platform that is well suited for organizations wishing to issue and manage digital assets. It takes a different approach than the standard Bitcoin approach on implementing blockchain. Then IBM Bluemix. Being a giant player, IBM also allows and have their own blockchain network and platform that is on IBM Bluemix, built on top of Hyperledger project, and it offers additional security and infrastructure facilities for enterprises. So IBM are preparing blockchain in such a manner that they are enterprise ready and can be directly used by enterprises and financial or other organization to start and migrate their existing applications to blockchain network in order to facilitate and utilize the features and benefits provided by blockchain. There is another kind of blockchain network exists that is called chain, yet another and well suited for financial applications based on chain core, which is an enterprise software product. Then IOTA is another blockchain that is a revolutionary new blockless distributed ledger which is scalable, lightweight, and for the first time ever makes it possible to transfer values without any fees. If we see, the above blockchain platforms take some amount of fees in one form or other, while IOTA helps, that is again a blockless distributed ledger and do not take any fees for doing transaction over blockchain network. There are various more. BigchainDB, an open source system that starts with a big data distributed database and then adds blockchain characteristics, decentralized control, immutability, and the transfer of digital assets. Then comes Corda. It is again a digital ledger platform which pluggable consensus. So multiple consensus can be used here, plugged with the blockchain and utilized, and simply forms a different kind of blockchain with flexibility of adding pluggable consensus. You can anytime change the consensus algorithm from proof of work to proof of stake, from PBFT, from POET. So it provides various options of using multiple consensus algorithms. Quorum, an open source digital ledger and smart contract platform based on Ethereum, that is customized Ethereum platform using distributed ledger and smart contract. Stellar, an open source distributed payment infrastructure that provides RESTful HTTP API servers which connect to Stellar core, the backbone of the Stellar network, and help you giving a blockchain network where you can utilize and do your transactions related to your business need. So at the end of this session, you should be able to identify Bitcoin at its era, understand where and how to get the Bitcoins, identify Bitcoin wallets, identify Jack's wallet, define selling Bitcoins, compare Bitcoin blockchain, transaction and transaction script, describe various transaction forms in Bitcoin, define scripts in Bitcoin, list nodes in Bitcoin network. So let's see what Bitcoin is and what was its era. Even this era time also can be considered as Bitcoin era only because it is again still booming in form of a cryptocurrency and stands very strong against all existing currencies like dollar, pounds and any other. So let's learn about the history of Bitcoin and its detail of Bitcoin. In 2008, Bitcoin.org was registered by Satoshi Nakamoto. Bitcoin, a peer-to-peer electronic cash system, white paper posted in October 2008, and that was the first time when world came to know about blockchain or Bitcoin. In 2008, Bitcoin kept growing and Satoshi mined the first Genesis block of 50 Bitcoin in January. The first block in the Bitcoin blockchain, as we all know, is called Genesis block. So the first blockchain Bitcoin's length was 50 Bitcoin containing Genesis block. Bitcoin 0.1 released on cryptography at meltdown.com and Usenet. Then coming to 2010, first offline transaction of 10k Bitcoin for 2 pizzas was done successfully. And first specialized GPU hash miners and pooled miners operation was also successfully done. In 2011, continuing the journey of Bitcoin, it took parity with US dollars first time ever. It came into existence as a global currency. $31 top of first bubble followed by the first price drop. 2012 December $13 slowly rising for a year as it was really fluctuating. So during history of Bitcoin it kept fluctuating yet kept creating history in the financial market and showing people the strength of blockchain. In 2013 November Bitcoin broke $1,000 in second bubble. It was a peak for Bitcoin currency, but sadly, in December 2013, prices crashed again to $600. In 2014, prices fell again following the shutdown of Mt. Gox, impacting the Bitcoin market. Bitcoin continued to fall due to a false report regarding Bitcoin ban in China. There were various fake news around Bitcoin. People were not secure. False news were generated by the financial markets. It is online money. It's not secure. Hackers are driving it. Blah blah blah. In April, it started stabilizing at $450 after a long time. After a long fall, it stabilized at $450 value. In 2015, prices fell again through to early 2015. Large spike in value from 225 to 250 at the start of October to 2015 was recorded and the record high was $504 in 2015. Price again stabilized to low $600 range in 2016 as the Chinese renminbi depreciated against the US dollar. Bitcoin rose to the upper $700 during this period and renminbi depreciated against the US dollar. Bitcoin rose to upper $700 again. In 2017, prices fell 30% in a week, reaching a multi-month low of $750 again, and prices broke above the November 2013 high of $1242 and then traded above 1290 again. That was again a good highest of Bitcoin. Price reached its maximum in the history of Bitcoin, reached all-time high of ever $12,500 in 2017. So that was all about history of Bitcoin, how it started moving in the market, how it captured the market, it became popular, how it fell and rise in the market, and were the values it attained during its whole history. Even in these days, Bitcoin stands strong against dollar. And if we talk about the current value of Bitcoin in dollar, so in today's date as well, it stands strong against dollar and has value of 3,857 US dollar. So really stands strong in nowadays as well and still growing. And one Bitcoin is equivalent to 3,857 US dollar. So you might have heard the people invested that time initially in the blockchain and the Bitcoin are really went into very good amount of profit and it was having a boom at that particular time. Along with Bitcoin, there were multiple other cryptocurrencies that evolved and attained a very good value, and even sometimes they even defeated the value of Bitcoin in the market. So, if we talk about Bitcoin, the first blockchain focused decentralized digital currency was Bitcoin. uses consensus to control its creation and management rather than relying on a central authorities, that is the role of mediator, held electronically in a P2P open ledger called the blockchain. That was the first ever blockchain developed. The first ever idea of blockchain. They are not printed. They are produced by people using software that solves mathematical problems. And those mathematical problems are called consensus. Those puzzles are used in order to create new blocks inside the network and as part of the award against the creation of new block. Why to use bitcoins? It is super fast. As we all know, there is no mediator. Transactions are instantaneous. If they are zero confirmation transactions, or they can take around 10 minutes in a merchant requires confirmation. They are really cheap. Bitcoin transaction fees are minimal, and in some cases they are free too. It's absolutely decentralized. Because the currency is decentralized, you own it. No central authority has control over bitcoins. They are autonomous and free inside the network. Never worry about chargebacks. Once bitcoin has been sent, they are gone. A person who has sent the bitcoin cannot try to retrieve them without the recipient's consent under any circumstances. That means if you have spent your bitcoin and transferred it to some other person, you cannot retrieve it back. You cannot claim it back because there is no central authority. You have to request the recipient of the money or Bitcoin in order to send it back to you. Otherwise, there is no option. If your Bitcoin is gone, then it is gone. It also acts as the best payment security. Transactions don't require you to give up any secret information. They use two key public and private key that are given at the creation of your node and your wallet. It is not inflationary. Bitcoin has been assigned a hardwired value of $21 million in its protocol itself. So any time in its lifetime, it can achieve maximum value of 21 million that can be created until it is itself changed in the protocol from from 21 million to some other value. But till date, it can grow to 21 million only. It's really private. It is like having a clear, it's plastic wallet with no visible owner. Everyone can look inside it, but no one knows who owns it. Make your own money. You can certainly buy bitcoins in the open market, but you can also mine your own if you have computing power. You can participate as a validator node and solve the problem. Proof of work can be used to solve the problem, and if you are a winner, you will be rewarded with the bitcoin by solving the problem. Now, where and how to get the bitcoins? In order to sell or buy a bitcoin, customer has to join the Bitcoin blockchain network. You can buy the Bitcoin using your wallet, your credit card, or online also. To start with, a user must install a virtual wallet onto a PC or mobile device. The wallet keeps track of your Bitcoin balance and all transactions. Bitcoin can be bought either through online payment or through any company. Once the funds are available, a buyer can place an order for a Bitcoin similar to trading stocks through various online exchanges, and then it can start participating in the blockchain network. Bitcoin can also be purchased from third parties, which sends the coin directly into your virtual wallet. Every time you transact, you will be using your wallet address in order to buy or sell Bitcoins. Bitcoin and its client. To join a Bitcoin ecosystem and start using a cryptocurrency, all the users are required to do is download an application or use a web-based application that is client. There are three kinds of clients available in order to transact with the Bitcoin: full client, web client, and lightweight client. Full client stores the complete history of Bitcoin transactions and manages the user's wallet and capable of initiating transaction directly on the Bitcoin network. That means it has full access and full role inside Bitcoin network and can manage the transaction and keep record of them. Web client. Web clients are accessed through a browser and stores the user's wallet on a server owned by a third party. They are used by exchanges primarily. So you can open a web client, do your transactions on a Bitcoin using third party user's wallet. Then comes lightweight client. This type of client stores the user's wallet but relies on third party owned servers for access to the Bitcoin transactions and network. So there are three kinds of Bitcoin: full client, web client, and lightweight client available with the help of third parties or maybe Bitcoin network to allowing you transaction over Bitcoin network. Bitcoin wallets. So as we discussed about Bitcoin wallets and Bitcoin currencies, we should know how these wallets are created and how they are stored against and for each pair. There are various Bitcoin wallets or clients available in the market. Web wallets. Web wallets are website or even online exchanges that allow storage. Example blockchain.info, Coinbase. So these web wallets you can use online and store your Bitcoin currencies. Mobile wallets. A smartphone wallet makes it really easy to scan QR code to make quick payments via phone only. No need to go to the browser for same. Example stands Bread Wallet, Mycelium, Earbids, Greenbits, etc. Since now we are very friendly to our mobile phones, gadgets, so mobile wallets are introduced, and like Paytm and other apps, you can use QR codes of your Bitcoin and do purchase and sell over the Bitcoin network. Then comes desktop wallets. Similar to mobile wallets, they use apps installed on a personal computer like desktop or laptop, and they act as a wallet to transact on Bitcoin network. Example, Electrum, Multibit, Armory. Hardware wallets. A piece of hardware is used to store the private keys to your Bitcoins. Example, Ledger Nano and Trezor. So you are storing your private keys in a hardware wallet, and that can be used for further transactions. Then comes paper wallets. It is the most secure cold storage solution that is used for storing your private keys and can be used as a wallet for Bitcoin transactions. Example, Coindesk, Bitaddress. Then multi-signature wallets. These wallets require multiple private key signatures to make a transaction. That means you need to have multiple private key signature before you initiate and sign your transactions over the Bitcoin network. Example are Carbon Wallet, Coinbase, Blocktrail, Electron, and CoinKite. More details about these wallets can be found on web. Those who are interested in reading the details of these kind of wallets, how these are developed, designed, and used for storing the bitcoins. So this slide shows comparison between different kind of wallets. If you see here, we have web interface, mobile app, desktop client, independent wallet, privacy, security, newbie friendly. All these criteria and features can be compared again each kind of wallet available. We can have hot wallet, we can have hardware wallet, we can have again multiple type of hot wallets to store our Bitcoin or payments. So in your hot wallet, web interface are available. In some of them it is available and some it is not. Mobile app for some of hot wallets are available. For some it is web client, that's desktop client available. Then in all kind of wallets you could see privacy and security is same and good because they are operating on blockchain networks. So these are example of different kinds of wallet that you can see what features they provide and what features they do not provide. So if we talk about the features and comparison of these wallets, you could see and follow the below table. Web wallet is unsafe, easy for beginners, very convenient and free of cost. While mobile wallets are unsafe, again, easy, very convenient and free of cost. So using web and mobile wallets is not suggestible. Desktop wallets are safe, bit complicated for beginners, average in convenience and again free of cost. Hardware wallets are very safe. They are little complicated, and if we talk about convenience, they are not convenient and they require certain amount of cost to be spent in order to use hardware wallet, maybe 90 to 400 US dollars. Paper wallet. These are considered again very safe and really difficult for use for beginners, non-convenient and usually free. Then multi-signature are again safe, difficult to use for beginners. Convenience varies as per the uses of multi-signature wallets and is again free. So this was all about wallets. Now we will be discussing about different kind of wallets that exist in the market and provide convenience for Bitcoin transactions in our next session. Let's see what all wallets exist following these types of wallets. Jaxx wallet. Now that we have discussed and compared various Bitcoin wallets, let's see a wallet in working called Jaxx wallet. Jaxx wallet is used for Bitcoins, and when you log in to use it, this is how its home screen looks like. You can create new wallet or you can restore your existing wallet using the UI. Once you press on continue, you get a next screen where you can receive bitcoins from senders, or you can also become sender and send bitcoins. And there is also a QR scanner code available that can be used for easy transactions using this wallet. In turn, this wallet will show your balance also in terms of Bitcoin and in terms of US dollar. The second section of this Jaxx wallet shows your transaction history, the number of transactions that you have done, you own the Bitcoin, and along with the details. So when you start sending your Bitcoins from Jaxx wallet and you click on the send, you have to enter the recipient address, the amount of Bitcoins you want to transfer, and then you have to click send in order to send the Bitcoin. So procedure for sending the Bitcoin, as is summarized in the last picture, using the Jaxx wallet, you have to click on the send button. In the address section, that you have to paste the Bitcoin address of the person you are willing to send the Bitcoin and the amount you want to send, and then click the blue icon for send and sending the Bitcoins. Even if you want to generate or receive Bitcoins through Jack's wallet, you have to click on receive. You have to click on the amount that you want to generate and receive from the address. So step 4, you request your payment using your QR code, or you can give your address for the transaction, requesting the Bitcoin for that particular amount. Okay, so this is how you can send and receive Bitcoins using your Jax wallet. There are other similar wallets exist in the market which have similar functionality as of Jax wallet with some different GUI. Now, the second important point comes to secure your wallet. How you are going to secure your Bitcoin wallets. There are multiple ways to secure and make your Bitcoin wallet more secure. You can encrypt the wallet in order to protect your wallet from prying eyes is to encrypt it. This makes it difficult to access your wallet but not impossible. You have to use public and private key pair in order to encrypt the wallet, and while using you have to use the decrypted version of it. You can use multisig that allows multiple parties to partially seed an address with a public key. The required number of signatures is agreed at the start when people create the address, and that is more secure as compared to normal encryption of the wallet, where you are using multiple signature that is used by multiple seeds and peoples in order to create a signed address. Third option is you take a backup of it. Backing up your wallets makes a copy of your private keys, but it's important to back up your whole wallet. You can also take it offline. Cold storage wallets store private Bitcoin offline, and they are not accessible over internet, and this also makes it secure, that is available to you only. How to buy your first Bitcoins? It is still quite difficult to acquire Bitcoins in most countries. Cryptocurrency exchanges are the easiest way to buy Bitcoins. So you can do them. You can buy your first Bitcoin using Bitstamp, a European currency market that supports several currencies including euros and US dollars via wire transfer. You can use Coinbase, a US-based Bitcoin wallet and platform where merchants and consumers can transact into Bitcoin. ZipPay. ZipPay is the fastest and easiest way to buy and sell Bitcoins in India. So if you want to purchase and sell your Bitcoins in India, you can use ZipPay. CoinSecure. CoinSecure is the most secure Bitcoin exchange to buy, sell, and accept Bitcoins over internet. So these were some sort of mechanism, some sort of options using which you can buy your first Bitcoin over internet. And all our options available are using cryptocurrency in order to exchange your Bitcoins in easiest manner. Now, how to sell your Bitcoins? You have option of selling the Bitcoin in two manners, selling Bitcoins online or selling Bitcoins in person. How to sell Bitcoins online? There are three ways to do so. Direct trade involves a trade with another person directly over internet. Exchange trades involves an online exchange where you can trade with the exchange rather than another individual or any unknown person. So you are doing Bitcoin exchange or selling in form of exchange, trading over the internet. Peer-to-peer node or peer-to-peer trade allow Bitcoin owners to obtain discounted goods with their Bitcoin via others that want to obtain the cryptocurrency with. So they are trading in Bitcoin. You have option to trade in Bitcoin. You can buy discounted goods with your Bitcoin over internet via others that want to obtain cryptocurrency in return. These are few examples of selling Bitcoins. Online with exchanges, websites that offer this type of selling model include Coinbase and local Bitcoins in the US, and BitBargain UK and Bitlicious in the UK, and many other exchanges across the globe. You have option to transfer or sell Bitcoins peer-to-peer. Again, the marketplace acts as an intermediary, offering users the platform, Bitcoin wallet, and escrow for transactions. So these are some examples of selling Bitcoins online or offline. But beware of using website for transacting into Bitcoin. There are various fraudulent websites available in the market online that may cheat you and exploit your internet in order to hack your system and spoil the Bitcoin amount available in your wallet. So you need to be very careful while sending your information and transacting with online parties that simply anonymous to you. Always buy and sell Bitcoin from authorized vendors. So this screen shows various places to spend Bitcoins. One example is Bitcoin Store, where you can buy multiple items in exchange of Bitcoin, and that acts as a online marketplace that sells a variety of electronic gadgets. Then you have BitPremier, Luxury Bitcoin online only marketplace where you can find anything from high performance sports cars to work of art and even real estate also. Then you got gifts, that is used to buy, receive, redeem and send digital gift card for over 200 retailers including Amazon and Sears, Target and GameStop. So gift is used to buy coupons or digital cards, gift cards. Now they accept Bitcoin also over other payment options. Other option available is CoinGig that again allows you doing transaction in form of bitcoins that conducts it transactions solely in bitcoins only. You can find everything from books to t-shirt to gift vouchers on CoinGig. Then you got Virgin Galactic, cheapair.com. These are other options where you can utilize your bitcoins in order to purchase items from marketplace. You got Bitcoin commodities, travel. Bitcoin commodities helps you sell gold and silver coins, bars and sheets. As the name suggests it accepts Bitcoin payments. While travelforcoins.com acts as a middleman between you and travel sites such as Expedia. You pay in bitcoins to travel for coins who will pay for your flights using standard currency. That was all about the places where you can spend, sell, and purchase your Bitcoin. Bitcoin blockchain, transaction, and transaction script. So, before spending the Bitcoins, we should be securing them inside our Bitcoin wallet. That we already learned. Now, what is Bitcoin blockchain? Transaction and transaction script that we'll be learning here in coming slides. Now that we have seen how a Bitcoin is used and spent, let's see what exactly happens when a transaction occurs. There are various Bitcoin protocols that can be used while doing transactions. Mining, research and support, payments, retail, buying, selling and storing, financial services. So these are the areas where Bitcoin's ecosystem can be used. Your mining, hardware manufacturing, mining platforms. You can use it for foundation, for profits, venture capital, security. You can use it Bitcoin protocol for payment processes, escrow services. Then you can use for retail services like merchants, directories of stores that accept Bitcoins. You can use Bitcoin's protocol for exchanges, software wallets, market makers, ATM providers, and then you can use them for financial services as well, like institutions, lenders, insurers, hedge funds, and then for products, derivatives, and investments. So these are examples of using Bitcoin protocol for various kind of applications and services. The structure of Bitcoin transaction. A transaction contains a number of fields. As you can see here in the tabular format, like it contains every Bitcoin transaction contains a version which is size of 4-bit bytes and that specifies the rules this transaction follows. Then you got input counter in the Bitcoin transaction field that is of 1 to 9 bytes variable integer and it includes how many inputs are included in the transaction. Then outputs. You get variables to store outputs for one or more transactions. Then you get 1 to 9 bytes variable integer type of output counter that is used to count how many outputs are included. Variable outputs is used to store one or more transaction outputs and then log time is a Unix timestamp or block number that is used to save the timestamp of the transaction in 4 bytes. Unspent transaction output. How an unspent transaction looks. UTXO or unspent transaction output is a fundamental building block of a Bitcoin. An unspent transaction output that can be spent as an input in a new transaction. The network keeps track of all available UTXOs currently numbering in the millions. So these are the stored coins or Bitcoins that are available in your Bitcoin network that are unspent and stored as a form of unspent transaction output. The first block contained 50 mined BTC in address A is equal to 50. The second block contained 50 mined Bitcoin in address A, a transaction sending 20 Bitcoin to address B and putting the change in address C. So in that way A was 50, your B becomes 20 and C has a value of 30 Bitcoins. The third block contained 50 mined Bitcoin in address A. A transaction sending the 20 Bitcoin from address B to address D are available. So after 3 blocks, you could see there are 4 unspent outputs. A has 2 unspent output worth rupees 50 Bitcoin each. C has a single unspent output worth rupees 30 Bitcoin and D has a single unspent output worth rupees 20 Bitcoin. And there are 2 spent outputs also. The 50 Bitcoin generated in the first block is spent in the second block. The 20 Bitcoin output created in the second block and spent in the third block. So what do you see here? Let's review the example again to explain into more detail. The first block was A and was having 50 mined Bitcoins. The second block was containing 50 mined Bitcoin in address a transaction sending 20 Bitcoin to B. So this 20 amount got deducted from A50 and putting the change in address of it. So it becomes A has 50, then B got 20 bitcoins and the C becomes 30 in reduction of 20 bitcoins. The third block contained 50 mined bitcoin in address A. A transaction sending the 20 bitcoin from address B to D is used now. So your A got 50 plus 50 bitcoins, and now C was 30 again, and D got 20 bitcoin transferred from B. So these are the values in this third block. Note that unspent outputs don't merge together. The two unspent 50 Bitcoin outputs at address A are separate and will remain separate at least until they are spent in a transaction. So each unspent transactions are stored separately and should not be merged together during the transaction. Bitcoin transactions input and outputs. Firstly, four axiomatic truth about transactions. Any Bitcoin amount that we send is always sent to an address. You need to have recipient address in order to send any Bitcoin. Any Bitcoin amount we received is logged to the receiving address and should not be used, which is usually associated with our wallet. So the amount of Bitcoin we are sending to other party will be logged from our wallet until it is successfully sent to the recipient. Anytime we spend Bitcoin, the amount we spend will always come from the funds previously received and currently present in our wallet. Address receive Bitcoin, but they do not send Bitcoin. Bitcoin is sent from a wallet. So that are four thumb rules or truths about transactions occurring for Bitcoin transactions. So this block of code shows Bitcoin transaction example. In the block, you got three blocks. The first block has hash of the transaction, then version of it and other details. You got in block section and out block section also into the transaction example. Transaction format version is currently at version 1. If you could see from the figure, in counter is the number of input counts that are available to this transaction, and output counter is out counter, that is number of output amounts. You could see here the output amount and input amount are defined as discussed. Transaction lock time should be 0 or in the past for the transaction to be valid and included in a block. Then size of the transaction in bytes. So these are the information that are present as in the header of the blockchain transaction example. Bitcoin transaction input and outputs. So the amount that goes into our wallet are not jumbled like the coins in a physical wallet. These amounts received don't mix but remain separate and distinct as the exact amounts received by the wallet. Here's an illustration. Just see an example. You create a brand new wallet and in time it receives three amount of 0.01, 0.2 and 3 bitcoins as follow. You will send 3 bitcoin to an address associated with the wallet and two payments are made to another address by Alice. If you see in the figure, two people send amount to addresses held by a Bitcoin wallet. And the wallet balance for this wallet was initially 3.21 Bitcoin, adding 0.01, 0.2 and 3 Bitcoin in your wallet. Now, these all amounts came from three different resources from Alice, then Alice and you. Now, the wallet reports a balance of 3.21 by summing up the amount. Yet, if you were to virtually speak inside the wallet, you would see not 321 million Satoshi, but three distinct amount grouped together by their originating transactions. So by this, we can conclude that each amount added to the wallet are kept separately. The received amount, bitcoins, don't mix but remain separated as the exact amount sent to the wallet. The three amount in the example above are called the outputs of their originated transactions, and Bitcoin wallet always keep outputs separate and distinct. This should be clear by now. We should not be summing up the amount of currency or Bitcoin received. And we'll be continuing from this point here now. Bitcoin ecosystem that we already discussed contains various areas and applications that you can utilize your Bitcoin or blockchain. We discuss about Bitcoin transaction header, what values and what fields it has. Then we saw what unspent transaction output is. We discussed it is unspent transaction output. It's a fundamental building block of a Bitcoin. Any Bitcoin when created, it is stored as a UTXO and it is called unspent transaction output. So any money, any Bitcoin in your wallet, it is called UTXO. Then we discussed about Bitcoin transaction inputs and outputs, how a transaction block looks, and how money or Bitcoins are summed up or stored inside the Bitcoin wallet. These are never summed up. The whole money is kept individually and can be utilized depending on the requirement. The whole value is summed and displayed in your Bitcoin wallet, but these are stored separately always. Transaction inputs. Transaction inputs are pointers to UTXO. They point to UTXO by reference to the transaction hash and sequence number. Until now, we understand what are hash. I will try to elaborate it more using a demo and example. So hashes are, as discussed, are the mechanism using which you can create your strings encrypted format, and that are, when hashed, create a unique value that changes when your input string changes. So hash of any given string is always unique and can never be generated using any difference inside the string. I will show you how you can test and generate hash. You can go to any online website and start. I will just take an example of this example website where you can go and generate hashes and play with it according to your learning and as per your interest in this topic. You can give any data in this comment box or text box. Say hello. So if you see here, even if it was empty, it was having a hash value. So empty string also has a hash value and is always of a fixed length. Here in this demo, we are using SHA-256 hash. So SHA-256 is always considered a very strong hashing mechanism that is almost impossible to hack and translate. So if you see, hello generates a unique hash string. And if we try to change it by a dot even, the whole hash changes. So this way, hashes always remain unique and you can always use them to preserve the validity or authenticity and integrity of your data blocks. So this was an example of hash. Let's move to the parent topic again. So your transaction inputs are pointers to UTXO. UTXO we know, unspent transaction outputs. They point to UXO by reference to the transaction hash and sequence number. To sell or spend UTXO, our transaction input also includes unlocking scripts that satisfy the spending conditions set by the UTXO. Every transaction input has the following field. It has transaction hash pointed to the transaction containing the UTXO to be spent. Then it could be of 32 byte size. Then output index, the index number of the UTXO to be spent. First one is always 0 and its size is 4 bytes. Then unlocking script size. Unlocking script size length is in bytes to follow. It can vary from 1 to 9 bytes. Then unlocking script, a script that fulfills the condition of the UTXO locking script and it is of again variable size. Then sequence number. Currently disabled transaction replacement feature set to hexadecimal value 0xFFFFFFF. And this is again of size 4 bytes. So these all fields constitutes your transaction input block. What does a transaction look like? A transaction has three pieces of information. In this example, you can see it has in sign public key, out, and the amount of the Bitcoin that is being transferred. So the input is a record of which Bitcoin address was used to send the Bitcoins to the customer in the first place. Then amount is the amount of Bitcoin that A is sending to the vendor. Output is the Bitcoin's address of recipient Bob. So these three transaction fields constitute your transaction block. Each input and output field is using the address of the sender and receiver node, or you can say peers. Any transaction is signed using sender's private key and it uses the address of the receiver in order to transfer the amount to the recipient. So this whole figure depicts the same that we discussed. 2 Bitcoin is sent to the address of the customer and at in node it is signed with the key. Then output is sent to the address of the vendor, the amount 2 Bitcoin and 3 Bitcoin is again sent to the address of the customer change. Now example to show the transfer of Bitcoin. Let's say Andy has 3.21 Bitcoin in his wallet sent to him at different addresses. So these amounts were sent from Alice, me, you.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Or Alice again. So these all have different addresses and they send the balance to Andy and constitute 3.21 Bitcoin in his wallet. The received amount remains separated as exact amount sent to the wallet, if you can see here in the figure, and that is called transaction output. Spending consumes UTXOs and creates new ones. You could see from the figure before balance of node 1, or you can say the sender was 3.21 Bitcoin. So when he tried to sending 0.15 Bitcoin to Bob, it destroys output of amount 0.02 Bitcoin from the transaction, or you can say UTXO available in his wallet. and creates a new output of amount 0.05 Bitcoin inside the wallet of the sender node. So whenever a transaction is initiated, it looks the nearest value available in the wallet and it deducts the money from that portion only, from that address only for spending. The above scenario explains the 0.2 value was nearer to the 0.15 Bitcoin required to send to the Bob, and this amount was deducted from this particular address only and leaves 0.05 balance after the spend. So 0.15 Bitcoin will be sent to Bob's address and will reside in his wallet as an output, waiting eventually to be spent. The 0.05 Bitcoin is called change and will be sent back to your wallet. So you see the whole block, the whole address amount was translated and transferred to the Bob, and this amount, the change, the remaining portion was returned back to the wallet as new address. Transaction as double entry bookkeeping. With the previous example, it is clear that the transaction in Bitcoin is a double entry bookkeeping. How? Let's see in the given diagram. This is a specimen of a double entry bookkeeping. You got inputs, you got outputs. So you have entry for both in form of bookkeeping. You got four inputs, input 1, 2, 3, 4, and each has different value of 0.10 Bitcoin, 0.20 Bitcoin, 1.10 Bitcoin, and 0.15 Bitcoin respectively. Then your output entries are three, output 1, 2, and 3, and these have again different values of 0.10 Bitcoin, 0.20, 0.20 Bitcoin again. So when we sum up the total inputs and outputs, we come across total inputs of 0.55 Bitcoins and total outputs of 0.50 Bitcoins. So when we calculate the difference, it is 0.05 Bitcoin, and this is implied as transaction fees. So if you see, the amount of transaction input can never be equal to the transaction output because our difference is applied, that is called transaction fees for completing the transaction. That is why it is called double entry bookkeeping, because it stores both the entries of input and output blocks and do all the calculations for transaction fees. Bitcoin transaction lifecycle. How Bitcoin transaction lifecycle starts and flows till the end, that can be depicted from the given figure. We start here. Rob opens his Bitcoin wallet, scans copy Laura's address in order to send the money. What Bob is doing, Bob's quest to send 0.3 Bitcoin to his friend Laura is an example of this whole Bitcoin lifecycle. He's trying to transfer 0.3 Bitcoin to his friend. He opens his wallet, scans the address of Laura in order to send the 0.3 Bitcoin, fills the amount and the fees of transaction, and then sends over the network. Then it passes through user or machines, and the wallet signs a transaction using Rob's private key. This transaction before sending over the network is signed using Rob's private key, and it is all time spent 10 seconds around until now. The transaction is propagated and validated by the network nodes. Miners or validators include the transaction in the next block to be mined. So this transaction is now part of group of transactions of a new block that is being mined by the validator nodes. We all know that mining is the computational process of calculation of certain hashes and take time. So when mining is done, the miners who solve the proof of work propagates a new block to the network and new bitcoins are created in result. The nodes then verify the result and propagate the block and add to the blockchain. When the final confirmation is done and blockchain got the new block added, Laura can see the first confirmation on his wallet and his device that the amount has been transferred successfully and received by her. New confirmations appear with each new block that is created. So every node inside the blockchain network is made aware of the new block creation, and this constitutes the whole life cycle of a transaction inside a Bitcoin transaction life cycle. Now we'll be discussing about various transaction forms in Bitcoin. Let's see what are the various type of forms used in Bitcoin transactions. This is the figure depicts a common transaction form. The most common form of transaction is a simple payment from one address to another, which includes some change returned to the original owner. So this is a very basic example of transferring Bitcoin from one address to other, where input 0 from Alice signed by Alice is sent to output 0 to Bob, and then output 1 comes as change returned to the Alice. Then comes aggregating transactions. These are another common form of transaction, where transaction is one that aggregates several inputs into a single output. So what happens? Multiple inputs are aggregated and formed in a form of transaction and sent to output 0 to the output peer or output node. These type of transactions are sometimes generated by wallet applications to clear up smaller amounts that were received as change for payments. Then comes distributing transaction. Transactions that distributes one input to multiple outputs represents multiple recipients. So here the sender address or sender peer can try to send amount or Bitcoin to multiple addresses in one transaction itself. So you can generate one input with multiple items to multiple recipient addresses, and this will be further distributed in multiple outputs depending on the number of different addresses available. So this type of transaction is sometimes used by commercial entities to distribute funds, such as when processing payroll payments to multiple employees. So this is a quite good example where this can be used by an organization to send salary of multiple employees inside their organization, which will have all employees have different addresses in the network. What are scripts in Bitcoin? Now that we know that transaction in Bitcoin consists of input and outputs, these inputs and outputs offer nothing but the scripts. Bitcoin scripting language script. All Bitcoin transactions have scripts coded into its inputs and output mechanism. Design goals are forth-like programming language, old stack-based simple programming language used, reverse polish notification. Data is pushed onto the stack and operation is performed. Composed of OP codes. Operation in Bitcoin is composed of OP codes or operation codes that help deciding the results. Example of Bitcoin scripts you can see on the screen. The script shown alongside will execute the values in the stack and will return to value to true if the equation is valid. So it has multiple steps to execute it inside the script. The scripts are written in the old stack-based programming language that is called Forth or other similar programming languages. They have syntax, they have execution pointers, execution starts from the left, that constant value 2 is pushed to the top of the stack. In the third step, this execution pointer, execution continues moving to the right with each step, constant value 3 is pushed to the top of the stack. You can clearly see that data structure stack is used here in order to propagate the script execution. Then the add option specifies adding the values. Operation add pops the top two items out of the stacks are added them together, and then operator adds pushes the result 5 into the top of the stack. This is syntax of this programming language that is used to calculate the value and propagate the transactions. When the script shown alongside is executed, the result is op-true code, making the equation valid. That means the constant value 5 is pushed again to the top of the stack that was received as a result of adding 2 and 3. The operation equal pops the top two items out of the stack and compares the value 5 and 5, and if they are equal, the equal pushes true, or if they are not, it will be 0. Most common script types. Pay to public key hash, P2PKH. One of the most commonly used transaction output script. It is used to pay to a Bitcoin address. Second is pay to public key. This is the simplified form of that P2PKH. This is not commonly used in new transactions anymore because P2PKH are more secure. Pay to multisign, P2MS. Multisign outputs allow to share control of Bitcoin between several keys, and that make them more secure, that we have already seen in previous sessions. Pay to script hash. Scripts that contain the hash of the another script called redeem script. And it is another way of common script types using transactions. Script mechanism. Transaction validation engine relies on two types of scripts to validate the transaction: lock and unlock. Unlocking script sig that signs using public key, and while plus locking script is script public key that uses duplicate hash 160 public hash equal verify and check the signature. That is the function written and for locking and unlocking script. Unlock script sig is provided by the user to solve the encumbrance, while in locking script lock is found in a transaction output and is the encumbrance that must be fulfilled to spend the output. Combining the output and input scripts. The two scripts together would form the following combination validation script: cafe signature, cafe public key output dup op hash 160, and cafe public key hash op equal op check sig. The script combined, when executed, will evaluate to true if and only if the unlocking script matches the conditions set by the locking script. So this is just an example of writing codes in your input and output scripts. when you have your own requirement, you can simply code, and obviously you should be having the knowledge to write in the code, and then you can evaluate and get the value accordingly, true and false, by meeting the certain condition allowed by the locking script to the unlocking script. The result will be true if the unlocking script has a valid signature from the cafe's private key that corresponds to the public key hash set as encumbrance. Now, here comes the evaluation of the script. So on this screen, you could see how steps provided in the scripts are executed and evaluated. Pointer is at the initial state same. So signature sign off happens using the public key. Evaluation starts. Value sig is pushed to the top of the stack. Then public key is pushed and execution continues moving to the right with each step. Value public key is pushed to the top of the stack on top of the signature. And this algorithm is repeated continuously till the end of the steps. A step-by-step execution of the combined script which will prove this is a valid transaction. In the next step, dup operator duplicates the top item in the stack. The resulting value is pushed to the top of the stack again. So for the audiences, those who are not into development, this could be a bit tricky. They should know how push and pop happens from the stack and how operations are performed over the stack data structures. So the scripts are simply following the data structure instructions. They are pushing the items into the stack, doing pop and push items in order to execute the instructions written. The next item, hash 160 operator, is picked and it hashes the top item in the stack with the repmd 160 SHA-256 public key. The resulting value pubk hash is pushed to the top of the stack now. That is received by hashing. Now the value pubk hash from the script is pushed on top of the value pubk hash calculated previously from the hash 160 of the pubk. The equal verify operator compares the pubk hash encumbering the transaction with the pubk hash calculated from the user pubk, that is public key, and if they match, both are removed and execution continues. The check sig operator checks that the signature matches the public key and pushes true to the top of the stack if true. So since the script alongside returns true, this transaction is valid. Otherwise, it stands invalid. So this is how any script works. Any Bitcoin script works and calculates the transaction values. Nodes in Bitcoin network. So since we have discussed more about transaction inputs and output and the scripts, we will see now what are the various nodes in Bitcoin network. In the Bitcoin network, full nodes are the enforcers of consensus rules, but not all full nodes are created equal. There are several different kinds of Bitcoin full nodes which exist in the ecosystem. Pruned selfish full nodes. A pruned node is a full node that prunes raw block and undo data by deleting it from the disk. This can be achieved to save the disk space. A selfish Bitcoin node is a node that does not upload new blocks or transactions to the other Bitcoin peers in the network. Archival selfish full nodes. An archival node is a full node that stores a complete copy of the Bitcoin blockchain data on the disk. Within this data, the archival node operator can make queries against the blockchain to find information pertaining to the particular transaction or addresses. Common Bitcoin nodes in the Bitcoin network. Network result routing node, full blockchain. If you see here, you could see reference client that contains Bitcoin core. Then you got full blockchain node. You can have a solo miner. You can have lightweight simple payment validators wallet. Then you can have pool protocol servers, mining nodes, lightweight SPV, Stratum wallets. So the network routing node contains a full blockchain database and network routing node on the Bitcoin P2P network. This reference client contains a wallet, miner, full blockchain database, and network routing code node on the Bitcoin P2P network. Solo miners. Solo miners contains a mining function with a full copy of the blockchain and the Bitcoin P2P network routing node. Lightweight SPP wallets contains as a wallet and a network node on the Bitcoin P2P protocol without a blockchain. Then comes your pool protocol servers. Gateway routers connecting the Bitcoin P2P network to nodes running other protocols such as pool mining or Stratum nodes. Example, pool server, Stratum server. Then mining nodes containing a mining function without a blockchain with the Stratum protocol node S or the other pool P mining protocol node. So one other type of common Bitcoin nodes is lightweight SPV Stratum wallet. Again, contains a wallet and a network node on the Stratum protocol without a blockchain. So here you do not need to worry. These are just example of common Bitcoin nodes that are used in Bitcoin network, and there are many. If you're interested, you can really go through the web and read about the definition and example of these kind of nodes that are used in Bitcoin network. So let's discuss about economics of Bitcoin. Below pointers constitutes about economics of Bitcoin and tells more in detail. That is, Bitcoins are stamped after creation of the each block at a settled and reducing rate. That means every Bitcoin creation of new block is stamped, settled, and every time they are created, they are in reducing rate as compared to the previous one. For each 2.1 lakh blocks, or roughly every 4 years, the money issuance rate is diminished by half in the Bitcoin system. It means every year Bitcoin generation is decreasing and the next year it becomes half of the rate of the block generation in Bitcoin network. So we could say that if 2.1 lakh blocks are generated or 4 years are spent, the rate of issuance of money inside Bitcoin will be diminished to half. For the first 4 years of Bitcoin operation of the system, each block contains 50 new Bitcoins. So that was the initial phase of Bitcoin. When it started flowing officially from year 2009, the first chain of blocks was containing 50 Bitcoins. And during the next 4 years also, starting 4 years of Bitcoin operations, each blockchain consisting only 50 new Bitcoins. The rate of new coins diminishes exponentially, more than 64, halving until block 13 lakh 13,230,000 mined roughly in year 2140 when it achieves the base cash unit of 1 Satoshi. Finally, after near around 13.44 million blocks in approximately 2140 years, almost Satoshis or almost 21 million Bitcoins will be issued. What this line means? This line means that the 21 million Bitcoins are already hardwired inside the Bitcoin protocol and Bitcoin generation could only happen till this amount only. When Bitcoin generation has reached 21 million Bitcoins, the block generation will automatically stop until someone expands the limit in the protocol itself. Therefore, blocks will contain no new Bitcoins and miners will be rewarded solely through the transaction fees once blockchain generation is completed and reached 21 million Bitcoins. Bitcoin economy, supply of Bitcoin. How supply of Bitcoin happens inside the Bitcoin economy. The limited and decreasing supply and issuing rate makes a settled financial supply that opposes expansion. This is really needed. When you are designing a financial network or cryptocurrency network, you need to keep in mind that it should not cause inflation. That's why Bitcoin makers also kept in mind and put a limit and they kept the rate of Bitcoin generation in control by limiting it and decreasing supply and ensuring rate of financial supply opposed to the expansion. Different to a fiat money which can be imprinted in unending numbers by a national bank, Bitcoin can never be swelled by printing. Blocks need to be generated by miners against the effort they are putting solving puzzles inside the network in order to create new blocks. So every time the effort invested will be limited and the restrictions put inside the Bitcoin network will keep the blocks in control and they will never cause inflation inside the network and cannot fill the network again like fiat money or cash. The adjacent graph depicts the supply of Bitcoin currency over time based on a geometrically decreasing issuance rate. You can see here over coming years like starting from 1st Jan 2010 till 1st Jan 2030, Bitcoin generation remains constant. Starting for 20 lakhs of Bitcoins created, it is slowly going towards 2 crore Bitcoins in the network. And that remains the highest limit of Bitcoin generation inside the blockchain Bitcoin network. Now let's discuss about Bitcoin mining. How Bitcoin mining can happen and what are the factors involved mining new blocks inside the Bitcoin. So how do we create new Bitcoins inside Bitcoin network? Bitcoin mining is a process of adding transaction records to Bitcoin's public ledger of past transactions or blockchain. This ledger of past transaction is called the blockchains. It is chains of blocks, the blockchain server to confirm transaction to the rest of the network as having taken place. This means whenever a new block is created as part of the mining process, where there are certain validators or miners participating in the network in order to solve problem and group transaction into new blocks. In order to submit their block successfully inside the existing blockchain network, they have to solve a problem called proof of work provided through proof of work they need to solve, they need to win, and the winner node will be getting a chance to create new block inside the blockchain system. Once the new block is created, it is published to all other nodes in order to let everyone know that a new block has been ingested inside the blockchain network, so that everyone need to update their ledgers maintaining locally. Types of Bitcoin mining. There are various ways in which you can mine your Bitcoins. They can be divided majorly into solo mining and pooled mining. In solo mining, miners endeavors to produce new blocks all alone, with the returns from the reward and transaction expenses going altogether to himself, enabling miners to receive extensive payment with a high variance, longer time between payments. This ensures. This means every miner works alone in order to produce new blocks, and in return they are getting hugely rewarded. The transaction expenses going altogether to himself he manages, and the reward in return he receives he owned by himself only. So enabling miners to receive extensive payments with a higher variance is again giving longer time between payments in order to achieve and collect Bitcoin from the network. Against to this, polo mining. In polo mining, miners pools against assets with different mine workers to discover block all the more regularly within the return, with the return being shared among the pool miners in rough correlation to the measure of hashing power they each contributed. That means, apart from working alone, the pooled miner system gives a group of miners that work in a pool of assets, and they work toward creation of new blocks and awarded equally as per their effort by in solving the new problems towards creation of new blocks. And that correlation of paying them can be measured in the terms of hashing power they each contributed towards new block creation. Pooled mining also enables the miners to receive little payment with a lower change. That means, and this duration of payment is comparatively shorter than the solo mining system. So this is more beneficial system where pooled miners work together along creation of new blocks, and in turn they get rewarded on frequent basis than solo mining process. Let's first understand the working of solo miners. Mining and consensus. Bitcoin consensus algorithm allows for the creation of new bitcoins by the process of mining, and this process involves majorly four steps to complete the block creation. Step number 1, autonomous check of every transaction. Every transaction submitted by the nodes is autonomously checked and verified against the standards provided in the algorithm. Then, second, proof of work algorithm is used in order to validate the and transactions and then compete against each other in order to become winner and submit their transaction of blocks. Then third step is confirmation. Once once the node is winner, they give confirmation about the new block creation against the all network nodes available, and they publish it. And fourth is independent aggregation of nodes and publish along whole network in order to update the ledgers and increasing the blockchain network. Step number 1. How autonomous verification of transaction happens. Autonomous check of every transaction by each full node in light of an extensive rundown of criteria. Independent aggregation of those transactions into new blocks by mining nodes combined with exhibited calculation through a proof of work algorithm happens, and then independent confirmation of new blocks by each node and get together into a chain. Fourth step includes independent selection by every node of the chain with the most cumulative computation demonstrated through proof of work. And how this independent verification of transaction happens. Let's say Andy initiates a transaction of 5 Bitcoin to Bob in a Bitcoin network. So every node inside the network passes this transaction to each other. Each node has their peer nodes connected, and when any node start sending the transaction to other node, they start propagating the information inside the network. And each node is responsible for independent verification of these transactions and validating the integrity of these by using the public key of the sender node. Independent verification of transactions. Let's discuss more detail. Before sending transaction to its neighbor, each Bitcoin node that gets the transaction will at first confirm the transaction. This ensures that only valid transactions are proliferated across the system, while invalid transactions are rejected off at the first node which receives them. Since each independent nodes are responsible for validation of transaction, and they are validating very efficiently, so that none of the bad transaction or invalid transaction should propagate inside the network. So any invalid transaction will itself get cancelled and rejected at the first node itself. So there will be no chance of propagating wrong information or invalid transaction inside the network. Checklist of transactions. Every node confirms each transaction against a long agenda of criteria. So while the validators or nodes perform the validation of independent transactions, They follow a checklist or set of rules in order to validate the transactions. Transactions punctuation and information stack has to be in sync with the Bitcoin protocol. That means all the instruction and transaction information should be in sync inside the transaction block. Neither list of inputs or outputs are empty. Inputs and outputs we have already discussed in last session. These are transaction inputs and outputs which provides the available amount of Bitcoin inside the personal wallet and amount of Bitcoins transferred to the other nodes as part of the transaction. So both the list or none of the list should not be empty. The transaction sizes in bytes is less than max block size. That means the transaction size which is calculated in bytes should always be less than the maximum block size of the Bitcoin network. It should not increase at any point in time the size of maximum block size. When we talk about maximum block size, is the size of the maximum the block available inside the Bitcoin network that has the more number of transactions. Each output value and also the aggregate must be inside the permitted scope of qualities, that is under 20 million coins more than 0. That means any output value and the aggregate of it that is generating new bitcoins should be limited under should not go beyond 21 million coin and should be obviously more than 0 or the available bitcoins inside the existing Bitcoin network. A matching transaction in the pool or in a block in the main branch must exist. For each input, if the referenced output exists in any other transaction in the pool, the transaction must be rejected. That means if any input, for each input, if the output is already existing, that means the transaction has been already validated and done. Then the similar transaction should always be rejected. For each input, the referenced output must exist and cannot already be spent. This means the referenced output against any input that is supplied must be existing and should not be spent already. That means it is similar to the above point, the transaction should not be done already. Reject if the sum of the input values is less than the sum of output values. As we discussed already in last session, there is always a transaction fees involved for each transaction. That means your input value should always be lesser than the output value, allowing some space for transaction fees during the validation of transaction and committing to them in the new block. Combination of verified transactions. Autonomous check of every transaction by each full node in light of an extensive rundown of criteria. Independent aggregation of those transactions into new blocks by mining nodes combined with exhibited calculation through a proof of work algorithm. Independent confirmation of the new blocks by each node and get together into a chain, and then independent selection by each node of the chain with the most cumulative computation demonstrated through proof of network. So now, during these 4 steps, we already discussed the validation part. Now, how the combination of verified transaction happens after validation. Combining transaction into blocks. We have already discussed and understood that during the mining process, not a single transaction is used to create the new blocks. Validators or miners look for the available transaction in the network and they group the available transaction to form a new block. So by doing it, they follow certain rules and process in order to write the new blocks by grouping the available transactions in a group. And now we are discussing about Bitcoin mining. So this is second session in this Bitcoin mining series. Till now, in our last session, we already discussed about mining process and how during the mining process, individual blocks of transactions are validated by each node and propagated towards the network. Before propagating to the network, the validated nodes group the transactions into the blocks, and how these validated transactions group together, we will be learning and discussing in this session. Combining transaction into blocks. Let's see how it happens. By autonomously confirming each transaction as it is received and before transmitting it, each node maintains a pool of valid, however unconfirmed transactions known as transaction pool, memory pool, or mempool. Why we call them unconfirmed transactions? Because these transactions are still not confirmed. They are just validated against the sender and receiver's addresses by using their public keys and other mechanisms. So when a validator or miner comes to form a new block, they start looking for pending transactions. They group together, they create a new block that will be possible candidate block inside the network, and this is called transaction pool, from where they pick all the pending transactions. Transactions reaches mining nodes, it has collected, validates, and relays new transaction just like the other nodes. So that means that any transaction that reaches the miners that has collected it and it validates, and then after validation it relays the new transaction just like the other nodes are doing. That means it starts propagating it to other nodes inside the network. Unlike other nodes, the miner node will then aggregate these transactions into a candidate block. And this way, a new block formation will start inside the Bitcoin network. Similar way, there will be other miners as well that will be competing for creation of a new block by grouping the pending transactions. For an example, you can see from the diagram that in the network shown above, the miner nodes in orange color aggregate the transaction in a candidate blocks. They are responsible for grouping the pending transactions and formation of new blocks. Here we will try to understand through an example. Let's say Andy is a miner. A mining code maintains a local copy of blockchain, the list of all blocks created. This will not happen with all the nodes in the network. Only miner nodes, or you can say validator nodes, will keep a whole local copy of blockchain that contains all the blocks in the network. That means when we say whole copy, they will be having the Bitcoin blockchain system starting from 2009, starting from first node. Okay. So Andy's node is listening for transaction, trying to mine a new block, and also listening for blocks discovered by other nodes. So any miner block or node, sorry, will keep listening to the all the incoming transaction, and they will also keep listening and monitoring the other blocks or other nodes that are trying to listen and form new blocks. As Andy's node is minor, it receives block say 273816 through the Bitcoin network. The arrival of the block signifies the end of the competition for the block and the beginning of the competition to create the next block. Which means when the arrival of block comes to the miner Andy, it has to now participate in the competition in order to create next block with other nodes, which are also contending in order to create a new block. And during the previous 10 minutes, while Andy's node was searching solution to block 273816, it was also collecting transaction in preparation for the next block. Which means miners work parallelly. While they are working to form a new block and register it inside the blockchain by competing with other nodes, they also do preparation for the new block for registering into the system. So by now, it has collected a few hundred transactions in the memory pool and will try to register them. Upon receiving 273816, a new block and validating Andy's node will also check all the transactions in the memory pool and remove any that were included in the block 273816. So by this step, it allows or it ensures that none of the transaction is repeated in the next block that is already covered inside the existing block, that is, it is forming. Whatever transaction remain in the memory pool are unconfirmed and are waiting to be recorded in a new block. So once Andy's node has already collected the transactions inside a group to form a new block, these all are unconfirmed yet, and these will be registered into the new block once confirmed from proof of work or other consensus mechanism. Andy's node immediately construct a new empty block, a candidate block 273817, and this block is called a candidate block because it is not at a valid block. It is just trying to pull its block inside the blockchain network. It has to participate in consensus mechanism by doing proof of work, and once it is winner, he will be eligible for creating and registering his block, publishing it inside the whole network. After the block becomes valid only if the miner succeeds in finding a solution to the proof of work algorithm. So this way, whole mining process occurs and new block formation happens inside the network. Other nodes that were competing inside the blockchain network in order to create new block will start over again and try forming the new block by winning the competition using proof of work solution. Fabrication of a block header. Since Andy has won the competition, he need to construct the block header after collecting all the transactions in a block. Sorry, this will happen before winning the competition because he is forming a candidate block. How fabrication of a block header happens? These are the listed fields in the table shown that will be required in order to construct a new block header. These are total 6 fields that any mining node requires in order to construct a new block's header. The first field will require a version of the block. In order to construct the new block header, the mining node need to fill in 6 fields as listed. First is version, second is previous block's hash, a reference to the hash of the previous parent block in the chain, then Merkle root. We have already discussed how Merkle roots are calculated by repeatedly hashing the available transactions. A hash of the root of the Merkle tree of this block's transaction. Then timestamp, the approximate creation of block's time, seconds from Unix epoch. It will always be in seconds. Fifth will be difficulty target. The proof of work algorithm difficulty target for this block in order to participate in the consensus mechanism. Then last will be nonce, a counter used for proof of algorithm in order to win the consensus mechanism and competition. Mining. So when Andy has already decided the block's structure and formed a candidate block, he will start mining process. Since Andy started mining in the block, once his node has all the fields filled in the block header in the blockchain, he will follow the below process. With all the other fields filled, the block header is now finalized and the process of mining can begin. The ultimate goal of Andy is now to find a none value which results in a block header and hash that is less than the difficulty target of the block. So how this works and how proof of work algorithm happens, we have already discussed in our previous session. If you find it interesting and want to learn, please refer to our first topic videos, that is cryptocurrency and Bitcoin. Now, once the mining hub should test billions or trillions of nonce streams before a nonce is found that fulfills the prerequisites. Miners are participating, like Andy's node will participate in proof of work competition, and they will need to find a solution for the given problem, and the resulting nonce will be used to fulfill the prerequisite condition. Since an approved piece has been developed by Andy's hub, it is ideal opportunity for Andy's equipment mining apparatus to mine the square to discover an answer for the verification of working calculation that makes the square legitimate. So presently, to approve the piece as per the confirmation of work calculation, Andy's mining hub needs to achieve the trouble target. How about we perceive how the trouble is spoken to? Let's see. Portrayal of difficulty. The block contains the trouble focus in a documentation called difficulty bits or just bits. Let's say a block has 0x1903A30C as the difficulty bits. The notation expresses the difficulty target as a coefficient exponent format with the first two hexadecimal digits for the exponent and the next six hex digit as coefficient. In turn, this becomes, using formula as below, the difficulty target from the illustration is target is equal to coefficient of 2 to the power 8 and exponent minus 3. So this whole formula can be written in the shown format. Successful mining. So we have seen that Andy's mining node has worked hard to reach the difficulty target using all previous mechanisms. So let's see, once it is a winner, what happens next. Successfully mining the blocks. As we saw earlier, Andy's node has created a candidate block and prepared it for mining. Andy has several hardware mining devices with SIC where the hundreds of thousands of integrated circuits run the SHA-256 encryption algorithm in parallel at unbelievable speeds in order to win the proof of work. The mining code running on Andy's desktop transmits the block header to his mining hardware, which start testing trillions of nonces per second. Almost 11 minutes after starting to mine block, one of the hardware mining machine finds a solution and sends it back to the mining node. That means the solution of the problem assigned to the miners. Immediately, Andy's mining code transmits the block to all its peers, and this is part of the publishing of the new successful added block inside the whole network. In this way, all peers inside the networks are aware of the new block and they start registering the new information and new block inside the blockchain and inside their ledgers. They receive, validate, and then propagate the new block as per the block ripples out across the whole network. And this way, so a new created block successfully mined and introduced inside the Bitcoin network. In short, you can say a new Bitcoin is generated. Now, let's see how third step happens. Independent confirmation of each block. Validation of new block or confirmation of new block. In Bitcoin consensus process, every new block is validated by every node of the network. That means every node has the responsibility for validating the new node just created. This makes sure that only valid blocks are propagated to the network and not the bad blocks. Node validates the block by verifying it against a long list of criteria that must all be met. The list may include the block structure is syntactically valid, the block header hash is less than the target difficulty, that means the solution provided by the miner node is really correct, and enforces this way the proof of work was genuinely solved by the winner block. The block timestamp is less than 2 hours in the future, allowing for time errors. The block size is within acceptable limits, that it is not crossing for Bitcoin 21 million blocks or Bitcoins. The first transaction, and only the first, is a coin-based generation transaction, and all the transactions within the blocks are valid using the transaction list discussed in independent verification of transactions that we already discussed in previous slides. Just to show you a glimpse, This was the list of followed by the nodes during the independent validation of transactions. Now the fourth step comes during the mining process, independent aggregation of the block in chain. The main chain, the chain of blocks with the most cumulative difficulty associated with it. Under most conditions, this is likewise the chain with the most blocks in it unless there are two equivalent length chains and one has more confirmation of work. When a new block is received, a node will try to slot it into the existing blockchain. The node will also look at the block's previous block hash field, which is in reference to the new block's parent. That means this is an important feature of any new block and or any blockchain in order to maintain the integrity of the blockchain. Every newly block added should be having the correct hash of its previous or parent block which it is getting added. So this will be the main part of validation while adding a new block to the existing blockchain or during aggregation process. Then the node will attempt to find that parent in the existing blockchain and which will be identified by the hash of the previous block ID. Most of the time, the parent will be the tip of the main chain, meaning this new block extends the main chain. Why they are saying this? Because there could be sidechains also available, which a new block may refer to. Orphan blocks. If a valid block is received and no parent found in the existing chain, that block is considered as orphan. Orphan blocks are saved in the block pool where they will stay until their parent is received. This can also happen. Sometimes a previous block marked in the newly created block may be still in confirmation process and yet to be received. So in this scenario, the child or block or candidate block has already arrived for the confirmation to the existing blockchain, and during this it will not find its parent block because it is already in process of creation. Considering this, the valid blocks will be parked in orphan block pool. And when any new block arrives, the hash ID of that block is validated, and if found as previous block ID of the orphan blocks, then they will be added along with their parent block's chain. Once the parent is received and linked into the existing chain, the orphan can be pulled out of the orphan pool and linked to the parent, making it part of the chain. Orphan blocks usually occur when two blocks that were mined within a short time of each other are received in reverse order, that is child received before the parent, and that we have already explained. So it is very simple to understand how orphan blocks are created and how they are again put into the mainstream when their parent block arrived. Now, how bitcoins are assembled in the longest chain. By choosing the greatest difficulty chain, all nodes in the long run accomplish organized wide consensus. Brief errors between chains are settled in the long run as more proof of work is included, broadening one of the conceivable chains. Mining node vote with their mining power by picking which chain to extend out by mining the next block. So it's up to miners to decide which chain they need to follow. When they mine another block and expand the chain, the new block itself speaks to their vote. So till now, we have discussed about whole mining process and how the blocks are selected and added to the existing blockchain. So let's see what are the difficulties in solo mining. So we have seen how solo mining of Bitcoin works in our last session videos. So however, solo mining is becoming difficult. Let's find out why. Mining and the hashing race. Bitcoin mining is also a great degree aggressive industry. The hashing power has expanded exponentially each year of Bitcoin's presence. The computing power has already increased at very high level, and our computers, next-gen computers, are already capable of doing huge amount of transactions as compared to the previous generations.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
The competition between miners and the growth of Bitcoin has resulted in an exponential increase in the hashing power, total hashes per second across the network. The acquaintance of SIC mining lead with the another Goliath jump in mining power by setting the SHA-256 work straightforwardly on silicon chips, particularly with the end of goal of mining. So in overall, we see that our computer has become strong as per the requirement needed by the blockchain network mining, and use even by setting SHA-256 work straightforwardly on silicon chips, and they help in mining of the new blocks easily as compared to the previous generations. If we refer to the picture in the slide, then it shows the hash rate, the estimated number of hashes per second that can be depicted from the graph. Trillions of hashes per second are happening per second, and the Bitcoin network is performing it very efficiently. If you can see, it was like 1 lakh in the starting, and then it has reached 6 lakh hashes per second in last few years, increasing the computing power or hashing power very efficiently, or you can say exponentially. Difficulty rises with the hashing power of the miners. As the amount of hashing power applied to mining Bitcoin has exploded, the difficulty has risen to match. Total hashing power in giga hashes per second over 2 years graph you could see on the slide against the estimated number of terahashes per second, trillions of hashes per second. You can see the blockchain network is performing. You can already see our blockchain is already performing trillions of hashes per second, and that has really exploded the block mining inside the blockchain network. As compared to previous, many blocks means more number of blocks are generated and exploding the whole blockchain network. And with this, we expect the block Bitcoin network to be exhausted soon. Mining by pool of miners. That means we'll be discussing about the second type of mining, that was pooled mining, where pool of assets were performing the mining of new blocks. How it happens? Since solo mining has become impossible with the increasing difficulty in the Bitcoin network, so there came a concept of pool mining in order to increase the computing power of the mining nodes. So miners have started mining in the pools in order to increase the efficiency and reduce the computation time in order to participate in the consensus process. This slide depicts the process of mining by pool members. Mining pools coordinate many hundred or thousand of miners over specialized pool mining protocols. The pool server will periodically make payments to the miners' Bitcoin addresses once their share of the reward has reached a certain threshold. That means miners in the pool are not awarded for each block creation. Once a certain amount is aggregated, then they are paid in one go. Successful blocks pay the rewards to a pool Bitcoin address rather than individual miners, which means rather than paying individually to all the miners, Bitcoin miners pool is paid against the awarded blocks. The individual miners configure their mining equipment to connect to a pool server after creating the account for pool, and this way they become the member of that particular pool. Their mining hardware remains connected to the pool server while mining and synchronizing their effort with the other miners. So here we can clearly see many members or many miners are collectively working in a pool in order to find a solution to the given proof of work problem. The pool miners share the effort to mine a block and then share in the rewards. Whatever rewards are provided, it is fairly shared with among the miners contributing to the pool. Pooled mining. Difficulty of target. The mining pool sets a lower difficulty target for earning a share, typically more than 1000 times easier than the Bitcoin's network difficulty, so as all the solo miners are able to mine and earn Bitcoins. When someone in the pool successfully mines a block, the reward is earned by the pool and then shared with the miners in proportion to the number of shares they contributed to the effort, which is quite fair. The miners that are working good and generating the results will get paid more. Now, how does a mining pool measure the individual contribution so as to fairly distribute the rewards? What is the process and what algorithm or logic used behind this so that none of the underworking nodes should cheat the system or can cheat the system? The answer is to use Bitcoin's proof of algorithm to measure each pool miner's contribution. Here again used same consensus mechanism in order to ensure the efficiency and calculate the contribution of any miner in the pool, but set as lower difficulty so that even the smallest pool miners win a share frequently enough to make it worthwhile to contribute in the pool. If some nodes are not awarded against their efforts, there are chances of losing them from the miners pool. Therefore, complexity of the problems are kept comparatively simple as compared to the solo mining process, so that every contributor in a block in a pool should be awarded and get fair chance of winning. Pool mining types. There are several types of mining pool payment payout system. The different payout systems are summarized below. Pay per share. The pay per share approach is to offer an instant flat payout for each share that is sold. The payout is offered from pool's existing balance and can therefore be withdrawn immediately without waiting for a block to be sold or confirmed. The possibility of cheating the miners by the pool operator and by timing attack is thus completely eliminated. The method results in the least possible variance for miners while transferring all risk to the pool operators. That means losing will not affect the contributors. The resulting possibility of for the server is offset by setting a payout lower than the full expected value. So this is how pay per share mechanism works for payout in the pool systems. There are several types of payouts, out of which one is the second is pay per last n shares (PPLNS). The first one we discussed was pay per share, and this is enhanced version of the pay per share mechanism. PPLNS has a higher payout. This is for people trying to mine as fast as possible. That means the nodes that recorded maximum number of blocks or more number of blocks in last n shares will be rewarded more as compared to the less contributing nodes. PPLNS will give you wide fluctuations in your 24-hour payout, but for hardcore miners, the law of large numbers state you will earn more this way. So this was all about mining inside Bitcoins, where we learned about during the whole session about mining process, their factors, their contributors, what are the factors impacting the mining, how integration, verification, validation of initial transactions, individual transaction by individual nodes happens, what is the type of mining, and what topics or how candidate blocks and confirmed blocks are created, what orphan blocks are, and how they are again collaborated into the Bitcoin network. So this was whole Bitcoin mining process that we discussed theoretically here.
So the project that we are going to cover is we are going to create an auction project. Okay. So what will happen in an auction? Okay, let's understand about auction first, and then we'll move ahead and see what are we going to program over here. Right. So auction is all about bidding on a product or service for its ownership. Right. Auction is all about bidding on a product or service for its ownership. Let's suppose there's a product owner who is listing his product for auction, right? Then what will happen? Bidders will come and bid on that product, right? Bidders will come and bid on that product. So depending on who is the, I mean, there will be certain conditions defined. On the basis of certain condition, the auction owner will select a bid for resolving, right? So on the basis of certain condition, auction owner will select a bid for resolving, and the bid will be resolved, right? So basically what happens, product owner come, and like this, obviously there'll be multiple product owners. They'll come and they list the product for auction. Once the product is listed for auction, it is open for bidding, right? Once the product is listed for auction, it is open for bidding. Then different bidders will come. Bidders will bid on the specific product. Okay. Then obviously every auction will have auction ID. Now we are going a little technical, and every bid again will have a bid ID, right? That's how that bid and that auctions would be recognized. So every auction will have an auction ID, and every bid will have a bid ID of the product on the basis of certain conditions. Like the conditions can be anything, like whosoever has placed the highest bid, or whosoever bidder has promised to resolve the bet in the earliest, okay, or seeing the background of the bidder, and all these things. There can be multiple conditions depending on the business logic. So on the basis of all these logics, we'll choose a particular bidder, and then the auction will be resolved, or we can say finally the auction will be closed and no more bids can be placed. Obviously when the auction has closed, further no more bids can be placed, right? That makes sense. I hope this is the product, this is the application that we are going to create. Okay, an application which will involve bidding of product or service for its ownership. The product owners can come, or auction owners can come and list their product or create auctions which will be open for bidding. The bidders will come and bid on that product or on that auction. Everywhere you can replace the product with auction. Product or auction owner will come and list their product or auction for auction. I mean, they'll create an auction, then bidders will come and bid on that product or auction. On the basis of certain conditions, the auction owner will select the bid for resolving. The auction will be closed and no more bids can be placed on that auction. Okay, guys. So let's move ahead and see a basic overview of what we will be going ahead and doing in this project. Okay. So firstly, obviously we'll have to plan out the structure of the project. This is how you should start thinking about. Okay, so over here, because now you have advanced little bit from what we have been learning, now you can understand the project from an architecture perspective as well, right? So now we'll be understanding that how we plan out any project. Okay, so the main agenda of doing a specific session for projects is how we, because see, right, we cannot just start doing a project, right? So when the application that we were building in our class, that was more like a simple application, right? But over here we are having a specific use case to be solved, right? A specific problem has to be solved using programming of Solidity or using Ethereum blockchain. So we have to think it from a top level perspective, that how do we plan out our project, what are different entities that will have to code, and then we move to coding. Okay, it's not that just we simply start writing the program. So firstly we'll understand the requirement, that what is bidding, what is auction. Okay, so then we'll start seeing that what are the different set of actions that will be taken. Okay, so when I say We have to create an auction contract. What does it mean? What are different set of auctions that will be taken? What are some major processes that will be followed? So the major processes like listing of a product or auction, like creating an auction, bidding on a particular auction, resolving a particular bid for a particular auction, and then closing the auction because the purpose of that auction has been solved. So these are the major process flows that will be taken care: creating an auction, bidding on that auction, selecting the particular bid, and then closing the auction. Okay, now that we have understood that what are the major processes that will be followed in the use case, then we'll start planning out the architecture, the structure of the project. So now we'll move ahead and see what are the different things that we'll have to plan out, right? So when we talk about an auction, what are different parameters that an auction can have? Firstly, we'll see, this is how we'll have to think. So over here, what is the asset? The asset is an auction, right? An auction becomes the asset, which will be transferred from one person to another, right? So what are the different parameters an auction can have? Can anybody guess? Parameters like an auction will have auction ID, right? In the same way, what are different parameters that an auction can have? So let me add it one by one. So an auction will have auction ID. Then what else? Auction owner. Yes, absolutely. Auction name can be there, but not needed because we have auction ID. Definitely it's optional. We can keep it. Auction amount. Okay, maybe we can keep minimum auction amount, that minimum this value has to be placed, right? Minimum auction value, something like this, that minimum this much bid has to be placed. Auction time, yes. So we can have, although it's optional, but yes, we can have auction creation time, end point. Okay. Yeah, the time auction was resolved, maybe. Yeah, auction. So yeah, so now I hope this gives a clear understanding of what are the different parameters that we will have inside auction. Any idea how we will code these parameters? How we will create where, using what we will code these different parameters in an auction? We will code them using struct. Why struct? Because with struct we can create our own data type. And if you remember, the example that I gave during class about how we'll store different data of a student of a class. We created struct for that, where we wanted to store name of that student, class, roll number of that student, whether he or she is passed or not, phone number. Then we created a struct of that student. So here also we will create a struct of this auction. Perfect. Now let's talk about a bid. What are different parameters that a bid will have? Okay, so there will be bid ID, bid value. For bid, we don't need start time and end time because bid is the bid which will be placed at one time. But definitely for bid, we'll have to map it with auction. Map a bid to a auction, right? Auction doesn't need to be mapped, but a bid has to be mapped to a particular auction, right? A bid has to be placed on a particular auction only. So bid ID will be mapped to a auction ID. Bid result, yes. So whether that bid was selected or not. Good. So this is exactly what is expected. So you think it's right or wrong doesn't matter, but you think that is what is important. When you think, obviously when you understand it from a logical perspective, you'll think it right. When if you created this document now, absolutely you can create a project. So before moving to programming, before actually just starting to write a program, this document is very important, and you need to understand, all of you need to understand this, that create a document like this which will make you very clear about the project. If you are very clear about the project, you already know Solidity, right? So you can creating programming the project won't be a difficult thing, but starting to think about how we approach the program, how do we approach the project to start writing the program, that is important. And for that, this document is mandatory. But for now, it is more than enough. So now we have an auction. Okay, obviously bid also will be coded using struct. So we have an auction, we have a bid. Now, do we also need a state of the program? And if we need a state of the program, how we will define the state of the program? How state of program will be defined? And the state of program will hold what? I mean, what is that entity for which the state will be defined? Okay, so for the first thing, it's very clear that we do need a state of a program, right? How about the second question? How the state of program will be defined? A state of a program means how a program will function or change its state from time to time. How the program will change its state from time to time. Remember in enum we used to define the state of the program? Exactly. So we will be using enum to define the state of the program. And then what, I mean, the state of the program will be holding what? Or the state of the program will be defined for what? The state of the program will be defined for auction, right? The state of the program will be defined for an auction, like whether an auction has been created and then live and then ended, right? The auction can either be in created state or be in live state or be in ended state. These words you can change it absolutely. I mean, in place of live, you can keep anything active or any other word you can use. That is absolutely fine. Okay. So, but overall, the auction will have three states, right? Either it will be in created state or in live state or in ended state. Okay. So definitely, so these are different states of a program. How we will define all these states using enum. Okay. Now we have discussed about auctions. We have talked about bid. Now we have talked about the state of a program as well. What are the different functions that will be needed? Okay, so first function bid is definitely, but the very first function should be to create an auction. Okay. Second function can definitely be to place a bid. What else? One function can be to create an auction, another function can be to place a bid. What else? Auction item. Okay, so do you mean to say view an auction? Okay. Bid successful or failure. Okay, so do you mean to say that view whether a bid is accepted or not? Okay, to make the payment of the bid. Okay, for a auction, to view the bids. What else? Cancel any bid. Okay, so let's have cancel an auction and then cancel a bid. What else? Set bid result. Okay, but bid result will be automatically decided on the basis of whether a bid has been accepted or not. So we can code it accordingly. And everywhere there we see a view, that will be a getter function, and wherever there is no view, that is a setter function. What else? But it's good that you all of you are thinking. That's the most important thing. As I already told, right or wrong doesn't matter. The thought process should be there. Okay, so as of now, it's good. So these many functions will be there. Okay, so now we have talked about functions. Now let's talk about modifiers. Do we need any modifiers? What kind of modifiers do we need? Okay, yeah. So basically over here, we will be having first modifier will be to a modifier which will only restrict owners of auction to see something. Maybe we can call it as only owner, only auction, only auction owner. Sorry. The second type of modifiers can be only bidder. Okay. And a third type of modifier can be only, I mean, both auction and bidder. So I hope now we are clear with almost all the parameters of this, right? We are clear with what how do we program. We are clear with what are the different entities an auction will have. We are clear with what are the different entities a bid will have. We are clear with what are the different as to how do we manage the state of the program. We are clear with all the functions, and we are clear with all the modifiers. So definitely mapping, absolutely. So we need multiple mapping variables. And what are the mapping variables that we would be needing? So mapping an auction, mapping a bid. What else do we need to map? Maybe obviously we'll need a default mapping, that is balances, right? Which maps address to a data. So now we'll start looking into the program and we'll see how do we create the application. So starting with the very first thing, Pragma Solidity version. We define the Pragma Solidity version of the compiler that we are using. Pragma Experimenter ABI encode version 2. Now what is this? Basically, whenever we are trying to use some of the features of Solidity that are in the experimental phase, okay, whenever we are trying to use some of the features of Solidity that are in the experimental phase, we put this line of code over here. If we comment it out, there will be certain things that it will say that these are not accepted. Okay, like over here you can see we cannot define a specific memory, the return type of a function as a memory output or as anything, over here. So these are some things that are yet in the experimental phase, and that is the reason we cannot do it. If we want to use that, then we will have to make it, or we'll have to add this line of code, that is pragma experimental ABI encode version 2. Okay, if we add it, then we'll not go get those errors. Okay, so this is an optional line that we may add it. Then as usual, we have library safe math. We all are aware that why do we need or why do we use library safe math. So we create a library safe math, and it has multiple functions like safe add, again taking two input parameters, public function, pure, returns an output, that is C, and it does this. Okay, so obviously we need to put the require condition before it executes something. Okay, so then again, like this, we'll put multiple different functions, like we have safe sub, safe mul, and safe dib. Okay, for doing multiple other things. Then we create a contract named as auction manager, and we write the statement using safe math for uint. I guess you all are already aware about this, right? Why do we use safe math for uint? Then we define a enum. Obviously, now we'll start creating everything like what we already planned for, right? So over here, we defined the state of the program, right? Where an auction can be either created or live or cancelled state. And we missed one thing, like auction, obviously there will also be a state for, there will also be a state for bid, right? So a bid can either be accepted or rejected, right? So for auction will have one enum, and for bid will have another enum. So both of this are defined over here, placed and accepted, anything the way you want to keep it. So over here we can see enum bid state is placed, like your bid is placed, and once it gets accepted, then the bid will be moved to accepted state. Similarly, auction state can be created, auction can be created, then it can be live, and then it can be closed. Then we have struct auction, that also we defined over here, that what are the parameters that a auction will have, right? So all the parameters that auction can have, we are going to define all those parameters over here. So we have auction ID, we have auction owner, we have the highest bid that is placed on that auction. Then we have auction start date, we have auction's expiry date. Then we can check if the auction is live or not, that will be of Boolean data type. Then we have the top bidder, that who is the highest bidder on that auction. Then we have auction index, like we'll create an array of auction, right? So when we create an array of auction, then what is the index of this auction that is created in that array, right? So over here, what I mean to say is, let's suppose we have an array of auction like this. Then over here, there will be multiple auctions available, right? So there'll be first auction that will have index of 0. Then there'll be another auction that will have index of 1, 2, 3, 4, and like this. Total 5 auctions will be there, right? So the auction that we are talking about over here, what index is it available on, or what index it is positioned at? So that will define over here. And then obviously the state of the auction, right? What is the state of the current auction? So auction manager dot auction state. Similarly, we'll have a struct for bid. So wherein we have a bid ID, we have an auction ID, because every bid will be mapped to an auction, as I already told. Then it will have a payable date, that by when this bid is planning to pay the amount. By when this bid is planning to pay the amount. Then we'll have a bid owner, obviously who is the owner of that bid, a bid value, and finally whether that bid is accepted or not. So are we clear with these two structs about different parameters of auctions and bids? So the purpose of this parameter is basically to define in which state the current auction is. Okay, when we want to check in which state the current auction is, then we will use the auction manager dot auction state. So over here, state is a variable, auction state is the enum, and auction manager is basically the specific address. So you can see here the contract address is auction manager, auction state is enum, and we are defining a new variable called as state that will be defined somewhere later. You can see over here. So next we move on to mapping. So what are different mapping that we create? So over here we saw that we are going to map all the auctions, we are going to map all the bids, and obviously the general default thing, that is mapping the balances. So what we are doing, we are mapping uint to auction, and we are placing it in a mapped variable called as auctions. So what are we trying to do over here? We are mapping a uint data type to auction. What is auction? It is the struct auction. Okay, which means every specific auction will have a index value. If you remember, I told this already. I told this earlier that every auction will be present in like an array, right? So how are we going to map each and every data on that array? So using uint, we are mapping it to an auction, and every auction will have these many parameters, and it can be stored in the mapped variable called as auctions. This needs to be understood closely. Similarly, every uint again will be mapped to a bid array. Okay, so over here we have the struct bid that is of array data type, and it will be mapped to a, so it becomes a two-dimensional array. Over here, the bid becomes a two-dimensional array. Okay, why it becomes a two-dimensional array? We need to understand this very clearly. Auction is, let's suppose these are auctions. Please understand this very carefully. So auction will be a single dimensional array, obviously. Why? Because we'll have auction. Let's suppose there are 5 auctions created. So this will be auction 1, this will be auction 2, this will be auction 3, auction 4, auction 5. But what we need to understand is over here, every auction will further have some bids, right? Every auction will further have some bids, which will again be of array data type, right? Which means zeroth auction, which is already a part of an array, is further having one more array inside it that consists all the bits that are applied for the zeroth number auction. Similarly, first auction will again have a list of bits that are implied to first auction. Second auction will again have a list of bits. Third auction will again have a list of bits. Fourth auction will again have a list of bits, right? So that is the reason I said that bid become a two-dimensional array. Why? You see this bid, any element of bid is a part of two array. First array among the arrays of bids, and second array among the arrays of auction. And that is the reason you will see over here that we have to map the bid as a array of bid and place it in a mapped variable called bids. So this is complex. You need to think this logically. Okay. So thinking it logically means you'll have to understand, you'll have to create, again, this diagram is very important. You have to understand that when we talk about auction, there will be a list of auction, but for every auction, there will be another list of array which will hold a specific number of bids that are applied to that specific auction, right? I hope that makes sense. So like this, we'll create 3 mapping. First mapping, auctions, will be mapping each and every index of array to auction. Similarly, another mapping which will map each and every index of an array to a array which is pointing to bids. Okay, and third is the default one that you already know. Every address will be mapped to a uint for storing the balance present on that address. Okay, guys, let's move ahead. So now we are going to program different modifiers. Okay, now we are going to program different modifiers. So we have modifier only auction owner. What is happening in this modifier? It is taking an auction index as an input parameter, and for that specific auction index, we'll try to make sure that the message.sender is always the auction owner, which means only auction owner is allowed. Okay, obviously for every auction there will be an auction index, and that is what we are trying to take as an input parameter. Okay, and we take it as an input parameter, we map, and we make sure that message.sender is equals to auctions auction index dot auction owner. How are we getting this? This is complex. This is something that looks complex, right? So let's try to understand that how are we getting this. So firstly, we have a auctions is coming from a mapped variable. In this, we will pass a key. Remember, what is the key over here? The auction becomes the key. This auction, which is coming from struct. So when we go in struct, then what we pass as a key? So auction index and the auction owner. So auction index dot auction owner becomes the key. This becomes the key. So when we pass this value to the auction, it will point towards the owner of this auction. It will point towards the owner of this auction. And that owner of the auction is related or is checked whether that is equal to message sender or not. If that is equal to message sender, well and good, then this modifier will be satisfied. Otherwise, this modifier will not be satisfied. I hope that makes sense to all of you. In the same way, we have modifier only bid owner. What is happening in only bid owner? So we are trying to have a modifier that is only bid owner. We are trying to take two parameters over here. Over here, we have only auction owner. We are trying to take one parameter, input parameter, that is auction index. Why auction index? Because if you see over here, I told that every auction is part of an auction array, and every specific auction will have an index, right? So which specific auction we want to target about, that index we will have to pass. So if we pass an index over here, now require message.sender should be equal to auctions. From where this auctions is coming, it is coming from this mapped variable. Obviously it is a mapped variable, means we'll have to pass a key to it. What would be the key of it? The key for this will become the auction index. What will be the auction index? That is already defined over here, and that we are passing from the input parameter. So let's suppose if we pass 3, so what will happen? Auctions 3 dot auction owner, which means, please understand this carefully, it will point to this auction, and in this auction, who is the auction owner? That will be defined over here. Every auction has a parameter called as auction owner, right? So when we pass auction 3 of auction owner, we are clearly pointing to a specific auction, and that will have a specific auction owner, right? That is what we are trying to define over here. We are trying to check that whether the message.sender is same as that auction owner or not. If it is same, well and good, then this modifier will be accepted and it will be true. Is it clear now? Primarily used for verification, yes. Then we have modifier only bid owner. So what will happen in only bid owner? In bid owner, we are trying to validate that whether a bid has been created, I mean, whether a bid has been proposed by a specific owner of that bid or not. Okay, so if a bid has been specifically proposed by the owner of that bid, then we will accept it. Now let's see what's happening over here. So bid modifier bid owner, we have uint bid index and auction index. Why do we have two different parameters? Can anybody guess? Yeah, so basically we can say that because every bid will be pointing to a specific auction only, right? Every bid will be pointing to a specific auction only. So a bid will never alone, never exist alone, right? A bid will never exist alone. A bid will always exist to a specific auction, right? A bid will always exist to a specific auction. So that is the reason whenever we will be talking about bids, it will have both the parameters, a bid index and a auction index. So over here, we have modifier only bid owner. We take two input parameters over here, bid index and the auction index. Then what we are trying to do inside, again, we are trying to map, or we are trying to check whether the message.sender is equal to bids, auction index, bid owner. Why this? It is this because if we see in bids, we have to pass firstly the auction index that it is mapped to, and secondly we'll have to also pass the bid index, right? So as you can see over here, bids will take first the auction index of what auction is it mapped to, and secondly it will take the bid index of what bid it is mapped to, and thirdly the bid owner, that will come from here, right? That will come from here. So like this, we'll have to check whether the message.sender is equal to the specific owner of that bid or not. And here what we are doing, we are taking a mapped variable bids. In that, we are defining the specific auction index that we have taken from input parameter. We are defining the bid index that we have taken from, again, input parameter. And then for that auction and that bid, a specific bid owner will be checked. Perfect. And then we have modifier only auction or bid owner. Over here, we are trying to check whether the person who is be calling that function will either be an auction owner or a bid owner. Okay, the person who is trying to call that function should either be an auction owner or a bid owner. How do we check that? Simple. Again, we take two input parameter, bid index and auction index. Okay, we take two input parameters, bid index and auction index, the way we were taking in bid owner, and then we put both the things. So we message dot sender will copy this thing and paste it over here, and then we'll put or operator. In or operator, we'll copy the bid thing and we'll put it in the bid thing. So now what it will do, it will check that whether the message dot sender should either be this or this. I hope you all know how does or operator functions, right? So or operator functions like this: 0 or 0 will be equal to 0. Now I'll replace it. 0 with 1 will be equal to 1. 1 with 0 will be equal to 1, and 1 with 1 will be equal to 1, right? So obviously only if both are not correct, only in that case this will be 0. Otherwise, even if 1 is correct, then obviously the output will be true. Same thing applies over here. So if the message sender is equal to this, fine, modifier will be true. If the message sender is equal to this, even in that case the modifier will be true. If the message sender is equal to both, even in that case modifier will be true. The modifier will only turn out to be false when the message dot sender is neither equal to this nor equal to this. Okay. Okay, what if I wanted to have a function which, what if I wanted to have a modifier which will only turn true if both the message dot sender should be a auction owner as well as a bid owner? Although practically that is never going to happen. There cannot be a single auction owner as well as the bid owner for the same address, right? Because a person who has created an auction cannot place a bid on his own auction. Practically that is not feasible, but technically just asking what changes we will have to do in order to make sure that a message dot sender is equal to the auction owner as well as a bid owner. Only then this modifier turns out to be true. What we'll have to do? Okay, so yes, so obviously the or operator will get changed to and. Now, how does and functions? Let's see. So if we replace this or operator with and, then what will happen? 0 and with 0 is 0. 0 and with 1 is again 0. 1 and with 0 is again 0. Only if both are true, then only it will be true, right? So what will happen over here? If both the conditions are true, which means message dot sender is equal to action owner and the message dot sender is also equal to the bid owner, only then this modifier will turn out to be true. So you should know the use of and or operator. Okay, we are good till here. Now what's happening is we are creating a array of auction. As we can clearly see over here, we are creating an array of auction. So we say auction list. Okay, so the name of the array of the auction that we have created is auction list, and we are defining the initial value of auction index and bid index is 0. Yeah, so we define the auction index and the bid index. We assign both of it to 0. Okay, initially. And then obviously, as I told, we need a array of auction. So we define an array of auction and we put it in the auction list. Now what is happening is we are creating a function called as create auction. Okay, if auction owner is equal to bidder, return false is return true. We can do this, but it will add extra lines of code, right? So in require, firstly we can say if this is equal to this, then do this, and then in another require we'll say if this is equal to this, then do this, right? So we'll have to add two require condition and a specific if else block as well. So we can do using that, but that would be slightly complicated. But over here we can do it in a single line of code. I hope that makes sense. So then we have a function create auction. Okay, let's try to analyze it and understand how it functions. So first of all, we are taking a specific input parameter, that is auction ID, and then auction ID can be anything that we want the ID of an auction to be. And then what we are doing, we are assigning that auction ID which we have taken an input parameter to the actual auction ID of the auction. So over here, see, each and everything will be assigned. Right now, they are just defined, but they are not assigned with any values other than auction index. Right? Auction index over here is defined as 0, as you can see. Other than auction index, nothing is defined as of now. Only it is just defined, but not initialized with a value. Right? So now we are trying to initialize all the data with a value. So we say auction.auction index.auction ID will be equal to auction ID. auction.auction index dot highest bid. As of now, it will be 0 because we are just creating an auction and none of the bids have been placed. Yes, we can say that we are defaulting the value for each auction ID at the time of creation. Then auction.auction index auction owner will be message.sender, and this is going to be message.sender throughout the program. Auction.auction index state, as of now, the state will be created. Again, auction.auction index auction start date will be now. And let's suppose if we want to say that auction will be expiring in 90 days or 30 days or 20 days, whatever we want to say, we can accordingly define it. Suppose if we want to say 10 days, then we can say 10 days. Okay, whatever we have, at whatever point of time we want the auction to expire, that much time we can define. And now you see the use of now as well. Now is the current timestamp. What is the variable now holding? Now is holding the time when the very recently block the has been created. Okay, perfect. That makes sense. So then auction start date and expiry date is clear with this. Then auction is live or not? Yes. Now the auction will be live because we have already created it. Now the auction is in live state. Auction index will be equal to the auction index itself, right? So right now the auction index is 0. So the first auction that will be created will always be of auction index 0. Once it has been initialized, then we are incrementing the auction index so that the next auction that will be created, for that the auction index value becomes 1, so that the auction index value over here is initialized with 1. Okay, so this is just to ensure that every time in the array a new auction is pushed, it also has a new auction index. If all of it is successfully executed, then return true. Okay, if all of it is successfully executed, then return true. Is it clear to all of you? Okay. So then we move on to another function, that is read auction. So what is happening in read auction? With the name of the function only you can understand that we are trying to read an auction. And when we are trying to read an auction, we just need one input parameter, that is auction index. So if we take the input parameter as auction index, it's a public function, it will view and will return all the parameters of the function. See, so we are returning all the parameters of the function, right? So how are we returning all these parameters? We are simply saying auction storage A is equals to auction index. So we are trying to put all the details of an auction into a storage variable called A. We are trying to put all the details of an auction into an storage variable called A. And then we are returning all the details of that A. So A dot auction ID, A dot auction owner, A dot highest bid, A dot state, A dot auction start date, all the details of that auction will be provided over here. Does this make sense to all of you? So this is how, see, the complicated programs are created. All you need to do is you need to be conceptually clear with what you are creating, and at the end you just need to implement what you have already learned. You see, this is a very complicated program and it's a very what do you say, no, a real-time example, but over here everything that we have already learned is being implemented. So this clearly signifies that you have to do practice, you have to do like this, you have to do lot of projects so that you can have more exposure to different things that we can do in a program, right? Okay. Yeah, memory variable and storage variable is basically like, if you remember, we talked about that the memory variable is like RAM. It only stores data for a specific execution. Okay, let's suppose we are calling read auction. For this read auction, it will hold the memory ID and everything, but when again we call the read auction, the value of this variable will be wiped off and it will be ready to take new input parameters and new values. But a storage variable is always fixed and will continue to keep a specific data for a specific amount of time. Okay, even if we call again the read auction, the value stored in A will not be gone, it will be there. Perfect. So now we have function place bid. Okay, let's understand. So over here what's happening is we are taking an input parameter for auction index and bid ID and bid amount and payable date. Obviously these are different things that we need to take input parameters while applying for any bid on a particular auction. Firstly, we need to know on which auction we are applying that bid. Secondly, we want to give a bid ID to our bid. Thirdly, what is the amount that we are paying in that bid or we are willing to pay for that auction? And fourthly, what is the payable date? When are we willing to pay? There are two required conditions. First required condition is the auction owner should not be only bidding. Okay, the owner of an auction cannot bid on his own auction. You can see auction owner should not be bidding on his own auction. Second required condition is auction should be live. If the auction is already closed, then we cannot place the bid on that auction. So these are two required conditions that we must have. Then we create a local variable I. The scope of this variable is only within this function, and we create another variable, local variable called as exist, and equate it to false. Then we say for I is equals to 0, I less than bid auction index dot length I plus plus. Now what does it mean? It means for every auction index, we are trying to place a bid for that auction. For every auction index, we are trying to place a bid for that auction. Okay. So we say if bid of auction index I dot bid owner is equals to message sender. Okay. Then require bid auction owner dot bid value should be less than bid amount. What does this mean? Which means, let's suppose I have already placed a bid. Let's suppose I've already placed a bid on any specific auction, and now I want to place one more bid because I see that now, my bid is standing very low. Other people's have already created a higher bid than what I have placed. So now I want to place a new bid with a new value. Can I do that? Yes, of course I can do that, but I'll have to ensure that my new bid value should be greater than my previous bid value. I'll have to ensure that my bid amount should be greater than my previous bid value. This is what is happening in this. And then we break if it is required. I mean, if it is successfully executed, then we break and we come out of the program flow. Then what do we check? If exist is equals to true, then the bid value, the new bid value will be assigned to the bid amount. Okay. If exist is true, then we'll assign a new amount to this value. Else will update all the parameter of bid as per what is taken in input parameter over here. Okay, which means this block of code is for rebidding. This block of code is for rebidding. Okay, and the else part of the code is for first time bidding. The else part of the code is for first time bidding. Okay, so when you are trying to rebid, then it will check that whether your previous value is greater than your current value or not. If it is greater, then it will assign your current value to the bid value. Okay, else if you are creating it for the first time, you haven't placed any bid before, now for the very first time you are actually placing it, then all the parameters of the bid will be updated with the values. And then bid index plus plus. Obviously, when the bid has been created, then we are updating the bid index so that the next bids that get placed on that auction will have another index. So if the value of highest bid is less than bid amount, and if the value of highest bid is equal to bid amount, and if the state is live, then return success is equals to true. So with this, finally a bid will be created. So placing bid is one of the most complex function in the whole program. Okay, because just because of this thing, creating an auction is easy. You only have 5 or 6 or 10 or 20 elements in an array. But when you are placing a bid on an auction, then there are two indexes that are mapped over here. First, index of auction, and second, index of bid. And then obviously all these parameters. I hope this makes sense to all of you. So you can closely understand this function at later point of time. It will give you more sense to this. Then we have another function known as total bid. So what is this function used for? Now we have all the easy functions. Yes, so right. So with this total bid, we can see how many total number of bids has been placed on a specific auction. Okay, how many total number of bids has been placed on a specific auction. Then when we want to read a specific bid, then we can read a bid using the bid index and the auction index. And obviously the modifier that will be used over here will be only auction or bid owner, right? Even a bid owner can read the auction, and even an auction owner can read the auction. So we will read it like this by displaying all the details of the bids. So we'll pass the auction index and the bid index to the bids mapped variable, and we'll store it in B and we'll return B. Okay. Similarly, when we want to read all the bids, we can read all the bids, but then that can only be done by an auction owner. So an auction owner can read all the bids that are placed on that auction. When we want to accept a bid, then again that can only be done by a only auction owner, what they can do, they can accept a bid. How do we accept a bid? We take in a bid index and an auction index. So we'll say bids, auction index, bid accepted will be turned to true. Earlier, the bid accepted was false. You see over here, the bid accepted is false, but for the time when that bid get accepted, then we'll convert or change that bid accepted variable to true. And then obviously we'll have to mark the auction also as closed, because when we have accepted a bid, then there is no point of taking more bids on that auction, right? So we say auction state, the state of the auction to be marked as closed. And then obviously we'll have to turn the auction is live variable to false. Okay, auction is live variable will be turned to false. So with this, a bid is accepted. When we want to close an auction, everything same will happen. It is just that bid accepted will not be there, rest same things will happen. You see, auction dot state will be changed to closed, auction is live will be changed to false. Okay, only thing is over here we'll have to check that whether the current time has surpassed the auction start date, which means whatever is the current time has already is greater than the auction start date. If it is greater than auction start date, we can close the bid. In closing a bid, everything remains same as accepting the bid. The only thing is that the bid accepted variable does not get true. Otherwise, all things remain same. At last, we have repay auction. So in repay auction, we can repay the amount to the auction owner, which means the bid owner will repay the amount to the auction owner. Okay, the bid owner will repay the amount to the auction. Whichever bid has been selected for a particular auction, that bid owner will repay the amount to the auction owner. And this code logic over here needs to be completed. Okay, although 70% of the code logic has been programmed, but you have to add one transfer and send over here, with the help of which you can actually transfer the amount from the bid address to the auction address, and that you have to do completed. Rest everything is completed. So with this, we are done with the whole auction contract. We have understood how an auction can be created, how the bids can be placed on that auction, how different bids can be accepted by the auction owner, and how the auction can be closed after acceptance of bid. And then finally, there will be a repay auction, which means whichever bid has been selected by the auction owner, that bid owner has to repay that much amount to the auction owner. And that you'll have to you'll have to add some more logic over here by yourself.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So now we will be seeing how practically bitcoins can be generated, can be used to create it from online websites available, and how can we become a miner of bitcoins through using these sites. So if you see my screen, there's an assignment that will ask you to set up Bitcoin miner on your personal computer if you're using Windows from nicehash.com. And the second, you can, if you have other OS including Windows as well, you can use bitminer.com that can help you to download the Bitminer client and create bitcoins on your computer and start Bitcoin mining. So let's see how Bitcoin mining can start by registering and downloading the software from nicehash.com. I will copy the URL nicehash.com and will try to open it on my Explorer. So first of all, I need to register on the nicehash.com in order to become miner of Bitcoin. I need to create an account. I will be using one of my account in order to become Bitcoin miner. I need to give password here. Obviously, I have to use it, so I have to agree with the terms. Let's wait until it registers this. Oh, I have to find my verification code in order to proceed further. Okay, I have received my verification code on my email. So it is a bit long. I need to copy it again from 222. I need to open my email. If you see, I have received an email from NiceCash as part of the registration process that I will be entering here in order to complete the verification and registration process. Okay. Now I am registered successfully. I need to enter my email ID and the password I used during the registration process. Okay, so once you log in on Nice Cash, you will see your dashboard. It shows your current Bitcoin wallet balance as well. I have no active workers and I have nothing as of now. So I have to become a miner. For there are options like for buyers, for sellers, you see your dashboard, you see your workers, statistics, you can see your wallet, withdraw, deposit, both can perform if you have balance in your wallet. You can see your Bitcoin address as well here. You can see pending bit deposits, pending withdrawals. You can again go to transactions to see more about your transactions history. You can go to settings and you can enable notification. You can do setting about your buying, buy hash power, sessions, withdrawal address, and you can use APIs using API key and other options. You can go to support. So before proceeding further, I need to enable buying. Now since I have registered successfully on NiceHash, I will now download the NiceHash client for mining process. So let's go to the URL again and we'll try to open our dashboard. So login. So now here you can just see from cell portion you can download the NiceHash client on your system and become a miner. So if you have NVIDIA processor, you can download NVIDIA graphics, and if you have AMD, you can download AMD. So I will install for NVIDIA and run it. Still downloading. Okay, let's wait for until it downloads. So once you are able to download the client successfully, you need to install on Windows 10. Keep in mind that your version should be as per your graphics card, NVIDIA or AMD. So the GPU version available in your computer should be checked first before downloading the client software. Now here on my system, running security scan is taking some time, so we need to be patient and see how it goes. Few important things about if you are downloading it for NVIDIA, you have to select NVIDIA version download, and before installing the installer, you will also need to have prerequisites like Microsoft Visual C++ 2017 in order to load your main screen. So that should be available as part of your prerequisites. So luckily I have downloaded and I am able to pass through security scan. I need to install the setup now. This I will be installing for my account and only. Press install, next. It is installing NiceHash and soon I will become a Bitcoin miner on my system. So I was telling you about minimum requirements that will be needed for NiceHash miner to run on your system. First of all, it should be Windows 7 or newer 64-bit OS only. It will not run on 32-bit OS. Then if CPU mining, modern CPU with SSE2 support is required. If you are using NVIDIA GPU mining, then GPU will with compute capability is required. And if it is AMD GPU mining, then GPU with OpenCL support is required. If CPU mining is used, most up-to-date chipset driver need to be used, and you will requiring Microsoft .NET framework. You can see on the screen it is using your Microsoft Visual C++ 2017 for 64-bit version for starting your Bitcoin miner NiceHash. If it is asked you for permission on the screen, then you have to click on yes. Do not say no. It will block the activation of the product. Along with the prerequisites, I told you need a very good internet connection in order to perform the mining work. So while it is installing, let's see how we can work further with the NiceHash. So once you have downloaded, you have to configure your Bitcoin NiceHash tool or client, you can say, in order to start with the Bitcoin mining process. There are two options are available for setting your Bitcoin address. They recommend creating a NiceHash account which links your preassigned Bitcoin addresses and has lower fees. Okay, so I have completed installing the NiceHash on my system. I will just run. nice hash miner version 2. I do not need the video. Closed. Let's wait for the launch of the nice hash miner. It's taking a bit time, so we will wait for it to launch. It's taking some time, so please be patient because Bitcoin miner is again a bit bulky software that require time to launch. So license agreement, you do not have any other option. You have to click on accept. Anyways, so this will not allow a robo. You have to prove yourself that you are a human. Just enter the code here 32668972. I'm entering and confirming the token. So again, waiting time. Wait until the beta version of NiceHash Miner loads. So if you can see on the screen while loading, it will check all your minimum requirements that I told you just in order to run NiceHash Miner on your laptop or on your desktop or any server. So it will also, while setting up, it will install the required softwares and libraries inside your computer system. So you need to maintain sufficient resources in order to run Bitcoin miner on your system. So if you can see, the Bitcoin, the NiceHash miner has already been installed and is running on my laptop. You could see there's no balance, no data available. I have on hardware details, it will be showing I have one CPU. There's no GPU installed, and I can add wallet here. I can add worker. I can start mining process. I can also configure my miner tool. I can set up language. I can set up currency in which I want to exchange and save the system and compare and use my bitcoins. It will be using my location as well. Then a mining setting I can do, start mining when idle, auto start mining, GPU fan control. I can set up device name and device type here. Logging also can be done. I can exclude logging as well by unchecking the log to file. Advanced, I can use advanced options to open config file, open log files, and I can enable notifications and disable them as well. About version, this is 2.0.2.8 using. So let's back to the home screen. Okay, so in order to start with the mining, I have to first set up the wallet. I have a username, so better I give my mail ID here in order to register my wallet. Okay, in this way I have created a wallet here. Now I have to benchmark my devices and start mining. I can benchmark all. You can see when shown here, just click, and I have to do standard mining. You could see current it is evaluating my processor and it will optimizing it according to the resources available. Don't forget to check the start mining when finished option. That will start mining automatically when benchmark optimization is finished. Simultaneously, you could see your dashboard. It should be having a wallet that is already created inside the. Oh, so I need to log in. If you see here on console, cryptocurrency is running. It has created already a new block. The mining has already started as part of the mining process. You see, this mining process is happening and the icon has changed to orange. If you see here, a new block has been mined. You can this all logs will be recorded in the logs that we are logging on. If you could see mining coin, this kryptonite V8 is starting 1x thread, no affinities, then no affinities, switch to assembler version of this. All details are logged here on your console while new mining process is running inside your laptop or computer. This way a new block is generated and detected inside the network. Mining process is still not complete, it is running. During the whole process, you always have an option to stop the mining process. Okay. So in order to view status online, I have to click here. If you see here, I got daily estimate earning of 0.87 something 87 bitcoins. This is not nowhere exist as compared to the US dollar. Data is coming, data is populating. You could see here I was not having any data. Now it is having some bitcoins available, earning available as part of this demo. And I should be able to log in also in order to maintain these things. Let's stop the mining process now. Okay, so let's see status online. What is the status? Since I have already logged in, it should be taking to my dashboard automatically. See, earlier I was not having any address or any worker, but now I have one worker associated. I have this much unpaid balance. I have profitability tabled here. I have got all mining status updated here as form of the mining process. So this is how I have shown you in form of demo how Bitcoin mining can be started using Nice Cash. Now in this session, we will be learning how to use bitminer.com in order to become a miner from your personal computer. From the screen, you could see already have a URL available. I will be just closing the windows from previous sessions and will directly open bitminer.com. So this is one of the option available in order to become a bit miner. In order to become bit miner, you have to log in here first. So since I have not yet registered, I should be creating an account before logging into the bitminer.com. If I try to log in here, okay, so go to the home page, click on sign up. There you need to give an ID. You can use your email ID in order to register here. Somehow this is not allowing me. Apart from OpenID, you can use other option also to log into the bitminer.com. I will be using my Google account in order to register here. I can choose a Bitcoin username and do sign up here as a new member. Okay, so it is not taking dot as part of the username. So I have created an account named Vista, and here it's showing on the dashboard, it is showing my Bitcoin balance, my Bitcoin cash, NMC name coin, all stand 0 since I have just newly created this Bitminer account. We have no unconfirmed coin or transactions. Now my email address also not confirmed. So before proceeding further, I need to confirm my Bitminer account. So in my email, activation email, I received this URL. I will be entering here in order to confirm my account. Okay, so I have confirmed here and my email address is confirmed. Now I will proceed with the account for using Bitminer in order to create and start mining the blocks. Since I have used my Google account, I will use Google ID to log in. It has allowed me successfully log into the server. So in order to run your Bitminer miner software on your laptop, you need to have at least one decent ASIC miner like the Antminer's S9 and relevant ASIC USB drivers, and you need to have latest version of Java. Make sure the reboot once installed happens, and you need to have a Bitcoin wallet as well. So before moving this, I need to check all the requirements on my system. Then since I have already created an account, I have to install the tool Bitminer client from the latest auto update option. So okay, so I will just install it here, download it here, and while it is downloading, it will run on Java. As we said, you need to have Java on your system. It is an installed Java file, and from this file I suppose it will be installing the required Bitminer software. Before that, it is asking to update my Java. So if you see, I have successfully updated my Java. Now I can proceed further. In order to install Bitminer and become miner, need to see downloads. I need to again run the downloaded Java file in order to install Bitminer. So it has started executing and it will install the required things inside the system. Wait until it installs. So my application blocked by Java security. Okay, how I need to allow now? Need to see configure Java. If you will also be facing this situation when you are trying to install this program. Your Java may still block your installation. So you need to allow your Java, so this mining software inside your Java program by using configure Java option. So I need to go to the security tab and I need to edit the site list in order to allow the Bitminer app. Just copy the URL and enter in the exception list. by clicking on add. Okay, so now our bitminer.com is allowed in the exception list of Java. So I guess I need to install again. Let's install the file again and see if it happens to be my installation file has been blocked and deleted from the system. I need to download again. I will try to install again now and hope we'll be successful this time. Okay, yes, this time it is allowed and I am able to install the software. So let's wait until the installation completes and we are able to become miner using Bitminer. Yeah, so we have now successfully installed Bitminer client and you can see it is started running. I may need, you can see here when I start the engine, it will start by taking my credentials that I used while creation of my Bitminer account. I can give worker name, say worker1 and put proceed. So it will now check my user to log into Bitminer account. You can see the logs working here. Bitminer worker difficulty is now 4096 connected to bitminer.com and Bitminer network difficulty is not this one. So now engine has started working and I have become a miner now. The meter is on. So this way you can start creating your Bitminer coins and if I refresh this page I should be able to see changes here as well. The above top this digit, that THPS, this shows your computational power as miner. Do not see anything happening here. Let's see. I have to start the engine. Okay. So as of now, it is working, but since we do not have sufficient balance, our Bitcoin generation is 0. Okay. We can go to the website once we have coins. We can use send Bitcoin options. We can send to Bitcoin address. We can enter the amount similar to our nice hash, and we can again try to send the Bitcoins to any other peer. Same way, we can again receive Bitcoins. We can send BCH Bitcoin Cash also here using send Bitcoin. We can give our address to any Bitcoin peer in order to send Bitcoin or receive Bitcoin to our account. We can also see transaction history by going here. So this shows I have no transaction history in the account, and this is all how you can use and utilize your bitminer.com to become a Bitcoin miner. So this was all about 2 exercises that we discussed and become a Bitcoin miner using NiceCash and bitminer.com. So let's see what Ethereum is and how it is derived. If we talk about history, Ethereum was conceptualized by Vitalik Buterin in November 2013. So from this we could see Ethereum is not much old. It came around after 4 years of the discovery of blockchain in form of Bitcoin, and then when it became into existence it became very strong and very popular among the existing blockchain technologies. Ethereum is a distributed open blockchain network and uses distributed ledgers in order to store the data in distributed manner. The key idea proposed was the development of a Turing-complete language that allows the development of smart contracts for blockchain and decentralized application. Bringing Ethereum into the scene was also required in order to make blockchain public and accessible among the broad range of audiences that were listening around blockchain and very keen to utilize in their business needs. But since of complex network of and complex design of blockchain network, they were not able to do so. So in this way, Ethereum aimed to enable innovations in 4 key areas: currency issuance, smart contracts, decentralized autonomous organizations, and smart property. So by introduction of Ethereum, the developers tried to make the process of currency issuance, smart contracts, DAO, and smart property easier in terms of implementation in blockchain. How? We will be learning it in coming slides during the whole session. So first of all, if you try to see how Bitcoin and Ethereum differs, both supports cryptocurrency And apart from cryptocurrency, Ethereum supports other applications as well. So let's see how much they differ among each other. So the idea came for Bitcoin was from digital money, and for Ethereum it came from word computer and word computer application needs to utilize blockchain for their functionalities. The founder of Bitcoin were Satoshi Nakamoto, and founder of Ethereum is well known, which was Vitalik Buterin and his team. Scripting language used for Bitcoin was Turing incomplete, while used for Ethereum was Turing complete, which was again an advantage over Bitcoin for Ethereum. Release date was January 2009 for Bitcoin, while for Ethereum it was July 2015. However, it was discovered in 2013, but it was officially released to public in July 2015. Coin release technique. Coin release technique for Bitcoin are early mining, and in Ethereum it is done through ICO. Average block time generation is 10 minutes approx in Bitcoin, while it is very much faster as compared to Bitcoin, that is 12 to 15 seconds only in Ethereum. Smart contracts. So while we start utilizing smart contracts in Ethereum, we should know what these are and what this term stands actually in terms of blockchain. The basic building blocks of programs written for Ethereum platform are called smart contracts. Let's understand what are smart contracts. A smart contract is a computerized transaction protocol that executes the terms of a contract, and when running on the blockchain, a smart contract becomes like a self-operating computer program that automatically executes when specific conditions are met. In short, if I explain in layman term, a smart contract is nothing. It is all the business logics and conditions and situations that your organizations want to execute as in the blockchain as part of the blockchain transactions. In order to remove third-party network, single authority, central authority, and make blockchain to run as autonomous body in order to approve all the transaction as per the industry or organization standard criteria. So whatever the logic being utilized and what are the rules are being emphasized in your organization or in order to complete a specific transaction, that can be written in programming language in a smart contract, and that can be run easily on your blockchain network for creation of new transaction as well as new blocks. So an option contract between parties is written as a code into the blockchain. The individual involved are anonymous, but the contract is written in the public ledger so that everyone can access it and use this for validation of the transaction. A trigger event like an expiration date and strike price is hit and contract executes itself according to the coded terms. So that makes smart contract automatically executable as part of the transaction initiation and validation. Regulators can use the blockchain to understand the activity in the market while maintaining the privacy of individual actor positions. There will be regulator nodes available in the blockchain that will also understand the activity in the market, and they will help maintaining the privacy of individual actor positions and participant inside the blockchain. Now let's see how smart contracts work in a permission blockchain. If you have not attended previous videos, so I will just summarize here what permission blockchain is. There are two kinds of blockchains, permission and public. In permission blockchains, every participant that is participating in the blockchain network as a node need to be aligned with some permissions, and he can act and transact within the network as per the permission granted to him only. While as compared to this, in public blockchain, all peer nodes or participating nodes are allowed to do any transaction without giving any specific permission, and they are open to do any action inside the blockchain network. Cryptocurrency used in Ethereum. Ethereum is incomplete without cryptocurrency. It was also generated as an idea in order to generate cryptocurrency along with serving other computer applications. Let's have a look at the cryptocurrency used in Ethereum. Ether. As in Bitcoin, the Bitcoin is the currency of Bitcoin network. Similarly, in Ethereum, Ether is considered as a currency for Ethereum blockchain. The Steem token of the Ethereum blockchain is called Ether in turn. It is recorded under the code ETH and exchanged on digital currency trades. It is also used to pay for transaction fees and computational services on the Ethereum network. Every time a contract is executed, Ethereum consumes token which is termed as gas to run the computations. So now in this slide, we could see there are two new terms are used. One is Ether and one is gas. So the cryptocurrency or Steem token generated in Ethereum blockchain as cryptocurrency are called Ether. The code used for them is ETH, which is used for currency exchanges and digital currency trade. So whatever the fees is included for the validators and miners inside this blockchain network is paid by using Ether in the Ethereum network. Also, whatever the amount, whenever a contract is executed, whatever the Ethereum consumes token, which is termed a gas. So, tokens that are paid and consumed as part of the Ethereum transactions, whenever the contract is executed, are called gas in order to run the computations inside the blockchain network. So this slide depicts the denomination table of Ether in comparison of other currencies. Wei, the unit Wei, is 1 Wei is equivalent to 1. The Kuei baggage 1 E3 is 1000 Wei equivalent to, while M Wei is Lovelace and is equivalent to 1 e to the power 6 Wei, that is 10 lakh. Similarly, it can grow higher and can be termed as G Wei, Shannon, and Microether, Szabo, which is 1 to the power 12, and milliether, which is called Finney, that equivalent to 1 to the power 15 Wei, and at the last ether, that is equivalent to 1 to the power 18 A Wei. This way, you can calculate your ether value in terms of Wei. Ether is used to purchase gas, a crypto fuel for Ethereum. So since we already discussed, gas is used as a transaction fees for computations, and ether is used to produce and purchase this gas in order to run the transactions inside the blockchain network. So now let's understand what gas is in the Ethereum system and why it is necessary. Gas, or you can also say fuel for Ethereum computations. Gas is required to be paid for each activity performed on the Ethereum blockchain. A transaction fee is charged as some amount of Ether and is taken from the account balance of the transaction originator. That means the sender node. A fee is paid for transaction to be included by miners. If you relate it to the Bitcoin, the process of mining the blocks and paying the fees and starting the transaction is almost similar to the Bitcoin blockchain. But the tokens and the currencies used for payment fees and awards will be different here as compared to the Bitcoin. The more the fee, the higher are the chances that the transaction will be picked up by the miners for inclusion in the block. So here this line depicts the difference between the transaction generation and their picking by the miner nodes. The more amount of gas is transmitted with the transaction created will increase the chances of picking that transaction by the miners for inclusion of the block. So the more gas or fuel you transmit with the transition of new transaction, there will be more chances of them being picked for block creation. Providing too little gas will result in failed transaction. The more the gas you provide with the transaction, the more the chances will be there for a transaction to succeed and create a new block. From the figure you can see, Ether buys gas to fuel up the EVM. EVM stands for Ethereum Virtual Machine. Assessing transaction cost. Transaction cost can be estimated using the following formula for any transaction inside the Ethereum blockchain network. Total cost equal to gas used into gas price. Gas used in turn exists and called for is the total gas that is supposed to be used by transaction during the execution of any contract. Gas price can be specified by the transaction originator as an incentive to the miners. So total cost originated will be distributed into two parts, gas used and gas prices, and the multiplication of it will be total cost of the running contract onto the blockchain network. If you could see from this slide, the gas price is equivalent to the incentive paid to the miners for completing successful transactions. What are the transactions in Ethereum? Let's see. The most notable difference between the Bitcoin and Ethereum blockchain is that Ethereum blocks contain both a transaction list and most recent state of the ledger of these transactions, while in Bitcoin it was only the transaction list that was maintained by the miners. Let's have a look at the transaction and the counts in the Ethereum blockchain. Transactions. The term transaction is used in Ethereum to refer to the signed data package that contains the message to be sent from an externally owned account to another account on the blockchain. Ethereum blocks contain both a transaction list and the most recent state of the ledger of these transactions as projected in the previous slide as well. So whenever you are forming a new block, accounts are the one of the main building blocks of the Ethereum blockchain. You could see this block, the first block has previous state and the next block has the previous state of this block as well along with, and so the transaction transmitted to will be having to address and from address and the value that is being transmitted at part of the transaction. So any transaction, any Ethereum block In this way will contain both a transaction list and most recent state of the ledger during the transactions. So if you depict from the diagram present here, you could see the previous state, the A3, the first block, the first node was having 920 ether, the second node was having 30 ether. Now when 10 ether is transmitted to A3 from BD, then it has increased A3 node's balance from 920 to 930 ether and BD node's balance from 30 to 20. So the amount of 10 ether has been transmitted from the BD block to the BD node to the A3 node, and this stores the state of and list of transaction both. Types of accounts. Accounts play a central role in Ethereum. There are two types of accounts: externally owned accounts that are called EOAs and contract accounts. Externally owned accounts, EOAs, are defined as the basic form of account. EOAs interact with and generates update on the Ethereum blockchain, while contracts are programmatically executive. The contracts are the accounts that are programmatically execute when they receive instruction in the form of a transaction from an EOA, that is externally owned accounts. Contract can push or pull funds and request these actions from other contracts, in turn calling on the code to perform dynamic actions. So if we restrict the Ethereum to only externally owned account and allow only transaction between them, we allow at an altcoin system that is less powerful than Bitcoin itself and can only be used to transfer Ether. The state of all accounts in the state of Ethereum network, which is updated with every block and which the network really needs to reach a consensus about. So the state of the accounts in the state of Ethereum network should always be updated with every block and which the network really will need in order to reach a consensus about all transactions and before confirming and completing a new block creation. So in this slide, we learned about type of account, which could be externally owned accounts and contracts. And contracts are again programmable that can execute as part of receiving instructions from the externally owned accounts. Contracts are able to push or pull funds and receive these actions from other contracts, calling the other code to perform dynamic actions. So these collaboratively work. Sometimes contracts are working together with externally owned accounts in order to fulfill the transactions, or sometimes externally owned accounts are running alone in order to generate altcoin-like system, which is less powerful than the Bitcoin. Now let's see how approval occurs in Ethereum blockchain, and our new block is created here. Validators or miners in Ethereum. We have already learned about validators or miners in Bitcoin, how they are participating in new block creation, how they are grouping the transactions, and how their new blocks are registered or became orphaned as part of the validation process. Just like in Bitcoin, transactions are approved by the miners. Anyone can take on the role of a miner and approve the block of transactions. It takes around 12 to 15 seconds approximately for a miner to approve a miner block, which is very much as compared to the time taken in Bitcoin, that was 10 minutes approx. At a theoretical level, a miner performs the following actions: listen for the transaction broadcasted on the Ethereum network and determines the transaction to be processed, similar to Bitcoin. Determine stale blocks called uncles or omners and include them in the block again. Update the account balance with the reward earned from successfully mining the block. And finally, a valid state is computed and block is finalized, which defines the result of all state transitions. Mining reward. Similar to Bitcoin, here also the validators or miners receive reward in turn for successful block creation. In order to incentivize miners for supporting the Ethereum network, a blockchain reward is granted to the lucky miners who generate the correct block in form of Ether. Currently, the block reward is set at 5 Ether for every successful block that is mined in Ethereum network. This will contribute to the inflation in the number of Ether available, and hence the value of each Ether will be updated. So this way we learn about mining reward and the format of reward provided in the Ethereum network after successfully mining of a new block. So let's learn about consensus mechanism in Ethereum. So what consensus mechanism was? If you remember about Bitcoin discussion, consensus mechanism was utilized in order to finalize the winner node inside the blockchain network while creation of a new block. So the same way here in Ethereum as well, for any distributed computing system to properly function, there needs to be a mechanism by which the entire network can come to an agreement on its state or how its token supply is divided among registered addresses on the network. So let's have a look on the consensus mechanism used in Ethereum. We'll see what consensus algorithm is used.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
In Ethereum kind of network. At the time of writing, Ethereum uses a similar proof of work protocol known as Ethash. Similar to Bitcoin, the core idea behind mining is to find a nonce that once hashed, the result is a predetermined difficulty level. Means here also each miner node is given a same problem of solving a puzzle where they need to find a nonce that is satisfying the given criteria of the puzzle in order to find the solution. It again uses different cryptographic primitive for its hashing function, known as SHA-3, while Bitcoin was using SHA-256 algorithm. Ethash is designed to make Ethereum both resistant to the high-powered mining chips that currently dominate the Bitcoin industry and more accessible to light client implementation that allow users to use Ethereum without needing to first download the Ethereum blockchain to their device. However, light clients download headers of the blocks for reference. So if you remember about Bitcoin discussions that happened in our previous sessions, all the validator or miners nodes were downloading the whole Bitcoin network inside their computer or computing node in order to form a new block inside the blockchain network. And they were including the previous block information inside their candidate blocks in order to generate the new blocks and participate in the competition for new block generation. And for that, if the node, the participating node was having high amount of computing power, then there were more chances of it to become a winner, and the blocks and the nodes with the less computing power were always striving to survive and compete in the competitive network that was having high amount of computing resources available to generate bitcoins. This problem Ethereum tries to solve at some extent by providing different kind of cryptographic algorithm, consensus algorithm using Ethash. So what this term says is, and how it is designed, it is again resistant to the high powered mining chips. It won't allow computation when you are having high powered mining chipsets that currently dominate the Bitcoin industry, and it is also easily accessible, more accessible to the light client implementation which has low resources, and in this they allow fairly all the participating nodes to participate and create new blocks without getting dominated by any other nodes on the basis of their computing power. But in order to generate new blocks and get the reference of previous blocks, the light clients can download headers only of the blocks for references that are existing already in the blockchains, because each new block will contain the reference of the previous block that will become the parent block of the same in future. Ethereum does far more processing than processing transactions. Means rather than apart from processing transaction, Ethereum does many other work as well. The Ethereum blockchain is intended to do far more than processing just share transaction. It is designed to execute complex code called smart contracts, where the functionality is only restricted by the imagination of its developer and accessible resources. The complex codes are executed in Ethereum Virtual Machine or EVM. So by writing smart contracts and logic, you can run your complex code on Ethereum Virtual Machine that can form logic and standard by collaborating your business rules in order to serve as a real virtual entity in order to process and approve and validate your transaction inside Ethereum blockchains. Ethereum releases. There are few that are discussed here like Metropolis, Serenity, and this can be defined as, for suppose for Metropolis, it is the next major Ethereum upgrade, and Metropolis was introduced on GitHub for testing, and it's just a matter of time before it goes live, not only introducing further protocol upgrades and opening the door for Casper, but also new interfaces for non-technical users as well. This will help gain further adaptation, and also it will help developers create easy to use apps. So Metropolis in short is a step again towards making Ethereum more simple to their developers and more user app friendly that are made available on the GitHub environment for beta testing and before releasing to the actual official Ethereum network as a new upgraded version. Serenity. Serenity is the last phase in Ethereum network. Release was planned for the start of 2018, but we might have some delays as usually. Serenity goal is to switch from proof of work to proof of stake algorithm considering the drawbacks of proof of work which exhaust much resources and energy as compared to proof of stake. And how it will do? It will be utilizing proof of stake by using a method called Casper by changing its blockchain, upgrading it to the new version. So this was all about our Ethereum topics and till now, and there are few left that we'll be discussing in coming sessions. So for now, we need to remember what we have discussed here. We discussed about mining in Ethereum, about the Ether currency, which is pet currency of Ethereum, and smart contracts in Ethereum. That is a new concept introduced in order to make your consensus mechanism programmable. We discuss about the gas, which is fuel or transaction fees in your blockchain, Ethereum blockchain, and how awards are given to the miners, which SHA algorithm is used for providing consensus, and what are the releases of Ethereum network. From this session, we'll be discussing about Ethereum development technologies. So let's see. Development technologies that seek to help network. In addition to the main Ethereum blockchain protocol, there are also supporting technologies in development that seek to help the network and components built on the network run more efficiently. That means there are development technologies that are being used in order to build Ethereum blockchain network and protocol in order to run the applications and the components inside the network that are built on the network and help the applications that are using your Ethereum network to run more efficiently. So this depicts actually what are the supporting technologies that are supporting development inside Ethereum blockchain. We have Mist application or browser also we can say that helps you developing and testing your Ethereum codes. Then we have decentralized applications that can be running on in form of Ethereum network. Then we have Swarm that is used for storage. Whisper is being used for messaging, and EVM, that is Ethereum virtual machine, is used for consensus mechanisms. Hardware clients. Then we have hardware clients from where a node or a miner can become a validator or miner of that Ethereum network, and they can use it for accessing the Ethereum network and transacting inside it. Then internet. Again, it's an important component which allows you to connect various distributed blocks inside the Ethereum blockchain network. Without internet, you know that we will not be able to access Ethereum blocks. So these all components in cumulative basis form and help driving Ethereum blockchain network. Then Web3.js. What is it? The key connection between the Ethereum network and your dApp application. What dApp stands for actually? dApp is your distributed application. The short form, the acronym is used for distributed applications, and in short it is called dApp. Web3.js provides a key connection between the Ethereum network and your dApp. Web3 allows you to compile, deploy, and interact with your smart contracts. If you go into developing Ethereum blockchain smart contracts, you will require Web3.js or another similar component in order to run your developed network smart contracts and test them before releasing them onto the in form of distributed applications. So what Web3.js provides, it provides a platform to your distributed application in order to compile them and test them about the behavior of the code you have developed. So if you could see from the diagram, the compiling, deploying, and interacting with Solidity contracts is part of your distributed apps. Now what happens when your code is developed, it will be sent in step 1, it will be sent for compiling, and when they say compiled Solidity code, so I must tell you Solidity is a major part of your Ethereum development, and it is the language that is being used in order to write your smart contracts. Okay, so it is a new language you can say, which is similar to JavaScript with some more modifications in according to support your Ethereum blockchain network. Then if a code is submitted, Solidity code is submitted for compile, it will be done through compile using standalone sols, that is Solidity compiler, or it will be compiled using Web3. Once it is compiled, your Solidity compiler will produce npm package, and if it is that will be used to compile the whole developed package, and in compile using Web3 compiler will be used to compile the Solidity code. And once it is ran on local Ethereum nodes sol contract functions. So again, Web3 platform will be used in order to generate the ABI and deploy your contract from bytecode Bytecodes are, if we talk about layman terms, they are generated executable that is returned from compilation of Solidity code or package. Okay, so once these are run on Web3 platform, they will be able to make RPC request. Okay, RPC stands for remote procedure calls, and this will help to interact with your local Ethereum node, example Geth. Okay, so Geth is again local Ethereum platform that you can have for your development purposes or for POCs or learning purpose. In turn, it will interact, communicate with the Ethereum network to deploy and interact the contracts over main Ethereum blockchain network. Okay, so this is how your web3.js, it will help you compiling your developed code and returning the executable packages, that is called bytecode in return, and then these are used in order to generate packages and interact with the and submit the transactions or in order to deploy on the Ethereum blockchain network. Okay, so hope this is clear to you. One thing I forgot to tell you here is ABI. Your ABI stands for Application Binary Interface, and that is generated from compiled Ethereum code, Ethereum Distributed Applications bytecode. Now, the second important component in your Ethereum testing or development part is MIST application. Styled as a decentralized application discovery tool, MIST is meant to serve as a wallet for smart contracts that features a graphical user interface. A desktop application is used to communicate with your node, allows users to dynamically set transaction fees and manage custom tokens. So, what is MIST application supporting? MIST application in short is supporting your wallet creation for smart contract storage, and it provides you graphical user interface in order to interact and do your job on the MIST application. You can use GUI to create your wallets for storing smart contracts, and when you have set up all this, you are using your desktop application in order to communicate with your Ethereum node. You have to log in and attach this to your Ethereum blockchain network. Okay, there in Mist application wallet, you can also set transaction fees, and you can also manage your custom tokens that are generated as part of Ethereum blockchain transactions. Mist browser versus Ethereum wallet. So Mist browser is also called Mist distributed app browser. Mist is a browser for decentralized web apps. Mist is still heavy development. It's not recommended to visit untrusted distributed apps until the full security audit is done. The current release allows you to open any Ethereum distributed app with the Mist browser. So, Mist browser is nothing, it is providing you a complete platform in order to create your wallet and run your Ethereum codes. It works as a browser where you can go and test your distributed applications, deploy and test your distributed applications, and check their behavior. Again, since it is a heavy development and all distributed apps are residing or connected on this network. So while you are deploying any new app or public app, you need to be careful before deploying it to the Mist browser. You have to be sure that whatever you are deploying on the Mist browser is really authentic and will not harm any existing nodes. Ethereum Wallet Distributed App. The Ethereum Wallet, also known as the Meteor Distributed App Wallet. These releases are therefore called Ethereum Wallet as it only offers a bundle of the Mist browser with a single distributed app, the wallet. The future with Metropolis release will provide a full Mist browser able to open any distributed app available out there. This means this is again kind of wallet that is provided inside Ethereum distributed blockchain, and this is also known as Meteor DApp wallet. So it helps you to offer a bundle of Mist browser with a single distributed app. You can run multiple Mist browsers in form of bundle inside a single distributed app that is called wallet. Okay, Ethereum clients. So what Ethereum clients are? Ethereum clients to interact with contracts. So these are the platforms provided by Ethereum or third-party developers in order to interact with your contract inside Ethereum blockchain. Developers write up the contracts, which are then converted into the EVM bytecode via a EVM compiler and uploaded onto the blockchain using an Ethereum client. So every developer that is developing inside or for Ethereum blockchain network will be writing their own code on their local laptop or desktop or any device. When they want to test it, they will be compiling this EVM bytecode via EVM compiler that is available, maybe Web3.js or any other, and the compiled bytecode need to be uploaded on the blockchain using a Ethereum client. So in order to interact with the Ethereum blockchain, you need to have an Ethereum client that will help you to upload your code and test there on blockchain network. There are various clients supporting the Ethereum network. Let's see what these clients are and what purpose they serve. Clients of Ethereum. Since the start of the Ethereum project, there have been multiple client implementations across a range of different operating systems and programming languages. So this client diversity is essential for the long-term health of the Ethereum. That means very simple. Every vendor, every third party has become a player in order to develop different clients that can interact, that have capability to interact with your existing blockchain, Ethereum blockchain network. And if we all know that if there are more vendors, more suppliers, then it will be again a healthy competition and it will help surviving your Ethereum network for long term inside the market. Ethereum clients are software that allow users to approve transaction and blocks, create, manage accounts on Ethereum, send and receive transactions from to your Ethereum accounts, deploy smart contracts onto the blockchain, and mine Ether on Ethereum blockchain. If you could see and if you have attended or if you know about Bitcoin blockchain, so these are all the functions that a miner does. Has every client has the capability to become and provide you all required features that you want to do on Ethereum blockchain. You can approve transactions, you can approve blocks that are for new generation, you can create manage accounts on Ethereum, you can keep your wallets maintained, you can send receive transactions, you can create new transactions from your Ethereum accounts that are signed up inside your Ethereum client. You can deploy your smart contracts onto the blockchain and run them. And again, you can mine Ether on the Ethereum blockchain. That means you can become a validator or miner and participate in creation of new blocks. And return, you can get Ether as reward. And so if you have a client of Ethereum, you can perform all these functions. This slide depicts list of Ethereum clients that are available in the market. Client Go Ethereum is a client of Ethereum that used to interact with the Ethereum blockchain, and it is using language Go. That is very popular client among the blockchain market that is generally used with the Ethereum blockchain. It is developed by Ethereum Foundation. The second is Parity. Language used is Rust, and developers are Ethcore. CPP Ethereum, that is based on C++ and is part of Ethereum Foundation. Then we have PyEth app, that means Python Ether app. It is again developed by Ethereum Foundation. Then we have Ethereum JS lib, that is based on JavaScript and uses this language to develop the smart contracts, and it is again a product of Ethereum Foundation. Ethereum J, that allows you to write your smart contracts in Java language and is developed and introduced from ether.camp developers. Then Ruby Ethereum, you can use if you have good knowledge on Ruby, then you can use Ruby language and Ruby Ethereum client in order to develop your smart contract, and this was introduced by Zenji. Ethereum H, Haskell. If you are expert in a Haskell language, you can use it in order to develop Ethereum smart contracts, and it was introduced by Block Apps developers and organization. So if you could see from the table, now you understand if you are mastering any or if you have knowledge or idea about any of this language, Go, Rust, C++, Python, JavaScript, Java, Ruby or Haskell, you can pick your Ethereum client accordingly and start developing smart contracts and logic in your Ethereum blockchain. Just to tell you, Go is again a form of JavaScript only. If you know JavaScript, you can quickly learn Go and start creating your blockchain smart contracts in Ethereum. So Go Ethereum, in short, it is called GA. The Go Ethereum client is commonly referred to as Geth, which supports the running full Ethereum node implemented in the Go language. Current features of Go Ethereum: it can be integrated with Mist browser. It is light client, beta, Swarm and Whisper used for POC, and these are proof of, and they can be used as an important component inside blockchain smart contract development. If you remember the previous diagram, your Whisper was used for messaging inside your blockchain structure, and your Swarm was used for storage. This figure clarifies more on it. Okay, so friends, this was about this session where we covered our Ethereum clients, we discuss about different Ethereum clients available, and then we discuss about Mist browser, Web3.js as compiler, and as part of development technologies for Ethereum. Okay, so now in this session, we will be discussing about platform functions. What platform functions are? Platform functions in Ethereum, while the architecture of the network certainly impressive, it's what's built on these intricate components that truly illustrates Ethereum potential. Let's have a look at the various platform functions in Ethereum available. DAO, called Decentralized Autonomous Organization. DAOs are organizations that exist entirely on a blockchain and are governed by its protocols, a unison of many long-term smart contracts between many people. DAOs are designed to hold onto assets and use a kind of voting system to manage their distribution. Two or more entities in DAO can interact with each other in a fully decentralized and automated fashion. DAOs also comprise a global network of nodes and members that all works together. So DAO is a global network of multiple nodes and members, and in order to work, they are working together to accomplish a design goal. In the DAO, each action or vote is represented by some form of transaction in blockchain. So as we know that every transaction in blockchain, Ethereum blockchain requires fees. So that means every action or vote will require a fees in form of gas or maybe some other mechanism. So we see that this how decentralized automation organization are taking part inside Ethereum blockchain and helping to action or vote inside or interact with the transaction inside Ethereum blockchain network. Okay. Working of DAO. How DAO or distributed autonomous organizations works inside Ethereum blockchain. A group of people writes a smart contract to govern the organization. That means, since we have already discussed in previous sessions, that any blockchain will try to not have any central authority or any mediator. And that is again a robust feature of any blockchain. So this comes a complicated situation. If there is no third party or any authority that is available in order to approve and validate a transaction, how it can happen? So like Bitcoin, we have smart contracts in Ethereum that are helping in order to govern the organization and validation of transactions. Smart contracts are nothing. We have already discussed these are the logics that can be derived from your business requirement as part of validation logic, as part of execution logic, transactions, or any other part of participation. So we have in DAO, we have a group of people that are writing smart contracts to govern the organization, and people that add funds to the DAO and are given tokens that represent ownership. So any participating people or node need to add the funds to the DAO, and in return they will get tokens, and that will be representing their ownership, that they are part of the blockchain network now. The DAO begins to operate by having members to propose how to spend the money. Since they have spent and they have become the part of the blockchain, now they can decide and they can start operating to and can start proposing how to spend the money inside that blockchain network. They will also participate in order to vote the members on these proposals. When the predetermined time has passed and the predetermined number of votes has accrued, the proposal passes or fails. So any proposal started within the by the DAOs and as part of the proposal to their members, they actually they go to the proposals generated, and then after some time, that is decided time, the votes are counted, and if the votes or proposal has sufficient number of votes, it will be passed inside the network. Otherwise it will be declared fail. Individual acts as contractors to service the DAO. Individual inside the in this kind of scenario act as contractors, and they are present to service the distributed autonomous organizations. Example of DAO. So by now, I think there must be some confusion in your mind about DAOs. This figure will try to explain what DAO are actually and how they are contributing inside the Ethereum network. Let's see an example like the step one. A country holds an election and wants to prevent voter fraud. So what DAO can be used? A DAO should be created to safeguard transparency and eliminate vote rigging. Now it will be DAO's responsibility once created that there is transparency to the voting and there should not be any fraud happening or any gambling happening inside the voting system. The third step would be to ensure by embedding the predefined condition inside the code. So everything we know that is happening using the smart contract, and this smart contract need to have a logic in order to define the condition into the code. Then once codes are written, voting tokens are issued to everybody eligible to vote. DAOs now, what all the eligible voters available inside the market will be getting the voting tokens, and they will be eligible to participate for the voting of DAOs. And then people start voting, or every vote is recorded and processed on the Ethereum blockchain which ensures transparency while allowing everything to run by itself and decentralized. Could see that every vote is recorded and is being processed on the blockchain network, and this way you will be having that transparency on the transactions and votes that are being generated inside the blockchain network, and you can which you can anytime audit or validate by going to the transaction list. So once sufficient votes are given and passed, and then a DAO will be elected inside the blockchain network. Now, since we understand now what are DAOs and how they are generated or created inside the Ethereum blockchain, we will be learning another important topic, DApps, that is decentralized app. Decentralized apps or DApps are computer applications that operate over a blockchain enabling direct interaction between the end users and providers. So, since we know blockchain is a huge network that is residing all over the internet and very much distributed. So we need to have some mechanism using which users can be able to interact with your blockchain network easily. And here your distributed application comes into picture, which helps you allowing interaction between your blockchain network and users. Okay. So DApps can be comprised of single DAO or even a series of DAOs that work together to create an application. A decentralized application has an unbound number of participants on all sides of the market. That means it can have any number of participants that can launch it and use it to interact with the blockchain network. Etheria is an example of distributed app. You can visit this etheria.world and use it as a Minecraft-like game. That is simply interacting with the Ethereum blockchain and helping you to understand the blockchain network and helping you to interact with the Ethereum blockchain. Let's go to this site. Okay, so you can simply search this on Google and you will be getting the blog about this Etheria blockchain network distributed app. If you could read it, Etheria is a virtual world in which players can own titles, farm them for blocks, and build things inside the Ethereum blockchain. The big difference is that the entire stage of the world and all popular actions are made through the decentralized, trustless Ethereum blockchain. So this you can use simply to play a game on available game on Etheria, where Ethereum blockchains are used. Okay, more details you can search and look on by going to the Etheria website. It's taking some time to open, so let's have some patience. I think the link is broken or down. Etheria.word is not working. Okay, let's see some other distributed app on Ethereum. Let's try searching some different strings. It's not generating any result. Etheria.word was working. I don't know why it is not working. So let's see this link. Okay, this page gives you few example of Ethereum distributed apps. One is your MetaMask. It is very popular and it is used to issue, even if you are a developer or tester of or doing a POC on Ethereum blockchain, you can use MetaMask in order to get some free tokens or free ethers on internet. Okay, so this we'll be using in our demo sessions. Then you have lot of names like Toshi, and you can have this Golem, Augur, Gnosis, Aragon, Tocket, Yuju Music. These are all example of Ethereum blockchain distributed applications, DApps, or you can say DApps. Let's see about this. Gitcoin is very popular. See, Gitcoin is again based on your Ethereum blockchain network, and you can start here as a developer and start building your coins or Gitcoins inside your Ethereum blockchain network. So this is using completely your Ethereum network in order to build cryptocurrency, that is Gitcoin. Okay, so these are few examples of dApps that we have just shown here. You can go into more detail about these examples and learn more about these Ethereum dApps. Okay, now we'll be discussing about types of distributed apps. Since we already discussed what distributed applications are the means in order to interact with your Ethereum blockchain network. They helps you participating inside the network and doing the transactions on and as part of the Ethereum blockchain network. Types of the apps. We also saw various various is the Ethereum blockchains available in the market that can be used to interact with the Ethereum blockchain network. So the first type of dApps is peer-to-peer transaction that uses a money app as Ethereum and uses the network has a lot of nodes connecting to this money app or Ethereum network, and then you have peers transacting with each other. So in this network, a user may need to exchange Ether as a way to settle a contract with another user. Since we have already discussed, Ether is a means of transaction, or you can say the currency of Ethereum blockchain network. So majorly it will be used in order to exchange the transaction or exchange the money in your distributed Ethereum blockchain network. So any contract or any transaction is settled using the Ether by transferring the Ether from one peer to another. And that is using the network's distributed computer nodes as a way to facilitate the distribution of this data. So in this first type of distributed app, peer-to-peer transaction is happening directly, and they are exchanging the Ether as part of or charge applicable for their blockchain transactions. Now comes the second type that has external authority on top of blockchain or Ethereum blockchain application. Example, oracles. The app mixes money with the information from outside the blockchain. For example, a crop insurance application that's dependent on an outside weather feed, say a farmer buys a derivative that automatically pays out if there's a drought that impacts his work. Okay, so if you could see, the second type of distributed app is having the basic blockchain application plus additional logic in order to meet the market demands. The current example gives you example of crop insurance application where the farmer buys a derivative that will be automatically paid if there is a drought impact on his farming, on his crop production. Third type is peer decision makers. Here, multiple peers are involved for creation of DAOs or other objects inside the blockchain network. So third type is DAO. The goal is form a leaderless company where we'll not be having any leader or central authorities or board of members, you can say. And then program rules at the beginning about how members can vote and how to release company funds and then let it go. So using DAO, you are creating a leaderless network using the Ethereum blockchain, where these logics written in form of smart contracts will help solving all the actions that were being done by leaders inside the company, and this way automating the whole process of consensus or you can say validation using DAOs. Now, future of distributed apps. As Ethereum and other projects have made writing dApp protocols quicker and more accessible, a number of possibly disruptive dApps have appeared. There is one is KYC chain. KYC chain allows users to maintain private identity wallet, which can be used to authenticate their identification in finance, legal, or commerce settings. Then another kind of the apps is Wayfund. Wayfund uses smart contracts to enhance crowdfunding services, including GoFundMe and Kickstarter. So whenever you want to release your funds in form of batches, this Wayfund provides a good mean using smart contracts in order to do these kind of transactions. It stores.io. Stores provide censorship-free, secure, and zero downtime distributed cloud storage by sharing data and storing it among a decentralized network of computers. Okay, so stores.io is a form of cloud that is or just cloud-based storage for sharing your data and storing it on decentralized network of computers. So these computers are connected in form of Ethereum blockchain and they're helping to store data online. You might have heard this stores.io as part of the various applications for cloud storage. Then comes 4G Capital. 4G Capital provides microloans for small businesses in Africa by utilizing the smart contracts. Note, a curated collection of various dApps can be seen at this address, the state of the dApps.com. So we will try to visit here and see various kind of distributed apps available. Okay, so if you see here, this page give you all a glimpse of all available distributed apps that are using Ethereum blockchain network. You can use, you can purchase, you can acquire any kind of app as per your requirement from this list of available apps. These are categorized here well as by their ranking, by their platform. You could see storage available here. If I go here, I could see the details of storage. I can add it to Drive and use as the cloud storage. You can also visit website of this T-app, storage.io, here on this website. This page is giving a quick view of all these distributed apps available, and you can have more details on by going to the company website. You can join the waitlist, right? Decentralized cloud object storage that is affordable, easy to use, private and secure, and completely built on Ethereum blockchain. Then we can also have look on some more kind of, let's have a look on this gaming category app. See, we have a lot of games developed on top of blockchain, Ethereum blockchain. You have Stream Monsters, Lordless, US Knights. For more information and more knowledge or more experience on this blockchain, you can start playing this game and see how this works. The more you explore, the more you learn. See? Okay, get your time and try playing this game or other applications try to use. You will get a flavor of distributed or distributed ledger Ethereum blockchain. This will really help you understand the applications running on the Ethereum blockchain are similar to the applications that you are using in nowadays on centralized application network. But the backend platform is completely different that is using and built on blockchain network. Since we are going through this demo, we will see, we already discussed about web3.js. We will just see what it is and what it stands for. You can go to this page and learn more about web3.js uses. This is your Ethereum JavaScript API. If you read more about it, it is a collection of libraries which allows you to interact with a local or remote Ethereum node using HTTP or IPC connection. Okay, this can be set up on your laptop in order to run and compile your smart contracts for Ethereum blockchain network. Okay, you can download this npm package of web3 if you have npm installed on your system. This way also you can install web3 on your system. Npm install web3. Okay, we will see all this while we are doing demo about Ethereum blockchain. So till now, since we have already learned sufficient information about Ethereum blockchain, now before moving to Solidity, we will try to do some demonstration about how to set up Ethereum blockchain network on your system. In order to set up Ethereum blockchain, you need an Ubuntu flavor or some other Linux operating system. You can do it on your Windows and Mac OS system as well. So for the POC purpose and for this session, we will be using Ubuntu 16.04 machine. And for the sake of easiness, I'm using my Google Cloud machine, which is of same version of Ubuntu 16.04 LTS. I can show you. So if you could see here, it is a Ubuntu 16.04 LTS machine. So going back to the dock, see what are the minimum requirement. You need to have OS 16.04 Ubuntu and minimum 2 GB RAM. You need to set up a virtual machine in order to set up your Ethereum network. We have already discussed what Git is. Go Ethereum using Go language for developing smart contracts is used, and we will be setting up same here on our Ubuntu machine. Let's update our packages. Once updated, we will be installing our common software properties using the command sudo apt install software properties common. Since I am on already latest version, I just need to move to another step of installing our Ethereum. So this command sudo apt get repository will add your PPA package of Ethereum into the Ubuntu repository. So this package is successfully added. You can see the GPG key ring is already created and added inside our package file. Once the entry is added, we will again update our Ubuntu packages to grab and pick Ethereum installation. Once package is updated with the Ubuntu Ethereum links, we can now install our Ethereum packages on our Ubuntu machine. So when we try to see when get is installed, we can check its version using get version command. You can also try the availability or check the availability of get on your machine using get command itself. Get -l can be used in order to see the manual or help syntax of the get commands. Okay, so we need to be patient and Need to wait until our Ethereum package get package is installed on my machine. It will require another 14 seconds to install the complete package. Okay, so it has fetched all the packages now installing on the machine. Just try to see what version of this machine it has installed. You could see get 1.8.20 stable version installed in folder user lib go 1.10. So this way we can see get is successfully installed on my machine. Now I will try to set up one project for my Ethereum blockchain. Let's go by the document only in order to avoid any command mismatch. Once project is created, once project folder is created, I will go inside it using cd, and now we'll create a node app in order to add script files containing get commands. Let's see. Let's create node underscore app inside my ETH folder project. Now, once my project folder is set up, I need to create a new account inside directory node app. So let's cd to our node app and try to create one account file using like account.sh. Okay, so I need to set up this command inside this file. So when I will be running or executing this file, this command like get -dir, the dir is the dir node directory inside our machine that will be storing all data related to this account new. So here from the syntax you can see get is the command that we are executing, and -data dir is the argument to it for data folder, and account used is new. Once created, I need to change the permission of it is u plus x in order to make it executable file. Okay, so once it is changed for permission, it is executable. I can try running this command and can create the new account. So while you are creating a new account, you will be asked to input and password. I can enter ether123 as passphrase, and my new account will be created here. You could see while creating your new account, it has already provided you an address in form of bytes. Okay, so now when you see here, you can follow the diagram and you can follow the steps in order to check your account file or account directory generated. Okay, you could see here one folder ETH node in respect to your account creation has been generated. Okay, I can go inside it and I can see what are the directory structures here. Okay, tree is not installed. Let's install this first. Tree is not required for blockchain, but instead it is a Unix command that is used to show our directory structure in form of tree. That is more convenient to see and observe. That shows a pictorial representation that you can see for your in our account folder. We have key store created for my account ID address. If you see this string matching here, the key store content contains the UTC time creation of this account, followed by some digits and then the address of the new account generated. If I go here and run this tree command again, I could see similar hierarchy or similar structure as shown in this document. Now, since we have created one account to run our blockchain network for Ethereum, now we will be starting to create our blockchain by creating a new Genesis block. If you remember, we already discussed about Genesis block, which is the very first block inside of any blockchain network that remains at the position 0, and our blockchain starts from that block itself. And that's why, because it is responsible for generating the whole blockchain, it is called Genesis block. So let's create one JSON file in my project folder called genesis.json, and I will be putting this content inside the genesis.json file. Okay, so you could see here the whole JSON content is using certain syntaxes like config. It will be assigning a chain in config. It will be assigning a change ID, and then it will be creating this block with home state block ID 0, then EIP block 0, EIP 155 block, and EIP 158 block. Then Coinbase will be 0 in hexadecimal, difficulty will be 0 into 1, and this or gas limit will be in hexadecimal, some value, nonce, and all other things that will be used during creation of Genesis block. Here, alloc properties will fill your accounts with Ether. You need to fill account address with the previously created account. When you set up Geth on your computer, you need to use the same genesis.json file in order to make successful connections between nodes. That means this genesis.json file will be used again in order to perform future transactions. So in this file, I need to replace the account address, that is this part, with the address generated during account creation. So let's create a genesis.json file, and here I need to get my address copied inside the JSON file. This was my account address. I need to make a note of it. Let's place this in place of account address. Okay, so this way my genesis.json file is complete now. I can proceed further in order to create my Genesis block. Now I will be creating an init file in order to generate this Genesis block, and will be copying and pasting the content, this command, from the document. This is again a get command in order to create your Genesis block. What it is doing, the command uses get command, then it provides arguments data directory to be used as same as your Ether account, and then init command in order to create my blockchain using genesis.json file. Let's change the permission of this file to executable, and I can run it now. So if you see, using this JSON file, my first Genesis block has been generated with these properties. The database for this lies here in this folder: home, Vista, Sunil, ETH code, get, chain data. Cache will be 16, handle 16, nodes are 1, size is this 152 bytes, time in microsecond it is 59.78 creation size, and there are other information when you are creating this Genesis block. This way we have created our first Genesis block for our first Ethereum blockchain. So now next step will be running get and interacting with JavaScript console. We will be creating a file called console.sh in order to run the console. Let's copy the command again. The whole line need to be part of this. It is again a get command which is taking input of data directory that you have created for your account, and the console argument will be provided as no discover. So this is done. Let's change the permission again and run this console file. Okay, so now my Ethereum blockchain console has opened, where I can run my multiple commands in order to check my transactions. So you could see here the blockchain has populated, and the self address and whatever it is providing here, you can read and understand. There are all the properties that are logged in the log file of the console. Now when console is open, I can test basic commands that are valid inside JavaScript console. I can check my Ether accounts using eth.accounts command. th dot. Okay, so this is not showing anything as of now since I have not added the account yet. I can also see the account balances, dot get balance.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Okay, so there is some issue. It is not listing my account. Okay, so it is not listing my account. I think there's some problem. Let's troubleshoot. Troubleshooting always gives us learning, right? So let's see what problem we have done here. There must be something. Okay. Oh, so problem lies here. The data directory of my account I have given is wrong. So let's change this. It was taking one level up. So once I have done it, I can try running again. And now let's see if it is populating the accounts. Okay, so now it is populating my address here. I can also check the balance. eth.balance, eth.account 0, oh sorry, get balance, sorry, just did a silly mistake. Okay, so get balance is the function to get the balance of any account. I have zero balance in my account. Suppose you have multiple addresses. Now how you can list the accounts? In that case, these accounts are stored in form of array inside the get. So you can give index of the array in order to get the account. Now again I did a typo, it will be S, and you can see 0. If I had another account, I could have given 1 in order to find the second address. So if we see here, it is undefined. We have created only one account as of now. Okay, so since we are able to run my script commands inside get console, I am able to list my addresses and I am able to get the balance of account using this. Now we can see how transferring ether happens between the accounts. So our account by default remains in lock condition. So in order to use them, I need to unlock them before using. So what I can do, personal dot unlock account, it should be capital, then account address. I can also give directly the address of my account. That will also work. Okay, so my account was logged using the passphrase that I have given, and I had given ether123 as passphrase. I think I given wrong key. Let's try typing again. EHER123. This time, yes, got unlocked now. Now I can use it to transfer ether from my balance to another account. The command used for sending transaction is, or initiating transaction is eth.send transaction from account 0 to from account 1. To utilize this, I need to create another account. Okay, so since I do not have balance, I will not be able to test this, but still I can try running this. I can create another account, create fetch. I think I have moved my account.sh. Suppose I name it 2. The name of the account I use as 2, and I create it again. Count. Sorry, I need to change the permission first. Plus x count dot sh, then account. Okay, let's do this. Let's provide a password again for this new account. Say ether123 again. ether123, and it has created this one more account that you can see inside your data folder. Okay, I need to list inside key store. Yes, so this has created another account with the address 5t44 and inside my wallet. If I try to run console again, not accounts, if we can I had not started the mining, I forgot to do this. Now when I start mining, our blockchain balance will start increasing it as it will start mining the new coins inside the block. So I had missed this step. So let's see how mining is happening and what it is doing. Okay, so if you can see, transaction is running and there is some percentage of transactions generating DAG is in progress, and this as this will process, it will be mining some new work. Okay, so let's click one more console. I will launch one more instance of my machine. Let's create another instance of my Ethereum machine where I will try to create another address, one more account. So until it is launching, let's see what is happening inside mining of new block. So my new machine is launched. The other instance is launched actually. So I will be going inside my project folder, ETH project, and I will try to run my account creation again. Okay, so if you see, I should be able to create another account, and when I run this, I should be able to see two accounts now. Let's see if it is populating inside the console. I need to kill this first. Launch the console again and try doing listing of accounts. It's not listing. Something I have missed here. Okay, so since I have run account.sh again by going inside the node app, for transferring the accounts, I need two accounts. So that's why we are creating second account in order to use my Bitcoin addresses in order to send coin from one node to other. Okay, so this script I have run twice and has generated another address. So now let's go to the project folder again and run console.sh. Let's try populating the accounts again. You could see now two accounts are available here, and now we can use the scripts to transfer coin or money from this account to this account, account 0 to account 1. If you want to populate them, you can populate them based on their indexes 0 and then 1. This way I can traverse all my Bitcoin addresses of accounts. So what's next? We will be transferring coin balance from first node to second node. In order to transfer this, I have to unlock my account again because I have just created it. So run this command, unlock accounts th.account 0. Again I have missed. I'm missing us again. So I will try to not miss this time. Okay, so this account needs password in order to unlock. I given and it is unlocked now. Similarly, once account is unlocked, I can transfer fund from first block or first node using eth.send transaction. I need to give from and to in order to give the addresses of sender and recipients. th.accounts 0, then comma, then 2 will be, sorry, I forgot to mention from. Should mention from. So the whole data you are mentioning here should be in JSON format. Okay. Spaces doesn't matter. You can keep them or do not keep them. They will not impact your execution. So this is your JSON formatted input to send transaction, and comma, you have to mention the value, also the amount of value or value of balance you want to transfer. Say some value. I will just use 10,000. You can say 10. Just keep it smaller because we are having less balance in our wallet. Try running it. Exceeds block limit. That means I do not have sufficient balance. Okay. If I had balance, I would have successfully transferred the 10 ether from first account to second. Let's try to mine some blocks here. I may get some balance. Okay, so you could see here transaction pool price threshold updated to price. Okay, I will just try to kill this and I will check my balance. Still I have zero balance only. Need sufficient mining in order to generate the balance inside the wallet. So I will not go into more steps. Now you must be having a feel like how you can create your addresses and how you can transfer funds from one node to other. Okay, so now making sure go get node is mining by checking a boolean property. Let's see why we were not able to do mining. But maybe it is set to false. Yes, so I need to enable this value. Check balances again. Okay, so I need to set it is equal to false. Okay, this is set to true now. Let's start mining. Try to mining again. Start one. Okay, let's see. Th.get balance for the first count. Not generating again. Okay, so if you see, we were not able to generate balance by mining the miners. Okay, so when I checked, I found problem with my Genesis block file. That means in my Genesis block.json file, I had given wrong address here. So because of which my account balance was not generating. When I did that, I did updated the correct address there. I am able to generate my ether balance here. If you could see here, I got balance some here, and if I do start again the mining, miner dot start one stands for thread. In within bracket you give the thread for miners to start. This many threads can start and proceed with the mining. So if I can do it again, close it again, and check the balance, eth.get balance, then get eth.count 0. Could see the balance has generated here. So in order to transfer the ether from one node to other, I will create one more account using my dot account script. I will keep the same passphrase for this as well, ether123. Okay, and I need to capture this address. This is very important. Because of this, we had to face issue there. Okay, I have recorded the address, and now I will try to unlock my account from the console and do the transfer of money from the transfer of balance from node 1 to node 2. Okay, account 1 to account 2. Let's unlock this personal dot unlock eth dot 0. Oh, spelling mistake again. Okay, so I need to give the passphrase here. When I give correct passphrase, it should be unlocked now. Now I can transfer the balance using this. First of all, let's check the balance of second node as well, second account as well. And when I check the balance using get balance, th dot 0, could see spelling mistake. Okay, so this is for 0 and for 1. Could see 0 balance. Now when we try to transfer here this much of ether from one account to another, this does, oh, okay. So I have successfully transferred this amount, and this is the transaction ID for this transaction. Okay. Now when we will try to see the balance again for this is for second account, see the balance has not updated yet. What could be the reason? Okay, so since we were able to transfer amount from one account to another, and the whole setup we did here was running as a single node with own Genesis block. And now we will be learning how to do get with multiple nodes. We will create a file inside my node app folder named static nodes.json. Okay, so before doing this, I need to in the console again and get this ID, the admin info of the nodes running. Admin.nodeinfo will give you the node information of current node. You see, this is the node information of current node that was created using this Genesis block file. If you remember, the same information we provided in the genesis.json file. You could see its listener address here, name, and encode. So the property we are interested is encode that we'll need to put inside the static nodes.json file enode. Okay, so let's copy this information. So once our static nodes.json file is there, I can copy this folder to another computer. Since I have one computer here only, I will just telling you the steps here rather demonstrating the whole thing on my computer. You can follow these steps and run this whole setup on multiple nodes. Once this is available, you can copy these all scripts inside node app folder to another computer and try doing the same exercise. Once it is done, you can again start the get using .console.sh file, and you can do all your inquiries in the node script console again. So this command is not running here because we are running in a single node mode only. So this whole thing, the whole transaction can be repeated again on multi-node as well. So this was a small demo about setting up your Ethereum and checking the information on Ethereum console, get console, that is called Go Ethereum. Okay, apart from that, there are multiple other script commands that you can run and get the output. Okay, you can get like we got our node information using admin.getNodeInfo, and similarly you can use other command as well in order to get more information about transaction. Also you can get the head information, you can get the number of blocks. If I run it here, without giving indexes, I can get all accounts that are existing as of now. See, we are getting an array of string here. You can also calculate the hash rate, the rate at which hashing is being done using eth.hashrate command. Current hash rate set is 0. You can also, like you do miner.start, you can also do miner.stop in order to stop the mining. Okay, if I do here, it will stop the miner. So just to summarize here, we learned about few commands during the exercise, like we learned about how to get Ether accounts using eth.account. We learned about how to get balance. We did this using eth.getBalance by providing the name of the account here. Then we learned how to send transaction by using eth.sendTransaction by giving the from and to nodes and the balance amount to be transferred in JSON format, actually from to and the balance. Then we learned how to unlock any account before sending the transaction, utilizing the amount present in his wallet. Personal dot unlock account by giving the account name. Then we learned about getting the hash rate, eth dot hash rate. Then another common command is miner dot start by giving the number of threads you want to start the mining. Then we learned about miner dot stop in order to stop the mining. Then we learned about, we can use this admin.nodeinfo in order to get the node information. Okay, and you can further use extensions in order to get particular and value of particular property inside this node.js node info JSON value, like we traverse through JSON formats, JSON values. Okay, we also learned about getting net peer count in multi-node Ethereum setup, Go Ethereum setup. So this was all to summarize about. There is much more. This was just a glimpse of setting small Go Ethereum network on your laptop or maybe on different computers or maybe on a virtual machine or a cloud. So just this was a start. There's a bit more. It's a sea ocean where you have a lot of things to learn. Blockchain is not a small thing. You have to practice hard, and there are various concepts and various kind of setups available because it is open source to market. Everyone is trying to build their own solutions, and if you see, there are a lot of platforms available for blockchain developments. So this was all about this demonstration. So in this session, we will be discussing about Solidity. As discussed earlier, Solidity is a programming language that is used in Ethereum in order to develop and design smart contracts. It is a flavor of JavaScript only, advanced version of JavaScript written and customized in order to write Ethereum blockchain smart contracts. So, what are smart contracts? As we already discussed, the Bitcoin blockchain stores data that's specific to keeping track of currency balance between parties. The Ethereum blockchain expands on Bitcoin in that it can store and do much more than the Bitcoin blockchain. Ethereum allows developers like yourself to build decentralized apps, and these decentralized apps are defined by the smart contracts. A smart contract allows individuals to exchange data in a trusted and conflict-free manner without relying on a third party like a bank, lawyer, or notary. So, these are written in such a manner that they embed the business logic and the transaction logics that your organization is trying to implement through the blockchain decentralized app. Due to smart contracts only stored on the Ethereum blockchain, they need to be validated or mined like a regular transaction. So, whenever you are writing smart contracts, you need a language to write your programs. There are various kind of programming languages available, out of which Go or Solidity is preferred very much and very popular among all the languages available. So what is Solidity? Ethereum would be incomplete if we do not give a native programming language, and that language is called Solidity. Solidity is a contract-oriented, high-level language whose syntax is similar to that of JavaScript. If you know JavaScript, then Solidity will not be very much new thing for you. You can simply go and write your smart contract in Solidity. It is designed to target the Ethereum virtual machine. What is Ethereum virtual machine? That we have already discussed. These are virtual machines that are created for running the smart contracts in Ethereum blockchain. Solidity is statically typed, supports inheritance, libraries, and complex user-defined type among other features. When proceeding further in this course, we will see Solidity has its own set of variables, arrays, enums, and other data structures like any programming language. It also has classes and constructors that can be inherited in order to write and inherit or extend existing classes. In contrast to an object-oriented language like Solidity is contract-oriented, because of which it makes it very popular in order to write smart contracts. It compiles instructions into bytecode so that they can be read by the blockchain network. So in this course, we will see how to use Solidity to create our smart contracts and what are the various component, or you can say functions or design methods or data types that are available in Solidity that can be used in order to write smart contracts. Layout of a Solidity source file. Source files can contain an arbitrary number of contract definitions, including directives and pragma derivatives. Version pragma. Source files can and should be annotated with the so-called version pragma to reject being compiled with future compiler versions that might introduce incompatible change. So whenever you are writing a smart contract using Solidity, the first line it is recommended to be of including Solidity version that your compiler should be using in order to compile your source code. So the first line would be written in the form of syntax that is pragma Solidity and then the version that you want to use or suggest your compiler to use while compiling the source code. And the caret symbol starting of the versions denotes that the compiler or the code version should be always greater than equal to the present version in the pragma syntax. That means here it should be always 0.4.0 or equal to 0.4.0 or higher version. Such a source file will not compile with the compiler earlier than version 0.4.0 and it will also not work on a compiler starting from version 0.5.0. Okay, so this means any compiler between 0.4.0 to 0.4.9 can be used in order to compile the source code. Considering this line is written as Pragma Solidity version. Comparison between memory and storage in Solidity. They are analogous to memory and hard drive storage in a computer. That means memory, the contract can use any amount of memory while executing its code. But when execution stops, the entire content of memory is wiped and the next execution will start fresh. This is very common and behavior of computer or computer programs run like this only. During the execution, the program's data is stored inside the variables in memory and once these are used and processed, then memory is freed up for other processes and executions to use. The storage on the other hand is persistent in the blockchain. So the next time the contract executes some code, it has access to all data it previously stored into its storage. So these two terms are generic to our computer systems and computer world, programming world. So there's nothing more to discuss here. General value type or data types, you can say, that are used in Solidity language. There are various kind of, like other languages, it has various kind of data types, like booleans, integers. Boolean may contain true or false values, while integers may be integer, signed and unsigned integer of various sizes. Keywords unsigned int to unsigned int 256 is in steps of 8 unsigned of 8 up to 256 bits and integer 8 to 1 integer 256. Unsigned integer and integer are aliases of unsigned integer 256 and integer 256. So if you are using directly uint and int, it will symbolize your unsigned integer 256 and integer 256 sizes by default. And if you give the number exactly, it will be using that size integer only. There are other kind of variables also available, data types also available. Address. Address is a new data type you could see different from other languages and that is available in Solidity only to hold a 20-byte value for Ethereum addresses. So address types also have members and serve as a base for all contracts. So any account inside your Ethereum blockchain will have an address and it is always identified using this base address only. When we were discussing about type of blockchain and when we discuss about it, we discussed there are two kinds of identities in your blockchains, anonymous and pseudonymous. So here address works as a pseudo identity for Ethereum blockchain accounts or nodes. Members of addresses, balance and transfer. It is possible to query the balance of an address using the property balance that we have already seen in our previous exercise about Ethereum setup. While we used the function of Solidity console or goeth console that was used like eth.getBalance in order to get the balance of particular account. And we also saw there how we use the address in order to transfer balance from one account to another account. So if we write the same query or same program here in Solidity, the syntax will look similar to below as you can see on the screen. There could be one address x is equal to hexadecimal 123, and then there could be another address of my account can be taken inside my address variable of address data type is equal to this. This again stands for the value of anything inside this object of particular class. So the meaning of this again is the same like Java or other JavaScript syntaxes. So while executing the transfer, the below logic can be implemented in Solidity programming or smart contract. If x.balance is less than 10 and my address.balance is greater than or equal to 10, then x.transfer 10. That means here this logic is trying to send some balance from my account or my address to x address. And in this account, it is checking the condition that whether the balance is again greater than 10 or not in my account balance. If it is there, it will transfer 10 to the x account. So this is simple. If you could see, this is the syntax of the last line is same as, or the whole code is same as, almost similar to your JavaScript code. There are other data types also available. You can use a string inside your programming. So string data types gives you value to use your certain strings as variable, and string literals are written and with either double or single quotes. These will be considered as string literals or simply strings. They do not imply trailing zeros as in C, or like foo represents 3 bytes, not 4. So like when we were using in C or any other language, we were closing it with semicolon, and that was again counting 1 byte again to the size of particular variable. While in this it will not be needed, and the size of the variable will remain to the count of the characters inside that string literal. As with integer literals, their type can vary, but they are implicitly convertible to byte 1 to byte 32 if they fit 2 bytes and 2 string. String literals support escape character also, like other languages such as /n, /x, nn, or /u, nnn, where n stands for particular number, where x nn takes the hex value and insert the appropriate byte, while /u nn takes a Unicode code point and inserts a UTF-8 sequences. So these are various kind of character coding that can be used while writing your business logics in smart contracts. There's nothing complicated. They are very similar to other languages that we must be knowing as of now. Arrays, very old and very familiar data type that is used in Solidity as well. In the same manner, they are followed and used in other languages. Arrays could be of any kind of, like it could be integer array, it could be string array or anything, or array of other complex data types. Arrays can have a compile time fixed size or they can be dynamic. Like other languages, like it can be, you can while declaring the array, you can define the size of the array and it can be of that size only and accommodate that number of variables. While in dynamic arrays, you can keep increasing the size and adding elements, and then it can be stored up to the defined size. For storage arrays, the element type can be arbitrary, and for memory arrays, it cannot be mapping. An array of fixed size k and element type t is written as tk. An array of dynamic size can be written as t with just square brackets without giving any size inside it. Variable of byte types and strings are special arrays, okay, that contains arrays of bytes or string literals. Arrays have a length member to hold their number of elements. Dynamic storage arrays and bytes have a member function called push, and that can be used to append an element at the end of the array. Apportioning memory arrays. Creating arrays with variable length in memory can be done using new keyword And as opposed to storage arrays, it is not possible to resize memory arrays by assigning to the length member. How it can be done, you can see in the given snapshot. If you're writing a code, you can do it like you can call a function with unsigned integer length variable, and unsigned integer memory array is declared as of dynamic size and using a new keyword. New is again used to initiate a new object of that existing classes. That can be your customized classes or user defined classes, or can be predefined classes in your Solidity language. Like unsigned int is a class of integer variable that is already predefined in your Solidity language. Then inside this function, you're also defining bytes memory variable b, and that you are assigning a new kind of new bytes object of given length using the new keyword. So if we compile it and we will get the values like a dot length is 7 and the b length is equal to length of a6, that is equal to 8. Okay, we'll be seeing these samples while we'll be demonstrating and doing practical labs for this Solidity language, and we'll see how data types and other values can be used and can be coded inside your smart contracts. So this way, this was an small example of apportioning your memory arrays. For this session, we will keep till here only.
So coming to the first question on this blockchain interview questions and answers, said it is compare blockchain with relational database. Well, whenever we think about comparing a blockchain with relational databases, 4 points are very important to be discussed. The first thing is the unit of data. In a blockchain, the data is stored in entities called as blocks, while in the relational database management system, it's stored in the form of tables. And then the second thing when we talk about is the point of failure. In a blockchain, there does not exist a single point of failure which might end up catastrophically. But then when you think about RDBMS, there are many points where if it fails, things can end up completely bad. Now, when we're talking about the third point, it's centralized control. In blockchain, there is no such thing as centralized control. The data is maintained in the form of ledgers, and then it's worked on based on that. And of course, when you're thinking about RDBMS, you do have the database management system and the admin who sits as the centralized control admin, basically working on the data. And then when you're thinking about editing and deleting data as per you wish, in the case of a blockchain, that is absolutely not possible because again of the ledger, the hyperledgers, and the data scheme that blockchain is built upon. But then when you think about a relational database, yes, it is possible to add data, edit it, modify it, and of course delete it as and when you require. Here again, in both places, there are many authorization techniques and safety measures that are put into place, but at the end of the day, it is possible very easily to change data in your RDBMS. Now, coming to the second question, it's what is blockchain technology? Well, you do have to know the answer to this in a clear and a concise way, because if you're at a blockchain interview, there is a very good chance you can get carried away with this answer, but then try to keep it very concise. See, a blockchain is nothing but a very simple incorruptible ledger that consists of multiple transactions that happen over the web. All of these transactions actually get recorded or they get programmed, right? It doesn't have to be a financial transaction, but it can be anything that can be put down in a text editor. You can have ledgers of these, you can have all the data stored in it, and you will have multiple copies of the data across multiple ledgers to make sure that even if there is one entity that fails in a blockchain, the rest of the chain has the data backed up such that it can pick it up and begin work, and in fact continue work without having any disruptions as well. So the technology that allows for this is blockchain, and it's been one of the most revolutionary technologies of our time, and it was made very popular to us by a cryptocurrency called as Bitcoin, and more on this in the next couple of questions. Now, moving on to question number 3, it states, what do you mean by blocks in the blockchain technology? Whenever we refer to blocks, right, understand this. A block is simply a list that consists of the records of data that's present in it. Whenever these lists are combined with each other, right, when there are more than one list, they're called as blockchains. The chain of blocks, right? A block contains a list of records. There are multiple lists. These lists individually become a block and eventually becomes a blockchain. It is as simple as that. Let's say, for example, there's an organization that has, let's say, 100 ledger books, a combination of which we entirely call it as blockchain. But then with these 100 ledger books, if you start picking it up one by one at a time, right? So there will be 100 different blocks, and there's one entity that's called as a blockchain that consists of these 100 ledger books. It's just a way of naming it, but then this is how it goes. It's a very important thing that you should know at this point in time. Moving on to question number 4, it states, how is a block recognized in the blockchain approach? Well, when you think about these blocks, this list the amount of data that gets stored into it. All of these blocks has something called as a hash pointer. These hash pointers basically link to the block, and it makes sure that it has a link between the previous block, the transaction time in case if there's a transaction that happened in the data, and of course a very clear and a concise way of stating the block. There is a transaction at this point in time, this date, up to milliseconds as well. So whenever having the recognition of a block is in concern, think about talking about a hash pointer and how it links one entity in the block to another, and any transactions performed in a block will be recorded with the timestamp of the transaction. Now, moving on to the 5th question, it states, is there any network specific conditions for using blockchain technology in an organization? But then when you think about it, right, it has to be a peer-to-peer network, and it has to have all of the wired protocols to ensure a lot of safety parameters and continuous connection from end to end. So what it really does is it validates the new block simply and helps the companies or helps the people who are willing to start up, this kind of a blockchain and bring it into their organization. It does it very easily because you really do not require any sort of third-party application. You really do not require any sort of expensive hardware to get started, to be honest. But then having the network is a basic requirement. So do talk about having the network and the protocols that govern the blockchain technology. But then do understand that there are no specific or expensive solutions to a blockchain requirement while beginning. Now, moving on to question number 6, it states, is it possible to modify the data once it is written in a block? Once a data gets written into a block in the technology of blockchain, the answer is no. It cannot be changed, because if you require any sort of customization or change or modification, all of the data that's present in all of the blocks must be removed, and then whatever modified data is there, it has to be put in to all the blocks. This is one very important reason that forms to be the entire foundational concept of blockchain, because at the end of the day, data is extremely cared for in a blockchain technology aspect. And here, when you're doing this, if you just modify it in one block and leave it, it really doesn't work, because blockchain doesn't work that way. So if you have to change something, you have to change throughout the entire blockchain architecture that exists, and then only you can have your new data or modified data to be present in a block. So when you're asked this question, make sure to present yourself this way. Now, coming to question number 7, it states, what type of records can be kept in a blockchain? Are there any restrictions for the data that are kept in a blockchain? Again, a very straightforward question. This is a very, very important question that gets asked a lot. Well, the answer is no for the second part of it. Is there a restriction to store any sort of data? No, you can store whatever is required, but then you must note, what you have stored, because at the end of the day, storage can be limited sometimes, because, technology, it works in a way where records get duplicated multiple times to make sure that your data redundancy is kept in check, and it is very much required to keep your data safe. So in that particular case, even though there is no restriction, it is always very valid to take care of the data that you put into a ledger. Now, what are the common types of records that are usually put in? Think about medical transaction, think about identity management, right? So, in India, we have something called as the Aadhaar. In America, you have something called as the Social Security. In America, you have something called as the SSN, or the Social Security number, and more. And then you have the transaction processing details, you have organizational details, management activities, key documentation events, and a lot more. So when all of these data are concerned, you might be asking a question of saying, is this all? Can I store only 6 types of data? No, because as I just mentioned when at the start of this answer, you can store whatever you want, but practically blockchain is used for this purpose. Now, with this, moving on to the 8th question, it states, what is encryption and what is the role of encryption in blockchain? Encryption, as you might know it, is a method you use to keep your data safe by changing its format or by changing something in a way where it doesn't give out what it's meant to for the naked eye. You can have a lock-and key system, you can have multiple ciphers, you can have multiple methodologies that you can use to encrypt your data. So whenever you're encoding a data, you're converting it from one kind of a format to another, where you can have it sent out through the network then, and then having the ability to know that someone in the network can capture your data and may misuse it is very important, because if you just send the data as it is, someone sitting in the middle of it during a phishing attack or whatever it is can take up all of your data and misuse it, right? So that's not what we want. So to avoid all of this, so we encode the data in a very strict way, in a way where only the receiver knows how the original data can be obtained from whatever was sent. This process is called as decoding the data, and doing this will make sure that there's overall security, your blocks are valid, and of course at the end of the day your entire blockchain is kept secure because of this. So at this point in time, it's very important that you understand encryption and you know how it works whenever data moves around in blocks, especially in the case of blockchain. Now, coming on to the ninth question, it says, what exactly do you know about the security of a block? Here's a very important question, and the answer to it is very simple. A block cannot be customized by all of the users on a network. It's only on priority authorization is required, and this authorization methodologies and protocols that are put into place will make sure that your data security is at top notch. That is, it has an excellent level of security. And when you're thinking about every single block, right, each of these blocks can be secured using cryptography, where you can have a lot of methodologies put into place where the organization or the person maintaining the blockchain really need not break his or her head about the security of the data, because at the end of the day, if it's in a blockchain structure, it's secure. Plus added parameters for the network makes it even more secure, and then individual block level cryptography methodologies will make sure the data is almost bulletproof in the network of a blockchain. Now, coming to the 10th question, it states, why blockchain is a trusted approach? There are many reasons why one would go on to trust a blockchain, and here is why. The first thing what happens is that it is compatible straight with any other business application. One, because blockchain is open source. Second, as we discussed, it's completely secure. And third, even if it was intended originally for online transactions, developers have paid a lot of attention, especially to the field of security, because in today's world, cybersecurity, keeping your data safe, and all of these are primary concerns, right? So to make sure all of this is put into place, no matter what business you own, no matter if it's an online business, no matter if it's a medical institution, or whatever you can think of that you're planning to implement blockchain into, do understand that the data will be secure. It's open source, so you really don't have to put in a lot of money at the start, and if you have proficient developers who can handle it, then you will have a very effective chain and moving your data from one point to the other. So a blockchain is easily considered because of all of these factors, but the primary one being security, in my opinion. Now, moving on to the 11th question, it states, what is secret sharing? Does it have any benefit in blockchain technology? So coming to the answer of this question, whenever we talk about secret sharing, right? Secret sharing is basically an approach that we take where we divide the personal information, of whatever data that is being shared into multiple units, and then we send it across to the individual users. So by doing this, what we're trying to do is that we're having the original information, and it can only be decoded when a member wants to share the secret, and all of them actually agree to share this particular data in secret, then only the data can be pulled out. By doing this, again, blockchain is proving that whenever it comes to security, it is in high regard. It brings out multiple advantages, especially in the world of security related technologies, and blockchain is at the top of it. So having your data sent out separately and having a common consensus to whom the data has to be shared to, and to when, where, what, why, and all of these other questions as well. So to do this, it has multiple benefits, and this is how secret sharing works. Now, coming to question number 12, it states, what is blockchain durability and robustness? I think by now you might have a clear picture of blockchain's robustness, because data is secure. If it goes in one of the blocks, it can be revived from the other blocks as well. And when you're thinking about durability and security wise, I think you already know how to approach those questions. Now, what happens is that whenever we have data in similar blocks where it's spread across a network, you can control all of these from one particular entity. It will absolutely have have no single point of failure, right? So think about a quick example about Bitcoin. Bitcoin was a cryptocurrency that was invented in 2008, and since then it has been working fine, and it's driving a lot of businesses without having any sort of significant disruption, right? If there is any problem that ever came with Bitcoin, mostly it was because of mismanagement or let's say unethical hacking, and other simple things such as probably bad intentions or human errors. But then there is absolutely zero flaws in how Bitcoin works. So the internet itself, when you think about it, has been durable for like 30-40 years now, and it's a track record that blockchain is willing to beat and work together as well, because in terms of security there is no beating blockchain. It is very durable and it is highly robust, especially for storing your data and moving it across the web. Now, coming to the 13th question, it states, what is transparent and incorruptible in blockchain? Well, one thing that you really have to know is that in the blockchain technology, right, all of the data gets stored into multiple blocks, and every time there is a check-in that happens to see if the data is all right or not. So whenever you have a self-auditing ecosystem like this, right, the network has to look back to check if each of the data is okay in every single span of time, and this is usually a 10-minute interval. And since each of these group of transactions is called as a block, there are two very important properties of a block that we have to discuss. One is that data is very transparent because in general it is actually a public piece of data. In general, it's the whole data that's being sent. And the second thing about it being incorruptible is that no matter what, blockchain data cannot be corrupted because it takes a huge amount, in fact an extreme amount of computing power to get a hold of the entire network that is working and then hijack it and mess with your data. This is literally not possible, but then this is literally not possible or very far-fetched even for people who would want to misuse your data. So in that case, data is very transparent and it is almost incorruptible in the case of blockchain. Now, coming on to the 14th question, it says, how does Bitcoin make use of blockchain? If you ever mention Bitcoin as a part of your answer, there's a very good chance this question can be asked as a follow-up. So what happens in the case of Bitcoin is that there are multiple wallets that users get assigned to, and each of these users with each of these wallets can have a part of the transaction, can have some data stored into them, and all of these data are stored in a ledger. So what these wallets do is that they have a piece of data called as a private key, or also what we call as a Bitcoin seed, and with this seed we sign transaction, we show proof saying that I am the owner of the particular wallet, and then whatever cryptocurrency has to be moved, whatever amount of cryptocurrency has to be moved, it gets moved around from one particular ledger to another, or one block to another as per requirement. Mostly it's the cryptocurrency moving from one person's wallet to another person's wallet by making use of the seed. But then when you think about it, there are many ways one can move money in the case of Bitcoin, but the basic working of it, the foundational concept of it remains the same. So when you ask this question, make sure to answer it this way. Now, coming on to the 15th question, it states, is blockchain an incorruptible ledger? Well, as the developer claim stands, blockchain cannot be corrupted no matter what, because at the end of the day, the technology is built to be extremely robust and it offers state-of-the-art security methodologies in terms of your data, in terms of whatever governs the data as well. So if you're asked this question saying, can we corrupt a blockchain? The answer should be a very straightforward and a confident no, because that's what the technology is put into place for, to be incorruptible and to be highly secure. Is it doing that? Well, yes, since a very long time, blockchain has been growing out to be an amazing open source technology that is helping keep our data safe and secure across a network as well. So in that particular case, blockchain is uncorruptible. Now, when you're thinking about the 16th question, it states, what are the business benefits of a blockchain? See, you can talk about this answer to this particular question for a long time, but then try to keep it very concise, because there are multiple business benefits of a blockchain, right? So you can have your data in a consolidated place. It can be consistent. All of the errors in your data can be kept minimal. You can verify your data and see if it's present. You will have authority of your data. You will know where the data is moved from the origin to the place, if it's a shared ledger, if it's a common ledger, and of course at the end of the day you will understand that there is a good amount of trust and integrity in the flow of transaction of information that happens in a blockchain, because no one can get on a blockchain and misuse your data, as I mentioned, right? And then when you're thinking about immutability, immutability means that you cannot change the data once it gets into your ledger, and this will make sure that there is a very good amount of transparency and people cannot go on to misuse data by changing something of value there, and then that leading to a catastrophe as well. That cannot be done. And it's not just this, because let's say contracts are executed on business networks. Whenever you think about blockchain, all of these technologies that govern the blockchain is smart, it's automated, and mostly these businesses that impart blockchain have seen that they get an extremely high amount of speed of execution when they have used blockchain. The overhead costs are reduced, and of course their entire chain is at less risk, because at the end of the day this is what businesses want and this is what blockchain offers. So it's a win-win at the end of the day, especially when talking to clients, when interacting with their data. And sometimes not sometimes, when you think about it, 99.9% of the time data is confidential, right? In the case of businesses, this is where blockchain can help. Moving on to the 17th question, it says, what are blockchain requirements? See, one thing you have to understand is that blockchain is one of these technologies that took the world by storm, right? Because it is transforming the way we, in fact, send data across networks. And once this innovation started to happen, and since it's open source, many companies wanted to invest their time and efforts into seeing how they can best make use of this, right? So IBM was one of these companies to contribute a little bit of code to what we call as the Hyperledger project. And from what they say, the people at IBM, industrial grade blockchain technologies have multiple characteristics that make it bulletproof. For example, if you have a shared permission ledger in, let's say, an SOR, or what we call as a system of record, and a source of truth, it is made sure that your data can be seen by all of the participating members of the business network with complete transparency and good amount of security as well. And then when you have a common protocol that's agreed by all of the members in the network, right, this means that your network will only get updated, the data in your network will only get updated when there are network verified transactions. No one can slip in any amount of data into your network. It has to come from a verified source, and it will. Now, the third thing that IBM people say is that there's good amount of cryptography that makes sure that your data is even more secure. It is tamper proof. Authentication is required. All of your transaction that happens is 100% with integrity. So there is no messing around with data when it comes to blockchain. So at the end of it, there are many things that make a blockchain structure very important, very rugged, and a practical piece to be used in an industry level as well. So in that particular case, and then coming on to the 18th question is very important, because you have to know that this is a commonly asked question in a blockchain interview. It says, how can you stay up to date with the new and upcoming concepts in blockchain? One very important thing here is that the interviewer is trying to see your interests in the field of blockchain, your ability to learn new things. It may be complex things or simple things, and of course, how effectively can you learn these and use them in a production environment. So make sure you talk about the way that you used to learn new things and how you plan to see if it's right or not for you, and of course at the end of the day, how you plan to practically implement it, right? See, all of the IT concepts in today's world has been put to place to solve particular problems. In the case of blockchain, I think you would know by now, it's security, it's to make sure your data is rugged, and to make sure that no one can mess with your data. Now, to do all of these, how can you practically implement the solution to a problem by working on blockchain? What have you learned, where have you learned it from, and how best can you add value to the person who's hiring to your company? So when you think about it, right, this is what is required as an answer to this particular question. So talk about how you research new things. It might be reading blogs, it might be attending conferences, or whatever it is that takes to understand and learn the new and upcoming concepts in the field of blockchain. Now, coming on to the 19th question, it states, do you have any experiences working in the same industry as ours before? This question is a frequent one, and if you are a fresher, this question might not apply for you. you because you might be just out of college. But even if you're a fresher or an experienced person, here's how you can answer this. If you have any sort of previous experiences either in your college or any sort of internship or any environment where you have worked on a current industry, right? So you can be working on building a blockchain architecture for a hospital, for a social media, or whichever industry that you've just applied to. So think about the company you applied to, think about what they do, see if you have done anything similar. If you have not done anything similar, even though you're experienced, do not say no. That's not the way to answer. One very important thing you really have to know is that you can talk about whatever you have done and tell them how you plan to bring that experience to this industry as well. There are many things where technologies or techniques that can be trickled down from one technology into the other, where they can outshine their previous technologies as well. So in that particular regard, make sure to talk about your previous experiences, all the tools you've used, all the techniques that you have implemented, all the problems you've solved, even though it might be not part of the same industry. And if that is the case, talk about how you will bring about the change and how you will bring about furnishing yourself in a way where you will bring that experience to help this particular industry. Now, coming on to the last question, it says, have you earned any sort of certification to improve your learning and implementation process in the field of blockchain? Certifications are very, very, very important in the field of blockchain, and not just blockchain, in any technological field, right? Because for you as a learner, you will get a lot of knowledge, you will get hands-on experience, you will be trained by professionals, you will become experts, and you will become thorough in all of the concepts that you're learning. But how does it matter to an interviewer? See, an interviewer will want to understand that you're very serious about your career, that you want to build your career in that particular domain that you're certified in, and it shows if you're certified that you have a strong aspiration to learn maybe new things. See, you can be coming from a background of cooking, you might be coming from a background of architecture, from marketing, whatever it is into the world of blockchain. If you are certified by a reputable firm, it means that you have put in your time and your effort to learn new things. This shows that you're an effective learner and that you have a passion to go about doing this. So it's one very important thing that whenever you talk about certifications is firstly list all the certifications in a very quick way, telling the interviewer what you have done. And instead of talking about what these certifications are, please talk about what you learned from it and how it's been helpful in implementing a solution to a problem. It might be that you have worked on practical use cases, it might be that you have worked on industry level case studies, or whatever it is. Do talk about how you have driven value out of a certification program. A certificate is something that you can have for multiple purposes, and the most important thing is that you use it to solve problems that we have today, right? So in that particular regard, more than talking about what certifications, talk about how you've used these certifications.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below.